Hey, good morning, all. So, hope you had a wonderful keynote session on track one. So, we are going to start with our sessions on track nine. So, starting with the first session, fairness assessment using fair learning in Azure machine learning by Dia and Ansri. So, without wasting any much time, I am handing over to your session speakers. Thank you and have a good conference. Over to you.
Thank you, Amal. So let me go ahead and share my screen. I hope my screen is visible to all.
Yes, it is.
All right. So thank you for the warm welcome. And on behalf of ASCONF, I welcome each and every one of you to Azure Community Conference 2021. And I would like to introduce ourselves. I am Dializa Vargas. I'm a cloud engineer at Deloitte, and I'm a director to an NGO called PIHIA Foundation. And today I also have along with me my co-speaker for the session, Anushree S., who is also an AI engineer, and she's a director to our organization called PIHIA Foundation. So today we are here to talk about fairness assessment using FairLearn in Azure Machine Learning. I would like to start by throwing a very simple but overly used question. How do you all start your day? Mine definitely starts with my day defining a decision whether to snooze my alarm or not. I bet you all be making decisions small, big, silly, crucial, right, wrong, all throughout your day. And in fact, it is a result of these decisions that we live our lives. According to a cover article of Inc., it is told that an adult human on an average day makes like 30,000 decisions. And no wonder why we all feel the decision fatigue at the end of our day. Ever since computer science developed, we have been trying to make the systems do part of our jobs, and today we make artificial intelligence take up the decisions too. Artificial intelligence has been an integral and inevitable part of our everyday life today. And from your face recognition in your mobile phones, replies in your mails, recommendation systems on your video platforms, or credit decisions, fraud preventions, and a lot more can be added to this list. Today, almost 50% of the business organizations all around the world admit that they use AI in their business. Among the other half, almost 64% of these have already invested more than 20% of their income in AI for their organizations. With such a huge impact on the decisions that are made for the world, the last thing that we would expect is a fallacy in the decisions made by AI. But on reality, the truth is our AI algorithms do make mistakes, they make biased decisions. They find the very reason why they were created in the first place. The issue of bias or the lack of fairness in the decisions made by AI never came into limelight until it was because it was resonated much with the decisions made by humans. Because yeah, humans are also biased. Of the plenty examples of AI bias, here are a few of the very important and classic examples for the lack of fairness in the commercial platforms. Of which the first is Amazon's recruiting algorithms that dislike women. This happened because the algorithm was trained using a data set that predominantly covered the resumes of males, which is kind of like obvious in a male dominated industry. But the lack of diligence of being inclusive caused the algorithm to eventually degrade the resumes which contain the word women. But kudos to Amazon, upon realizing this, the algorithm was scrapped out in 2018. The second example is Compass. The very famous case study of fairness of AI algorithms, Compass, is an assistive software used to predict the risk of reoffending of the criminal defendants. This algorithm did have a leniency towards the whites over the blacks, as a result of which the blacks did face a setback of being highly accused of reoffending and giving the clean sheet to the whites. And the third example is the LinkedIn image centering technique, which was biased against the people of color. LinkedIn was able to center the profile picture of white people while it was not done properly for the people of color. Not to mention the fallacy in the blurring of the background of the brown skinned people. But yes, this was also recognized by the end of August 2021, and they released LinkedIn Fairness Toolkit to reduce the bias in different features of the platform. In short, bias in artificial intelligence algorithms is common, and the bias is still, and the world is still in the process of mitigating it. Will we ever be able to be free of bias? The answer is quite ambiguous. In the process of mitigation, it is important that we understand the root cause of same, which is fallacy of training data. The use of training data with only limited demographic group with extraordinary characteristics can be a reason to this. The insufficient inclusive data can also be a reason to the bias learning in the models. Whenever human beings meddle with the training data, machines tend to be biased too. On the other side, this is something that we actually can control. And when people started to think about it, here we have Fairlearn package. Fairlearn is an open source community driven project to help the data scientists improve the fairness in the AI systems. This Fairlearn was integrated into the Azure machine learning for easy access. This Python package understands that there can be societal as well as technical aspects that shape into who might be affected or harmed by the AI systems and how we will be affected. And it encourages us to think the bias as a societal, social technical to use the metrics and algorithms of Fairlearn while considering the AI's broader societal context. There are majorly two broad components to Fairlearn, which is assessment and mitigation. Assessment contains the module called metrics, which is used to assess fairness related metrics for the model. It also has a dashboard that provides a visual way to compare the metrics among the models. And the next is mitigation. This part of Fairlearn makes use of four major algorithms to mitigate the bias that is assessed in the previous module, which is exponential gradient, grid search, threshold optimizer, and correlation remover. Let's get more deep into assessment. So as you can see, assessment it helps in identifying and displaying high level and detailed views for assessing which groups are negatively impacted. In simple terms, a model is fair when it treats different groups of the same dataset equally. If it shows an accuracy of say maybe like 60 percentage for one group, it should be showing the same accuracy of 60 percentage for other group too. Maybe for example like whites or blacks, or maybe like males or females. It is not just the accuracy or score, but there are plenty of other features also. For example, like equalized odd ratio, max difference, false negative rate, mean prediction, and a lot more, which we can all combine into a dictionary called metrics. It contains all the functions that you would want to run on your dataset among the differentiated subgroups. Here we come into the concept of metric frame. So metrics frame is a beautiful function that helps in doing this, that picks up each of the parameters as shown. So here, as you can see, metric frame has a lot of parameters, of which the important one is the sensitive features. So sensitive features is a vector, or it's a matrix that contains the column names that the system designer should be sensitive about. That is, if an estimator should check the fairness before and after dropping the sensitive features to see their influence in the functioning of the model. For example, gender or race, or across which you want to find the metrics. But hold on, this is not the best part of Fairlearn. The Fairlearn goes ahead and gives you a whole dashboard that you can get as a widget in your Jupyter notebook. It gives you a lot more information in a graphical and statistical way that are way more understandable and comprehensive. Here you can see the output of a dashboard, that is a Jupyter widget, and you can see in our data set there were two subcategories, which is male and female. When you compare the accuracy of the results in male and female, 79.7 percentage is provided for males and 92.1 percentage for females, the accuracy. So there's a disparity of almost 12.4 percentage in this accuracy, which means the data set is, or the model has been having a bias of almost 12.4 percentage. So now we have assessed the disparity in accuracy or the bias among the data set, the next step is mitigating this bias. So, for understanding how we can mitigate this bias, I welcome Anushree to continue with the presentation and to explain how mitigation is done.
Thank you, Dia, for the introduction. So I'll be sharing my screen. I hope you can see the screen.
Yes, we can.
Okay, thank you. Thank you for the confirmation. So, so this far we have seen how to get insights from the data set and the model that we have created using our dashboard that is given by the Fairlearn. Now let's look at how to make the model unbiased by actually training it on a biased data set. And that is what mitigation is all about. So let's glance through some of the terminologies that we'll be using before discussing those powerful algorithms. So one word that you'll be hearing a lot during this discussion will be the sensitive attribute or the protected attribute. It is simply an attribute which should not be the basis of decision making, and this can vary upon the use cases. So some of the protected attributes are race, gender, nationality, socioeconomic status, and so on. And these can be a protected attribute or not, depending upon the use cases and the institutions or the industry that are using them. That's the model. So one question that pops to everyone's mind when they hear suddenly about the protected attribute and the AI fairness is this: why not just exclude this protected or sensitive attribute from the dataset altogether? So the thing is that fairness through blindness is actually not a wise strategy, because there may be other attributes in the data set that can actually be correlated to this particular sensitive attribute. For example, let's say that in a data set about a person, they are having data like the race or the zip code. So the race can be correlated to the zip code because some communities tend to live together in the same area as a group. So even though if we delete the race as an attribute from the data set, we cannot actually delete the kind of correlations that is created due to the attribute race. Okay, so this is why we need to introduce some metrics. So as a definition of bias, in short, we can say a decision which shouldn't prefer one group over another is a bias, and that is exactly what or how statistical parity explains bias as. So here, X is the sensitive attribute, and X is the whole set of attributes of related to the data, and H is a classifier. Coming to group fairness, that is a fairness when it comes to different groups in a data set. The fairness criteria that we apply is called demographic parity, and it is one of the most commonly used fairness criteria when it comes to classification problems. If the use case is resume shortlisting, imagine, and the sensitive variable is gender, so according to this criteria, irrespective of the gender, both should get hired equally at equal rates. But applying this leads to some other various problems. For the major thing is the major problem caused by this demographic parity is sometimes when we try to give justice to a group, when we try to unbias a group, it violates the individual fairness. So, how does it violate the individual fairness? This is because if we just assume the case of resume shortlisting, if we are actually hiring both the genders at equal rates, irrespective of their gender, some individuals who might identify themselves as male may face certain biases. Another scenario is an individual can belong to multiple sensitive groups or attributes. Maybe that doesn't apply to gender, but when we consider other things, maybe a sensitive attribute like socioeconomic factor, an individual can belong to multiple subgroups. And another third case why demographic parity not always works is that when we try to unbias some sensitive attribute, it may cause violation of fairness to another sensitive attribute. So that is also a case. And thus, we have another metric to ensure the individual fairness, and that is equality of opportunity. This ensures if a person is truly qualified for the outcome and being in the protected group should not adversely affect that particular decision. It is concerned with treating fairly those who are determined to be worthy of acceptance. It is not concerned with rejecting people fairly across protected group. That is, true positive rates and false positive rates both needn't be equal across the protected groups. And thus, we come to FairLearn, which beautifully combines all these concepts into these easily accessible packages. And the first module being Threshold Optimizer. It is a post processing module and it operates on a predictor, not an estimator. It actually operates on a predictor. And all the algorithms that we're going to discuss, all the modules that we're going to discuss, operates on a on classification problem and regression problem, and provided that you have a fit and a predict function. And its output is adjusted to fulfill parity constraints. They learn how to adjust the output from the training data. Next, and most commonly and widely used, is grid search. This is basically employing a trade off between the accuracy and the fairness. The basic idea behind the selection of a best classifier, as we all know, if you're actually training a classifier, our only criteria, or maybe the major criteria, is to reduce the error of the predicted value. Then we try to include our concept of fairness or the definition of fairness into it, the finals for this final selection of classifier. Let's assume we are choosing a classifier H from a family of classifier C while satisfying some fairness constraints. From the set C, the best classifier is selected using some relabeling and reweightings. So this selection is made on the basis of some fairness metrics like demographic parity or equalizing odds, which is based on the problem statement, of course. So the next one is the correlation remover. The objective of correlation remover is to filter out the correlations in a data set using certain approaches or using certain approaches that actually changes the data in the original data set. It actually changes the original data set. For example, earlier in the beginning, we talked about how the race is correlated to the zip code. So these kind of approaches are used when we have those kind of data. So linear transformations are applied on non-sensitive features to remove their correlations with the sensitive features. This is done by using a linear regression model, and we fit these non-sensitive features centering on the sensitive features. And then the sensitive features are dropped altogether. But the thing is that we can also select how much we have to filter out using a parameter called alpha. As you can see here, alpha, if it is alpha is 1, it drops it altogether. Otherwise, we can control it how much we want to drop it. So now let's see how we can actually employ this fair learn to a particular data set. So here I have a data set which contains attributes like age, gender, internship, CGPA, all sort of things. This We use this data to predict whether the person, this is actually the data of students, and we are actually trying to predict whether a particular student will get a college placement or not. This is a very popular data set. So the first thing that we're going to see is whether this data set is biased or not, whether the model that whether the model that or the classifier that we have created is biased or not, whether the output it creates is biased or not. So that is where the dashboard comes into play, where we have to just analyze all these sort of things. So when we actually run the dashboard, what happens is, so this is the first thing that comes up when you open the fairness dashboard after you call it, and then you click on the get started. So this is one of the major step. So first thing that you have to do is select the sensitive features that you have to taken care of. So here, of course, the sensitive feature is gender, because our objective is to know whether this placements are having some sort of relationship or correlations with the gender, or is the decision of being a male or a female affecting the placements or not. So we select the sensitive features, and then the next step is to select the performance metrics. And now we are actually selecting the accuracy. You can select any of the features that you want to take care of, so like precision, recall, anything. So the third step is to select the fairness metrics. So as here we are concerned with the group fairness, that is here we are having two groups, that is male and female, and we have to evaluate the group fairness. We are actually selecting demographic parity difference, which is actually the best for comparing fairness between the groups. So after you select all this and you run the dashboard, this is the result that you get, and these are the insights that you get. So as you can see here, when it comes to male, you can see a greater number of false negatives when it comes to male, and also a less number of false positive when it comes to male category. So this may not be what we expected. So actually what we can see is the classifier it a bit lenient more towards the female category than the male category. So we can say that with a even though it is a very slight percentage, the category who identifies himself male is at a slight disadvantage. This can differ according to the sampling of different population. So this is what we have right now. This is the situation of the data set that we have and the predictions made on the basis of that. So also you can see that when it comes to selection rate, males have a higher selection rate than female. And also when it comes to accuracy, males are at a disadvantage with, even though slightly with just 1%, the accuracy rate is a 1% low for male. So here what we have just checked, the fairness metric right now that we have checked is the equalized odds, and with by clicking on that drop box you can select various other fairness metrics and just compare all the different answers. So the next step is, suppose we so currently the data that we have is not that greatly biased. So suppose we are having a greatly biased model, and our training data set is also greatly biased. So what we do now is, we now understood that we are having a bias. So what to do next? So next is the step called mitigation. So, as I said before, grid search is the mostly widely used module for this, and we are also trying to use grid search for this. So, what grid search does is, it actually relabels and reweights, and it creates a series of predictors or models that we can use from. So, basically, it creates a series of model that we can select from. It gives you certain options, okay, and then finally, it gives you a a graph with mappings from accuracy versus demographic parity difference that we have selected as the fairness criteria. So basically, here you can see five different models that grid search have given you from a hall set from the hall distribution, and you can actually select by clicking on each of those dots. You can actually understand which is that model. And for example, for a particular use case, you want a slightly more accurate version of the model than an unbiased version. You can select the model with a greater accuracy, or sometimes maybe accuracy, you can compromise on accuracy but you can never compromise on biasing. Then you will select that kind of required model. But somehow for this particular use case, the best model that the grid search has given is the one with the greatest accuracy and the one with the least demographic parity difference. So that is kind of a win-win situation. So that is one case. So this is how you actually use grid search. So, as you can see, we were able to reduce the bias to some extent. We might still have the bias, which is quite understandable. You might still be able to see a window of bias because it is not just dependent on logical or statistical point of view. It also reflects societal and behavioral traits. Psychology defines almost 180 type of biases that influences human brain while making each decision. Consider putting that into each of the decisions that we make in a day. This influence of the bias starts from preparing or selecting the questions for a questionnaire, and or deciding on the population or sampling set for creating a particular training data. And obviously the results that we expect are also biased. As we all know, things that are under control right now is the algorithms and the data that we can select as a human being. So, the deeply rooted influence of historical and cultural bias on the data is inevitable. Until and unless we start introducing synthetic data into the original data set and in order to rule out existing bias. Still, considering all the facts, AI without having a biased algorithm is not too far, but not too near too. With a deliberate efforts from human side and technical involvement into the field of AI will help us achieve an unbiased science tomorrow, which we humans can also learn from. Thank you, and I also thank as a Conf and Azure community for giving us an chance to present our views on the AI fairness system. Thank you.
Thank you, Anushree and Lydia, for this wonderful session. So, as of now, I haven't seen any questions. So, I have one question for you. So, we have seen this. This is one of the most often heard about question, right? Regarding to it, adding AI capabilities to your application, right? How much accurate it is, or is this going to be, or are we going to achieve that kind of human relatability very soon, or something like that, right? This question will always come to our mind. So according to you, how are you seeing, or what's your viewpoint on this particular thing? Are we
And
there, or
like we cannot actually assure 100% unbiased system anywhere, because all of us are biased, and we are creating that algorithms, and of course that tend to be also biased. And also, as I said before, there are two kind of fairness that we are talking about. There is something called group fairness and individual fairness. So if we are talking about a group fairness, like let's talk about whites and the blacks, men and women, if we are trying to give fairness to that particular group, the thing is that the individual fairness goes off. Some people will be at disadvantage even when we are giving this group fairness. That comes at every social aspect. When we give a particular group certain kind of advantage, there are certain individuals who also get disadvantage. So maintaining this group fairness and individual fairness is the difficult task that we are facing right now at the right.
Adding to
uh,
that, I would like to also add that, like as we told already, like the way humans behave is what the algorithms also represent. So how far we will be able to be unbiased, that also depends on the results that we are providing. So like, let's hope for a better tomorrow where human beings are less biased, so does our algorithms too.
All right. Thank you, Anusri and Dia. We are almost finishing by time. So again, I would like to thank you on behalf of Azure Community Conference for your willingness to take a session. Thank you. And
Thank you so much from our end also.
Thank you. Thank you.
so next up, we have Rahat here for our
Hey,
second session on idea generation to AI proof of concept using Microsoft Azure AI service. So I'm handing it over to you, Rahat. Have a good one.
thank you, Amal. Thanks for inviting me, and really excited to give this talk. And welcome everyone to my presentation. Today's topic is idea generation to AI proof of concept, designing using Microsoft Azure AI. Uh, it's a 30 minutes lightning talk, so I didn't put any demo. It's more like we will talk about like why AI is failing if you are designing something, because we will show some statistics based on that. We will show the key reasons and how can you fix the way you're doing it. You can do it better, get the most out of your AI development, everything. And as I said, it's a 30 minutes lightning talk. At the end, I will also show what Microsoft Azure is offering in terms of AI services, so that you can see how can you build your team, how can you leverage all those benefits that you can get from Microsoft Azure. And yeah, it's almost 1 a.m. At my place. I'm based in Montreal, Canada, and hope everyone is watching it from different parts of the world. Some are having, I would like to wish good morning, and to some, I don't know, maybe a good night or like something else. I jump into the detailed presentation, my name is Rahat Yasir. I work as the Director of Data Science and AI at Isaac Instruments. Uh, it's been a while that I have working in the data and AI industry in different countries, and yeah, I'm also a Microsoft MVP. It's been 7 years that I'm an MVP in artificial intelligence. Okay, before we jump in, what is happening in the market? Because there are like so many buzzwords, there are like so many good and bad stuff that we are hearing regarding in terms of data and AI. Is it true? So that's why I put some like a quick stats. So if you just look at the stat, you will see by 2026, global AI market will be $299 billion, and in 2020 it was only $29 billion. So you can see the exponential growth of the market in terms of like data and AI, and the data and AI market expanding at a compound annual growth rate of 40.2 from 2021 to 2028. So this is the right time to invest your time, money, skill in this particular domain. And because of COVID, we have seen that almost all the industries their growth and projection, estimation, everything got hampered. But in terms of data and AI, it's a bit different, because we have noticed that we need more automation. We need less human interaction in terms of like a lot of low level labor work. So that is one of the reason why we have recently noticed that data and AI is getting more investment in terms of like growth and opportunities. So these are some of the numbers that shows and proves that data and AI is growing, and how big it's going to be in next few years. But I would like to show another stat as well, that 87% of the data science projects never make it into production. So it is by VentureBeat survey of 2019, and that is also true. So now you can ask like, okay, if the market projection is growing that much, if the market is growing that much, all those new investments are coming, but at the same time 87% of the projects are failing. It doesn't seems right. So it depends actually, because those 87% projects, it is R&D. So those 87% projects that are failing, they're failing because because of lack of proper return on investment strategy, proper infrastructure, proper project planning, proper resources, proper hiring, proper way of doing AI. So if and those 13% that are surviving, they are actually making so much money that that 87% of failure rate is still looking very small in terms of like market projection and everything. So in today's talk, we will mostly talk about how can we minimize that 87% number so that the data and AI investment that you do or all the project that you are thinking to build will go in the right direction. So, before I go in detail, we need to know how AI projects are often starting because this statement is very related to the 87% of the data and AI project failure. So a lot of times what we have seen is management worried that everyone else is already using AI, so they rush into AI related development without having proper plan, proper strategy, proper development, and proper platform as well. That is one of the wrong step that they take. Second thing, we also see that executive decides to launch AI project because of market hype without identifying whether they are AI ready or not. It's not like everyone is AI ready. Before you jump into your AI investment, you need to do a lot of other things. So that is another lacking. uh, PM or PO, product manager or product owner, are looking for places to plug in AI. So they have their roadmap for product to grow, but because of the market hype, a lot of times they forcefully add AI feature even if they don't need to. Because every time you add something, you need to hire new people, you need to handle with more data, you need to deal with more computation. AI is not cheap; it's also pretty expensive. So that is another reason. And management jumps into hiring expensive data science and AI teams and starts to build AI models and tuning AI models without validating data, defining ROI, possibilities, cost, scope, etc. So there you need to follow the proper life cycle to complete the AI loop, and it is not a linear approach; it is an iterative approach. So if you're thinking, okay, you want to invest your resources, your time investment into AI, so what is the right way of doing it? So the right way of doing it is, before we start, we should ask ourselves three questions or the to the management. Is there a problem? That's the first one. Second one is, can machine learning help solve it? Third one is, does someone care? Because first, first of all, you need to identify the problem. You need to listen to your users, clients, take interviews, identify pain points, and how they are solving it, and how can you use automation or AI-related features or learning from previous data so that you can design something. So identifying the problem is the first step. And then when you design it, then you will have the, can ML solve it? Because machine learning is not magic, it cannot solve everything. So you need to identify it is solvable or not. And also machine learning is not like deterministic. It's the result we get is probabilistic. So the result could be, accuracy could be 80%, 85%, something like that, 90%. So we need to know that this 85% accuracy is acceptable or not. You also need to it's great if you can connect or associate some sort of like dollar value with the outcome, so that the management or the organization will be more motivated to solve this problem, because they will see direct impact on their organizational growth, because with this AI you are saving this much dollar. And does someone care? You need a business sponsor, someone who will sponsor, someone who will take care of the AI, someone who will preach that AI to your customers. So in between these three bubbles, which is identifying problem, ML can solve it or not, and business sponsorship, the middle part that you find, this is the actual opportunity for AI. And it's not like there is an opportunity and all the opportunities will be solved by AI. Initially you may have to solve it with very basic rule engine or very basic pattern or regressional models, that kind. And again, as I said, it's not a linear approach, it's a iterative one by one approach. But one of the thing that we I want to talk again, if you want to use ML and AI, the moment you find out that sweet spot, the opportunity, you also need to know the reasons of using AI. So uh, there are like two ways again the seeing it. One is a bad reason, second one is good reason. The bad reason is because the management wants to, because it's cool. That is a really bad reason, because there are chances of like a higher failure rate if your only reason of using or incorporating AI is driven by some cool or hype. But the good reason is because it adds long-term business value for your client. uh, it is bringing different kind of automation, it's giving you predictive capability, it is giving you prescriptive reasoning, it's also giving you personalization, so that all those customers user get like a personal feel, so and more interactive. So that could be the best reason of like using AI. So when I say that like iterative approach of getting long term value, so how does it look like? So from ideal ML implementation, it could be for POC, for full project or MVP, for any sorts of like scope of implementation. When you start your project for data and AI, you just don't get into deep learning or big data model or something like that, because you need to identify whether you have the data or not, the data is ready or not, you have the platform or not, what is the how much you're going to invest, all the data are annotated or not. So it's always ideal to go for heuristic model, which is like the first one, heuristic baseline approach. Once you set it, and this approach will also help you to annotate your data so that you have the data later. You can use that data for different kind of machine learning model training, and the complexity of those models will be iteratively higher than the previous one. And if you ask, okay, what is heuristic baseline model? So it's a method of solving problems using a simplified set of rules based on past experience, hard coded business rules rather than machine learning for now, so that you know what you are doing. You know the business understanding, and then you're just using the business understanding to add it to the machine learning approach through feature engineering, through proper outcome, through like different ways of like handling it, and also having proper realistic expectation as well. And it is also easier to create and maintain, and it is minimal cost effective and it has a high interpretability as well. So this is the approach which will ensure that the POs that you have started will give you some like good return, and it's not gonna fail. But again, you also have realistic expectation from your approach that okay, these are the things you need to do before jump into like expensive AI models. Then, what are the challenges you will face in terms of like machine learning POCs or projects? Uh, First thing is, as I said already, the probabilistic results rather than deterministic. The outcome we get from machine learning, the prediction, it is always probabilistic. It's not deterministic. So we need to know what is good enough and how to define good enough. So if you have designed a model that is detecting between cat and dog or some kind of classifier, so it is not going to be 100% accurate. If it is 100%, then there is something wrong, it's over, there is overfitting is happening. So it will be something 97, 98, 95, 80, 75, whatever. So you need to have the justifiable acceptance number, what is good enough, so that for 1% you're not, you don't spend that 90% of your time. You have the good enough approach threshold, you do it, it's done, and then you continuous your iterative training. And as I said, you need to know when to stop and the training approach, and let it use by your users. And also the art of model development, variance of model output, because you are dealing with a lot of data, that is also incorporated with that one. Higher technical risk. Yes, obviously, because the machine learning is just every the success factor completely depending on the data, the core data quality, the how the data is handled, how the data is cleaned, the feature engineering. Everything is like 70% of the your model's accuracy depending on proper feature engineering, and 100% is depending on good data, proper data, and also models are limited. So. There are different models that can like that are used for changing the result of values or like finding different kind of pattern, but end of the day the models that we use are usually predicting a number or doing a classification, or like multiple models are combined together to take one single decision. So models are limited, there are certain limitations in the model, so it is not like a uh, like uh, like just train one and done. No, you also need to keep track of your like retraining, model monitoring, that kind of aspects too. And there are lots of like upfront work, because you will have to do robust feature engineering for good result, and you also need to do all those like data correction, data processing, data cleaning, and those things. And for all those things that I just mentioned, you need lots of change management, because you need to change your you need to bring some changes in terms of like the mindset, user workflow, because the way we see software development life cycle, the data and AI life cycle is different. I will talk about that one later in my session. So these two, SDLC and data and AI life cycle, needs to incorporate with each other, so that there is no unrealistic expectation within this AI development approach. And one of the most important part is ethical obligation, because sometimes it looks like a black box, that you are just sending some data and it's telling for an insurance price prediction. You're just sending some user data and it's telling you that the insurance premium should be $30, $50, $10, something like that. So you need to know that it is ethically correct or not. You are not charging your user anything extra. You need to define data bias, identify whether there is any data bias or not. You need to make sure that the privacy, security, and sensitive information is always secured, and it's out of touch for all the other people outside of your or outside of your organization. You're validating all the ethical issues and implications. Just before this session, we got to see that all the fairness, AI ethics, and all those things. So we need to validate those things, and also we need to build model trust, and model needs to be explainable and fair. So you cannot just build a model and done. No. So you have already got the idea that okay, to do it right, we need to do a lot of things, like from data cleaning to platform development to doing the model development right, plus also a lot of managerial work. So you can also ask, what is the best way to design the machine learning or data science project management, so that we can make sure we don't fail. So this is one of the like oldest method, but also like one of the most proven and effective method in terms of data science and machine learning project management, which is we call it crisp DM data science project management method. There are like 6 steps here. The first one is you need to identify or understand the business domain, or business, having the business understanding why you are having it, why you need to do the modeling, what is the return on investment. And also during this phase, you need to ask those 3 questions, that is there any problem, what is the problem, identifying the problem that falls under this one, can ML solve it, and is there any business sponsor. The moment you get the right answer, then okay, you get into the data understanding. You need to see that you have the data or not. Then uh, after finding all the flaws within the data, you need to prepare your data, do all the processing, changing, cleansing, feature engineering, so that you can actually design AI models based on that data. You design all the model, like selecting the right model, selecting the right domain, training the model, and then you get into evaluation. If you are satisfied, okay, the accuracy rate you are getting is right, then you will get into deployment. If you're not, then you will have to go back to business understanding to go through this it process again. So in the business deployment section, you deploy your model, but at the same time, when your model is doing all the prediction, you also get the customer feedback, so that you can like continue this iterative approach and update your model, do all the retraining and model monitoring as well. So, okay, when you are designing the data and AI model from an organizational point of view, so you need to know it's just like uh, you are just like hiring a couple of data scientists, throw some data up, do some get some public data, and design some POCs, and it's done. No, you will get a lot of return on investment right away. No, it's not like that. From an organizational or enterprise point of view, when you design like you when you want to get the most out of your data and AI strategy, you need to go through this pyramid scheme, where it will ensure maximizing your return on investment so that your project doesn't fail. Plus, also you go towards your destination. So the first step of getting the most out of your most ROI of your data and AI investment is collecting the data. So you need to have proper data lineage. You need to bring the data, store the data properly. You need to have proper data lake. You need to have proper data zones, so that you can do all the data processing and the data is ready for consumption and curation. And the second thing is we see is information. Here we just have the raw data, but we need to find out different kind of like value from the data based on different insight, different KPIs. So that's where you identify informations based on your from your data, and you also define different kind of POCs which you develop during the information section. After doing that one, you put into go to get into the knowledge section. In the knowledge section, you like enforce data management, data governance, proper process, so that the data lineage is there, data catalog is there, data ops, ML ops, all those things that we talk about these days, they're already implemented, so that the POCs that you have designed in the information space are ready to interact with your users or customers, so that you can start to get some revenue. But in this phase, you will also notice that there are like you have made a lot of mistakes, and you will fix those mistakes in the understanding phase, which is reiterating based on all the learning that you had in knowledge and understanding. And you will ensure your return on investment, use your experience, so that you get the actual insight from the data that you have collected in the first section, and you make your organization data centric and AI driven. So it is an like a iterative approach, and you need to complete this loop to move ahead. One of the thing is very important in terms of like data and AI related stuff, is you need to make sure that you have all the tools, you have the platform, you are getting all the support from your tools and platform. So that's why data and AI platform selection is extremely important. Your cost, your timeline, your success, delivery, resource, depending on this data and AI, like selecting the right platform. So you can select platforms like Azure, AWS, GCP. It's an Azure conference, that's why I will obviously emphasize on Azure. But at the same time, you can choose other cloud vendors. But at the same time, you can also select one of the Azure, like Azure or AWS or this kind of cloud vendor, and replace a few of the tools within this ecosystem with SaaS products. But you need to know, like how would you define your ecosystem, whether you will be cloud platform lock or product vendor lock. So it's like a very classic conflict. You can also select I have seen in different organizations where they also select multiple cloud platform. If you are from like a big organization, then that makes sense. But at the same time, you need to make sure that you don't while designing your data mesh, you don't get into data mesh, which is way more expensive. You need to hire all those uh, like people from different resources and experiences of all those technologies, and it's also hard to get find in the market too. And also they need to talk to each other, so that The more data you move, the more computation you involve, the more new tools you involve, the cost is gonna get increased too. And an ideal decision is to choose the data and AI platform, which will have both the data and AI components. And it's always better not to to use those low code and custom tools for data and AI for maintenance and upgrade. So I will just quickly take a look at like a few more slides where in a data platform, when you're doing your POC is not just about like doing a small AI training 10 line of code. No, and you need to think about like a bit larger scale where your POC needs to get into production and make money. So that you need to ensure a lot of other things in terms of to make your POCs into production, you need support for both the data and also support for both AI platform side. So for the data side, there are certain amount of like components that you need to have in your cloud platform. First one is data ingestion, because you will need data to train your model. So sometime you will ingest the data in real time, sometime based on event driven approach. Your platform needs to support that. You also, when you ingest the data, you will store them into different different storage zones. It could be bronze zone, gold zone, silver zone, that kind. You will also deal with structured data, unstructured data. So you need to bring your computation as close as possible to the data store, so that the moment you get the raw data, you store it. You also do all the apply all the hard rules of your organization, and then put the data into another zone, could be silver, and then apply all the uh, gold business rules of your organization and put the data in your gold zone. You also need to have proper data visualization or reporting tools, while you need to have proper data serve and enrich a process too. That will make ensure all the data ops, ML ops, BI, data sandboxing, data marketplace, ML use case, that kind of options. So when from a complete person and lifecycle perspective, that's how we see in the data side, where business leadership set the goals, and then we have data architect, they design the architecture, then the data engineer design the data ingestion pipeline, and then the data modeler is the one who do the modeling on the data, so that the data is stored, data is properly there is proper schema on that one. They work with the reporting and visualization person, so that you have proper Power BI or BI analytics, so that's kind of like reporting tools that is giving you the full visualization of the data. And data analysts and scientists are working with the data at the end too, the moment the data is available. So that's how the data ecosystem looks like. And from the Azure perspective, all those data ingestion side from different sources of structured, semi-structured, streaming, or even data services. It supports different kind of ingestion process, whether through Event Hub or IoT Hub, or even like Synapse or ADF pipelines. The data store is supported through Azure Data Lake Zen 2. You can store both structured and unstructured in different formats. You can also have proper warehouse, like data warehousing in Synapse Analytics, and all those data like compute or data processing that I mentioned are there as well. And at the end, you can add your machine learning side, and also for the serve, you have the Power BI, Cosmos, of that kind. So you are getting all the full ecosystem in the AI data side from Azure. And also from the same thing we see in the AI lifecycle and persona as well, where the business leadership set the goal, data engineer gather and prepare the data for the AI modeling, data scientist is the one develop the model, ML engineer works with the data scientist so that we can deploy the model in the production, and app developer and ML engineer works together so that they can connect the AI model, which could be a RESTful API or something like that, with the web and mobile app. And IT operation is the one who is supporting everyone. And at the end, data scientist works again for data model monitoring and maintenance approach. So from the Azure perspective, we also see that we are getting all of them that we need. We get a lot of pre-built AI because as a new organization or any organization, if you don't have enough data for common use cases, cognitive service is giving you that approach. You also get all those like frameworks, bot framework, Azure Machine Learning Studio, or Azure Machine Learning like a platform for custom AI application like model development using AutoML or Jupyter Notebook or even like AML Designer. You also get all the deep learning frameworks that you need coming with this framework, Azure AI, and the data or the full data support is there, and along with the full compute, which is Spark, data science virtual machine, batch AI, Azure Community Service, and IoT related stuff. So that's
Yeah.
it. That's
Yeah.
how I see you can take your POCs to production, and there are like lots of benefits you get from the Azure. And thank you for inviting me. And that's all about my presentation today.
Thank you, Rahat, for that wonderful session. So as of now, we didn't got any comments so far. So if there are any questions, I'll post in the chat box. In the meantime, maybe you can share the link of the resources where these tools can be downloaded. All right.
Perfect. Thank you
And
so much.
since we are almost on time and we have next set of speakers here. So anyway, thank you for joining and delivering the session in this year's Azure Community Conference. Thank you
Thank you.
again. All right, next we move on to our next session. It's on building real-time solutions with Data Explorer. But we have here is Mani and Richard from Elastic Cloud to take you through the session. Over to you, gentlemen.
Morning, everybody, at least this morning for me. So thank you very much for inviting Manny and myself. We are going to talk today about real-time data solutions in Azure Data Explorer. I think the way that we're going to run this session is we're going to introduce ourselves, talk about big data in general. You heard a great talk earlier about data pipelines and also the roles of people in teams, the roles of data architects and data analysts and data modelers, and where they all fit in the scope of data. What we're going to talk about today is a specific framework called Azure Data Explorer. It's getting to be incredibly popular. It's got multiple names. Microsoft now call it Custo, and we'll be doing quite a bit of Custo query language today, which has now become the common querying language across Azure. So if you haven't tried it before, hopefully you'll learn some new things. So I'm going to just share my screen now. And wonderful. Hopefully you can see that, and it is fairly seamless. Okay. And of course, thank you for our sponsors at Microsoft and EY. Today, it's both myself, Richard Conway, and Manny that are presenting, and I'm the CEO of a company called Elastic Cloud. Manny is one of our lead cloud solution architects. A little bit about me and Elastic Cloud. I'm the founder of the company, and I'm a director. We're a UK cloud analytics data consultancy, but personally, I'm an Azure MVP and a Microsoft regional director. I've been using Azure since the start of Microsoft's journey in the cloud, so I've seen it change from very, very early days from, some of you may remember RDFE, the Red Dog front end it was called, to the Azure Resource Manager these days. So I've been lucky enough to be part of the whole journey. And then as has Manny as well. We are Microsoft Azure Analytics Gold Partner. One of the things that we've focused on, and I've really thrown myself into personally, is the idea of open source. We're very, very community focused. So So if you ever find yourself in the UK, come and join a meeting for our community. We run user group meetings monthly. In fact, we've got one on the 9th of November, just in case you're in London, which is for the release of .NET 6. So we've got one on .NET 6 and Azure. Lots of work in data over the years, and also running community conferences, blending Azure and Minecraft so that we can teach kids how to code in Minecraft and a little bit about the cloud. And one of the things that you'll find about me and Manny in particular is that we contribute to several Apache projects. And, you know, I really genuinely feel that that the way to learn about anything and the way to learn now about modern cloud environments is really due to studying open source code. If you are a coder, it really doesn't take long. Look at Spark, Storm, libcloud, Parquet, Flink. All of these underlying frameworks build the basis of what we're talking about today. Azure Data Explorer, what you heard before, Synapse Analytics, Azure Databricks, all of these big data platforms in Azure, they're all founded on open source projects. So if you get the time, definitely look through code. It will really help you understand some of these key features now that we're using. We've got offices in London, Nottingham, Spain, Brazil, and of course India. And a little bit about, just to show our wider presence across the world. So today we are looking at real-time data solutions in Azure Data Explorer. Azure Data Explorer may be new to many of you, so we're going to take you through steps to help you understand some things about big data, some things about big data on Azure, and also really focus on Azure Data Explorer, bring in some demos and just give you an understanding of how you can get started. Just to give you an idea of why I chose this talk, in our professional consultancy, we have a project now which spans about 2 petabytes of data, and we have real-time event hubs now coming in with billions of events a day. And one of the things that you'll find about Azure Data Explorer is that you can blend the sort of pipelines that you heard in the previous talk, where you can take batches of data and insert these into tables in Azure Data Explorer. But at the same time, you can ingest anything from event grid topics and files on a data lake in real time as they land, as well as being able to take event hubs. So if you have an event hub stream of messages, then those event hub messages can feed directly into a table. And within Azure Data Explorer, as you'll see when I talk through this, you can build pipelines of how you transform that data. So it's very, very much an all-encompassing platform. And the reason that it's important is because it can scale to your business. So if you have 1 user, if you have 100,000 users, you can have similar levels of performance because it is linearly scalable, and it will scale to the number of nodes that you need using auto-scale algorithms. So let's talk a little bit about big data in general. The first thing to say is that data is getting bigger. You can see on the left hand of this graph, we're measuring megabytes, gigabytes, terabytes, petabytes. If somebody said to me, I don't know, like 5 years ago, that in my project over the last 2 years, I would have been handling petabytes of data, I would have been absolutely shocked and said, I can't even think that far. But that's the reality, right? The projects that I'm dealing with now have moved from terabytes to petabytes. On the bottom axis, we have something in big data which is very, very common. We tend to call them the 3 Vs. There are actually 9, 10 Vs. When I was studying big data 7, 8 years ago, what I found was that every year somebody would bring out a new V. So I've left the most common there, and they stand for velocity, being able to handle real speed of data. Variety, understanding that you're going to get many different schemas of data and being able to adapt to them. Volume, lots of data, and veracity, ensuring that data has integrity and that it's true. And in the megabyte and gigabyte range, we look generally at things like ERPs and CRM. And as we move into terabytes, we look at that more Web 2.0 data collection, and we'll find that we've got web logs from tools like Adobe Experience Manager. Even things like log analytics now generate terabytes of data. So anything where we're tracking either web telemetry or anybody interacting with the website, we should expect those sort of volumes. And then lastly, big data into our new age, which can be very much telemetry, IoT telemetry. So we could have devices that generate data every single second, for example. RFIDs, we could have spatial GPS. So our phone might ping through an application like once every second. You times that by 1 million users, you have a huge amount of data. Gaming data, streams of blogs and wikis, Twitter feeds, social media, all of these things are absolutely huge, and they need a different approach to being able to manage them. Okay, and you can see there's data of different types there as well. You have free text data. Some of this data, which we call append only, where we just keep a historical record of that data and keep adding to it as well. And as a result of it, if we understand this data, we can make new decisions daily, and decision makers can have a much better impact as a result. So what do we do with this data? So this is just some examples, right? The most important thing is to answer questions, because data in itself, if you leave it, it's just a cost. So we can ask things from a retail e-commerce perspective. For example, why are visitors abandoning their shopping carts? Who are my most dissatisfied users? Are users leaving my site? Why aren't customers clicking on something? What is impacting production quality? If you frame the question in mind, right, then you can come up with a strategy to work out what data to use to be able to answer that question. It's really, really important. And the way that I think generally about data is to think about this from the top down. You'll find that very much in our modern day, there are two approaches. There's the approach of saying, let's have very, very solid building blocks where we'll build data lakes, apply governance on top, then have various data marts so that people can access this. This one group of people do. From an analysis perspective, you have to start with the questions. What data do I need to answer my questions? Okay, and that will be very, very clear at that point. Not what data do I have, which a lot of users do these days. I'm going to come up with some questions. It needs to be the other way around. You need to really think about what you want your data to tell you. So now that we've spoken a little bit about big data, let's think about big data in Azure. So I apologize if many of you have seen this diagram before, but this is a very, very powerful diagram. It's honestly, it is the software pattern that I use almost every single day when I do work. This for me is the reporting stack, the big data stack in Azure. Microsoft call this the modern cloud data warehouse. And I'm going to walk you through this from left to right so that you understand what's happening here. So, so on the left, you have all of these different types of data. You can have logs, you can have files, you can have media, and we can call this data either structured, either either unstructured data or semi-structured data. So unstructured data would be a video file or an image, for example, or a PDF document, whereas semi-structured data might be JSON. It might be something that sort of half describes itself. Then correspondingly, you have structured data. You might have an SAP table, or you might have a SQL table or an Oracle table. Essentially, you would want to ingest both types of things. And one of the key components to do this is Azure Data Factory. And so in our first step, we talk about ingestion of data, where generally the way this pattern works, on a batch, we would ingest, and then from step one, we would land this data. And I heard in our previous talk, we were talking about the life cycle within a data lake of bronze to gold. This would be our bronze stage, where we land this data. It's very, very raw. We've done nothing with it. What we may do in this data is we may do some kind of big data transformation. So generally, from going from point 2 to point 3, we may use a tool like Azure Databricks. Now we may use Synapse Analytics as well, using Spark pools. Generally, my preference is Azure Databricks these days. But in step 3, what we would generally do is we would take our landed data, we might cleanse it, we might put it in a format that's a little bit more readable, and we call this staging. Once we've staged our data, we might curate this so that other users can use it. And as part of that curation, what we might do is we might create something like a star schema, if any of you have heard of that, or a snowflake schema, or any kind of schema in a database, and automatically just import those files into a database or a data warehouse in step 4. Now you can see that there's a couple of arrows to where it says model and serve for step 4 for Azure Synapse Analytics. And that is because you can either have a push model from step 4 and say, I've taken my data, I'm going to push it into a table. Or what Microsoft have done is they've created actually a really good technology. It's been in use for years, so it's very, very well tested, and it's called Polybase. And Polybase is fantastic at saying, let's not use SQL to populate data and add data to a table. And one of the benefits of this is that it really shrinks down the time to take very, very large files, be they in formats like Parquet or JSON or whatever they are, or CSV, and take those files and get Synapse Analytics to read from the data lake. Now, the benefit of this and the difference between inserting data into a Synapse table is that you have to use SQL, you have to go through a front end, and you generally have to do this with a single connection. It takes a long time. And we've come up with techniques to simplify this through tools like BCP and bulk inserts. But generally what Polybase will do is it will not use SQL to insert records into the table. It will allow Synapse, in this case, our SQL data warehouse, to connect directly to storage. And if you have well-trodden partitions, if you partition your data properly, it will literally connect to many connections across storage, and it will read all of this data concurrently. So it will populate your tables much faster. Then we can model this in Azure Analysis Services, AAS it's called, and that will generate the KPIs that we were talking about, and then we can read this in Power BI. On the bottom side of this diagram, this modern cloud data warehouse, we have Azure Cosmos DB, which is a NoSQL database, and that's a way to scale to web applications, mobile applications, and and keep our data in a JSON format to serve it very, very easily for the web. So if we have this pattern, technically we can build any reporting capability that we need in Azure. So this is why you should remember this pattern and brand it on your mind, the modern cloud data warehouse. I wanted to show you this because it offers a more complex view. So that's a very, very simple high-level view, but realistically, you have challenges in any environment. You have the need to put all of these tools into a virtual network and then build things like network security groups, so rules around these, rules around subnets. And you might find that you have different subnets for things like storage, analytics, orchestration, and you will certainly not want to keep your keys in or any secrets in plain text. So you might want to use things like Key Vault. But it's all of these things together which are important, because what they do is they help us to secure our environment. So even though we saw a very, very simple high-level diagram, realistically, everything that we do is going to be much more complex in the enterprise, because we have to make sure that everything is in our bespoke network and not available to people on the internet. And you can see there's other services which are incredibly important, such as data cataloging. Some of you may have come across Azure Purview. It's an improvement on Microsoft's data catalog version 1. And Purview gives you that nice governance capability. And it also has the ability to sit inside a virtual network. And that means that, you know, all of this is closed off to the internet, but it takes rules, it takes an understanding of how to do that. So realistically, in the enterprise, everything that we spoke about is a little bit more complicated because of this. And so I just wanted to also break down some of the tools and the use cases. The ability to use a data lake means that we can have machine learning use cases. A common way to use machine learning is through Azure Databricks. It uses now a capability called MLflow, and MLflow, as well as its internal libraries called MLlib, allow us to version models and to treat machine learning models in the way that we would software. It's a really, really good framework. It works through both Azure Databricks and also Azure Machine Learning, which you can tie together through MLflow. The other way is to use these data science virtual machines, which Microsoft have put a lot of effort into. You can spin one of these up. It has Python. It has different Python frameworks like PyTorch and scikit-learn. It also has frameworks on them such as Dask, which allow you to create lots of different virtual machines, horizontally scaling in parallel, and the virtual machines will just allow you to train data. Then you've got the ability to read data into Azure Search. What Azure Search will do, Azure Cognitive Search will build indexes, and it will allow you to do fast searches against the search indexes, and you can enrich these indexes as you read in all the data from a data lake, and then use a REST API to access it. And then the most common one is the pure reporting use case, which allows you to model data by reading from the data lake. We talked about earlier the ability to use Polybase to read directly from SQL to the data lake, and then to optimize that by building a set of key performance indicators that you can show your users. And then at the other side, you have the ability to query all of this through SQL, Jupyter Notebooks, through Spark Notebooks, or Power BI. Okay, so this is another play, just because I really want to hammer home, and as we sort of move into where Azure Data Explorer fits in, again, all of this data and input on the left, from unstructured to structured data. We talk about ingesting and prepping, and you see here that we've got Azure Data Factory, we've got Azure Databricks, and so now there's two ways here on this diagram that we can ingest data. We model and serve that data in a data warehouse, and then we visualize that back in Power BI. And so if we break these down, there's benefits to each of these, right? For file storage, we can have huge volumes of data. We talked about the 3 V's and volume specifically. There's an incredible amount of SLAs that we can have. We can partition these in intelligent ways using folder names that might associate with business units and timestamps. We can have very, very wide tables in our data lake, and we can use any language to read them. In our data warehouse, it's scalable. We can also pause this, which is great. Synapse has an incredible amount of power. So you click a button, and if you have a very large commitment to Microsoft in what are called data warehousing units, DWUs, then you can do lots of calculations very, very quickly. And then NoSQL, you don't have a schema. You can change the schema on demand. It's fantastic for things like IoT, gaming and retail, if you want some kind of semi-structured approach to storing your data that's not quite a data lake, but not as structured as a data warehouse, and that's what you would choose. So now that we've had a good prep on that, let's take a look at Azure Data Explorer. One of the key things that you'll find about Data Explorer is that it is internally, and if you read the Microsoft documentation, it is a very, very complex beast internally. You have different virtual machines, which you never see because Microsoft hide this from you, that coordinate, that manage all of the, the services from streaming to batching. You have services in there which go through retention cycles of data. So if you say, I want to clear out this data over the next 2 years, a service will do that for you. And what you'll find is that even though your data is in the lake, you can see in the middle of the Data Explorer diagram, it's got an engine box, and every single virtual machine has an SSD drive, a very fast SSD drive. And this is how Azure Data Explorer is able to take your data and serve it back very, very quickly. Okay, because it does this locally. It doesn't need to make requests to storage over the HTTP API. It will just take this from a well-known partition when you give it a query and read it from an SSD, which makes it very fast. There's lots of different ways that you can interact with this, which is where it gets really powerful. You can use the Azure portal. You can use apps through ARM. You can create Data Explorer through both of these mechanisms. So you can have an infrastructure as code that creates it, or you can just click a few buttons in the portal and within a few minutes it will be ready. You can connect and get data into the into Data Explorer through any of these, through Spark, ADF, through APIs directly. There's a plugin via Logstash, and you can sync via Kafka. And this is basically a push into Data Explorer using the APIs. Very, very easy to do. But the other thing that you can do is you can connect back, and this is where the real-time element comes in. If you have an IoT hub in Azure or an event hub or an event grid topic, you can have an active connection to that, and immediately you receive a message, it will automatically ingest it into Azure Data Explorer in real time. And you should be able to read all of your data back through these common types of apps, query, command, control. Using the REST API, you can connect via ODBC, JDBC. Power BI has a connector to Azure Data Explorer, and from now on I'm going to call it ADX. You can see here ADX Web UI. We'll take a look at that. You can read from ADF, you can read from notebooks. There is a great plugin in Grafana, so if you want to see time series graphs, you can use Grafana for that as well, and Spark. Okay, so lots of different things in terms of the things that you can do with this. It supports metrics and time series, which we'll look at, text search, text analytics. It has multi-dimensional analysis. The analytics query language, which we call KQL or Crystal Query Language, which we'll be looking at, can do lots of things from time series to summarizations, to machine learning and things like anomaly detection as well. We can scale out our hardware. So I said at the start that this was effectively infinite scale. I mean, that's what we expect of the cloud today, but we can have auto-scaling algorithms where if we have 1 user or 1,000 users, we can serve our users with a certain service level agreement, because underneath it will just scale up with many, many virtual machines, but it will be invisible to us. And so one of the common patterns that we'll find is that we ingest data directly, and it may be through a couple of different means. There's Azure Stream Analytics, which ingests data via IoT Hub, and if we want to then take that data, push it onto the Event Hub, we should be able to ingest this directly into Azure Data Explorer. So very, very simple patterns. They take like 1 or 2 minutes to put into place, and I'll walk you through them. And you can see lots of different data sources that you can use to put data onto the Event Hub or the IoT Hub for ingestion. So now we've looked at the modern cloud data warehouse. I wanted to build this picture because you can now see where ADX fits. When you take this and you put this into the prep stage, you can build pipelines for things like Azure Data Explorer, land to the lake, and then ingest this directly and do the preparation in Data Explorer. And then you can model this in a SQL data warehouse and view in Power BI if you want to serve this very, very quickly. Okay, and there's lots of data integration tools that we can use. You can see here with ADX. So there are SDKs all over the place that we can use to bring data in and to push data out. And there you see here there are, we can pull in something. Let's say, for example, and this is something that I've used before, which is Office 365 logs in ADX. We can ingest these events. We have things called an update policy, which allow us to take data once it's ingested and effectively say, let's keep all data together on either a particular timestamp and with a particular value. So you can see this DP value there. What this will do is it will keep and localize all data together with a particular column value. And that means that it's much faster to search for data when it's queried. And so you have things called extent policies, which allow you to do that partitioning and to keep data close to each other. And update policies, which allow you to land data in Data Explorer and go through a transformation as soon as it hits. The other powerful thing about Data Explorer is that it has the ability to use something called row-level security. And some of you may have come across this if you've used Power BI in the past. But what I can do is I can write a simple function, and you'll see this is the first time in this in the talk that I've shown Custo query language, but this is what KQL looks like. It's a function, and what I can do is I can apply an Active Directory group and say, for this particular table, for this customers table, if where the in support rep is not equal to true, so if I'm not an in support rep, then I can see all data. Okay, I can see partial data where I am an in support rep, and what I do is for this partial data, I create another column, and the credit card number you can see is blanked out. So I only show the last 4 characters and no expiration date. And then I union both these tables together. And then what that function does is it says that anybody that's in the support reps group won't be able to see this. Okay, so you've got a union of these 2 tables, and you've used row level security to work out what somebody can and can't see by virtue of the fact of what group they're in. And so you can see here that the policy that will apply on this is very, very simple. It's you just do a create function and then an alter table on the customers, enable row level security, and then you can treat different users differently based on what you want them to see and what you don't want them to see in the table, just through the Azure Active Directory. This is a slide that I'll skip, and before we take a look at Data Explorer and some demos, I'll show you some just some ideas of demos that I've done in the past where we've gone through creating a table, then we create a mapping. So a mapping is important. What it is, it's a JSON document that says all of the data that you've got coming in your file. So say you've got a CSV file, this is how it maps to the table that you've created. And then you create your ingestion, and the ingestion expects a file in a certain type of format. It then uses the mapping, and then it puts that file into the table. And then you can ingest in this demo that I did, I ingested weather data. And then you can do a couple of other things as well. So once you've got your table mappings, your ingestion sorted, you can create what's called a data connection. If you're reading from the data lake in real time, you can set your blob path. And what that means is that if I drop files into the data lake, Azure Data Explorer will detect those files immediately, and it will ingest them, it will map them, and it will put them into my table. And then as a result of it, we can do complex things like joins. And the thing that we spoke briefly about update functions, and update functions are important. We won't cover them; they're beyond the scope of this talk. But I'm going to mention them because when we ingest data in real time into Data Explorer, what it means is that if we have 1 or 2 sources and we create our connection to, like our real-time connection to the data lake or an event hub, and we're streaming data, we can use an update function to say, we have one reference table, let's say, and we have a real-time table. Let's join them together as we get data coming in. So we would build a join function. We would set it up as an update function, and we would create a new materialized table, which will be all of our enriched data. And then in that way, any real-time data that we're ingesting directly and landing into Data Explorer, we have an enrichment pipeline, which is fantastic. So what I'm going to do now is I'm going to skip across to the oops, here we go. So I've created an Azure Data Explorer instance, and let me walk you through a few things about this instance. So you can see that the state is running. I've created my instance in North Europe, and it automatically gives it this address. So I've created mine. I've given it a name of user group, and I've created this in North Europe. So the address then becomes usergroup.northeurope.custo.windows.net. Now, the other thing to notice about this is that I've got a different URI to query. So if I want to query data, or if I want to connect to this, I use this address. And I've got another URI here, which allows me to ingest data. So it's ingest dash. And this ingestion mechanism is really, really important, because this is the thing that I need to give to, this is the URI that I need to give to any data connection, so that it can connect to this. You'll see I've created a database called Conference. I don't have much data in it, but there are some important things here to show you. We've got something called retention period, and what I'm saying is that my data is available for only 1 year. I have something called a cache, and what the cache does is it will cache the query plans, and it will also index results as well. So I should be able to run a query like 3 or 4 times, and it will get faster over that time because of the cache. And I can change these values for the database. If I want to create a new database, I simply hit Add Database, and I can choose all these things on startup, and I can make these unlimited as well. So I'm gonna walk through a few things here. I can scale up my instance. So if I want to choose a new instance, I can do it here. If I want to scale out my instance, I've got an instance count of 1, but I can just move that slider across. It's checking to see whether there's an auto scale availability, but what this will do generally is it will give me the ability to apply an auto scale algorithm to say, if my CPU across Data Explorer, let's say, goes above 70%, give me, for 5 minutes, give me a new instance. If it goes below 30%, remove that instance. Okay, so quite a powerful thing. We have a managed identity. I haven't turned this on, but this allows me to give Data Explorer an identity itself. So if I'm reaching out to another service through Data Explorer, I can use this. And there's a bunch of different configurations. I haven't set up streaming ingestion on here yet, but what this will do is it will allow us to do lots of different things. You'll have like, we'll start from the bottom because they're easier. So you've got R and Python language support in them. You can enable stopping the cluster if you want. You can enable purge, which will allow you to purge all of the data from the cluster. And you can enable streaming, which will allow you to directly connect the event hub, so real-time data. Okay. Then correspondingly, we've got permissions here. So we can add database admins. When I put this together yesterday, I added Antonio, who is one of the ADX experts in Elasticloud. And the other thing that I added was an app. So I can create an app registration, which is something that I can create in Azure Active Directory, and that's a non-interactive user. And that is incredibly important if you're ingesting data in real time. Then I've got this. We're not going to use this directly, but I want to walk you through. Yeah, seems to have got a little bit stuck. Here we go. So this will allow me to run queries, but also I can click to do this in the web UI. And it will ask me to re-authenticate. And you'll see that I have access to be able to query that cluster. There's a dashboards feature. Again, it's beyond the scope of this, but one of the things that I can do is create a new dashboard. And you can add tiles on this. I can add a particular data source, which is a cluster URI, connect to it, and then write a query. As I say, it's beyond the scope of this, but once you understand KQL that we're going to look at now, the rest is actually quite easy. So I'll walk you through some ingestion and some things that you can do. I used a tool called Light Ingest. So let's have a look here. It's something that you can download from Microsoft. It will allow you to ingest directly into. You can see there's quite a lot of command line switches. It's just Light Ingest, and you've got a bunch of different things you can use there. Now I am just going to take you to the web page. It's a NuGet package, and if you just do a Google or a Bing search on Light Ingest, it will take you to this page and ask you to download that package, and that's how I got data into this. Very, very easy. I ran a command like this, so I've got things like the app ID. I've got the storage key, which I'll redact after this. I'll remove these, so you won't be able to use them, unfortunately. But I point this to a cluster, so you can see here. This is my ADX. I point it to a database. I tell it that I want to federate. I tell it that I want to use an app registration to ingest data. I then give it a table, so I've called this landing sales Light Ingest. I give it a source path, so I say everything in the landing container in my data lake here I want to ingest. This is a sales data set that I've used, and I've put this in a time folder for the 28th, which is yesterday. I've told it that it's a CSV. I've said that I only want to look at CSV files in that folder. And I've used what's called a mapping, which says the CSV data maps to this table in this way. So I've created this in advance, and I have got a time pattern as well. So you can see this is in the dated folders, and what this time pattern will do is it will give us a timestamp when we ingest, and I will tell it that if this is too large, I want to time out within 600 minutes, okay, within 5 hours. Right, so what I'm going to do now is take you through some of the ways of querying using Custo query language, just to get you familiar with this. So we have a table called sales, and you can see now sales has a lot of data. We've got 5,000 records in this table. It's got things like the region, the country, the type that we've of product that we're selling, our sales channel. We've got things like order dates, order IDs, shipping dates, the units sold, units priced, all of these sorts of things. So first and simple query, once we've got this data in, is just to take 200. Now you see at the bottom, we've got 200 records now. Very, very simple. We can also change this to limit as well. It's the same thing. If we want to do a count operation, you can see it tells us that we've got 5,000. Now, going to run this, and I'm just going to walk you through what this is doing quickly. But what this has done is it has taken, we've used what's called project. So if we run this bit by bit, just so that you can see. So we have projected, which is like select in SQL. We projected our region, which is pretty much a continent. We projected the total revenue for that region, and we projected the order date. Okay, so this is pretty much the transactional data at this stage. Then we've used what's called a summarize, and with summarize I can create new columns. So I've created a column here called earnings, and I've rounded this, and I've rounded the total revenue sum. So let's take a look at what this is. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so that's in billions. Okay, and I round this to 1 decimal place, and I say I want to summarize total revenue, the sum of total revenue by every region, and I also want to summarize it by year. And then in order to do that, you can see the order date is a full timestamp here. So what I do is I use the get year function to get that order date. So if I run that, some of you will be familiar with the fact that this is very similar to a group by query in SQL. But you can see now I've got the region by year and the amount of earnings. And then I can simply do an order by here. And it's, you can see I've got this ascending. I could do it descending as well. Let's get rid of that. Change the way it runs. Okay. So on this other query, apologies, I'm just going to change this, and I'll talk you through what I'm doing here. Okay, so we've got total revenue, we've got order date. Okay, now you'll see the one difference between SQL and Presto query language is that I use the table first, and then I apply all the operators onto the table. Okay. Actually, looking at this, I think I've duplicated this query, so apologies for that. So the other thing that I wanted to show you is we've got this idea of functions in Presto, and so functions become very, very important because through the function, we can take a query and we can wrap that up in the function so that we don't actually need to completely rewrite our query every single time. I just call the function, and it acts like a table. So if we look at this function, we've created all country summary state, and we've project the country profit, total profit, earnings, get the year. So the great way to do this is to run this bit by bit. Okay. And you can see that we've got the profit and earnings by country. Then we can summarize this so that we've got the number of transactions. So we can do a count function by country and year. Okay, so these are the number of transactions per year that Antigua and Barbuda have done. We can order by, and we can extend that as well. So we've got an earnings ratio, which is profits over earnings as a percentage. Okay, some of these are not a number, unfortunately, but you can see that some of these have got like 50% profit, some of them have got 0. But if we run this all together here, so got a .create function, if not exists, that's now created a function. We should now be able to do something like all country summary state and limit 200. So that, and there you go. Okay, it has the appearance of a table as a query. Now, the other things that's really important is that you've got a bunch of these things called control functions. So this .show is an operator which will allow us to probe Data Explorer. And I do apologize, I should have said, but I'm using a tool called Custo Explorer here, and Custo Explorer is a way of me connecting to that database in Azure and being able to being able to run these queries in a nicer UI, not just the web UI that we saw. And you can see this tells me all of the people that have got access to my sales table. I can show all of the databases. So I've only got one, this conference database. I can show the capacity here, and you can see that the number of ingestion slots that I've got to be able to read data at the moment is 1, but it could be more. And then a cache, which I talked about. So we can literally probe and see just about every single part of this. Okay, this is my mistake, but what we'll find is that if we've got a space in our column name, so these are order dates, then what I need to do, unfortunately, is I need to put them into square brackets like this. So it's something that I missed. So the query won't work properly. But let's run this. And what we're doing here is, and this is actually my favorite part. So one of the things that you'll find is that we can render charts. And so what this means is that Data Explorer can be used to show different charts, whether line charts or whatever, just by using the render command. So off of the back of this, we can take one of these and just go render column chart. Okay, and it will render a column chart for us. And I haven't formatted this nicely, but we can do some nice formats on this. Now, what we're doing here is we're doing a query. We're aggregating around units sold, and we're summarizing by timestamp. So we've got a min and a max timestamp here, and we're using that to make a series. So we take this timestamp, we put it in between a range. So all of those transactions for all of these countries every single day, we turn into a time series based on the number sold, and then we can render this into a chart. So and this gives us a nice time series chart to show us between the beginning of 2010, January, and the end. This is how many. This is the number of things that we sold. You can see that we've used the let keyword. So let is an assignment of a variable that we can then use in our query. And I've consistently done this. A few minutes left, and I'm going to wrap up soon just to give everybody a chance to ask me some questions.
We have 3 minutes, Richard.
Okay. Thank you. I will try and be as quick as I can here. So, try and build some graphs for you in the next 3 minutes. So similarly, oops, I've made a mistake here because we've only got 3 minutes. I'm not going to revisit this. What I'll do is I'll explain to you what's going on here. So in these queries, these one of the really, really powerful features which I wanted to get to at the end was the ability to say that when you ingest data in real time into Data Explorer, one of the key use cases is the ability to do a time series. So especially if you have something like IoT data or real-time telemetry, what you can do is say, I want to make a time series in this real time and continually do this and refresh this and show these time charts. And one of the great things about Data Explorer is that you can run functions like this, series fir, which will then allow you to take all of the noise out of the time series data just to show you what the trends are in real time. So if you're doing things like anomaly detection or preemptive maintenance, this is a fantastic framework because it will allow you to look at the history and the real time of this across all of the lag values in the past. So with that, because we've only got 1 minute now, I'm going to close this. I hope that was very, very informative and you learned some new things about Data Explorer. Please try this out. It's very, very simple to create an instance in your Azure space. And thank you for your attention.
Richard, I'm just going to ask a question on behalf of everyone else. You mentioned ingestion, and we usually associate ingestion with extraction and loading into the data lake. So do you think we should be using ADX as a data lake store? Or is that the wrong pattern?
So one of the things that I've seen is that ADX is used more as a data warehouse, but it replicates all of the data from a data lake into a very, very well organized way. It's different from a SQL database in that it's not really operational, it's append only. But the way to use this is just to scale this with billions upon billions of rows, and it will read it very, very quickly.
So it's used for searching for a needle in a haystack kind of
exactly. Yes.
Scenario.
Very, very fast. That's right.
Okay, cool. Thank you.
Thanks, Manny.
All right. So looks like we don't have any more questions from our attendees. So I would like to extend my sincere thanks to Mani and Richard for taking your time and delivering the session here at Azure Community Conference. And thanks again.
Thank you for inviting us.
All right. So let's move on. We have Pasha here, who will be taking us through how you can use Spark for Java developers. And without any further delay, I'm handing it over to Pasha to take you through that. Thank you.
Yeah. Thank you very much for having me. Can you hear me well? Yeah. Okay. Looks like yes.
Yes.
Looks like the answer is yes. That's cool. Hello, everyone. I am Pasha. I work for JetBrains in role of developer advocate. We are building tools for developers, and usually these tools are vendor agnostic, and it means that today I am going to speak about Spark, and it will be easier to understand this talk for folks who are familiar with Java. But what you should know, it may be perfectly used inside Azure HD Insight. I mean, folks from Microsoft provide us with awesome tooling in their cloud, and HD Insight contains all the tools I will use today. I mean, between the thing you can see on your screens right now is Big Data Tools plugin, and it's basically will be the whole thing I will present in. For example, currently I'm connected to Zeppelin. It's my local Zeppelin, but of course it could be in HD Insight, but sometimes connections are unstable or anything. So just in case, I prefer to use Zeppelin on my local machine. And yes, Zeppelin is a system of notebooks, which allows us to render something, to run arbitrary code or anything else. currently you can see that I'm rendering Markdown, which is a part of my presentation. Who I am? I'm a former developer. I had quite some experience in development because I was developer for more than 10 years, and also I was team lead of Java teams, and then I became data engineer. Who are data engineers, by the way? Data engineers have 3 basic tasks. First, building storage architectures. Richard, who was speaking before me, gave an awesome talk about storing data in Kusto, Azure Explorer, Azure.Explorer. It's awesome. It may be one of the tools which data engineers could use. But in other tools, for example, Apache Spark. Apache Spark is distributed computing engine, but basically it allows us to run everything to run everything in a distributed way, like copy data from our operational storage to our lab storage, to our data warehouse, to our data lake house, to our data lake. We actually doesn't care. We actually don't care. And of course, it allows us to perform ETL operations. ETL stands for extract, transform, and load. Extract data from somewhere, transform it in some arbitrary way, and then put it somewhere again. Also, I'm an author of Kotlin API for Apache Spark. It's set of extension functions for Kotlin, which allow you to work with Spark in Kotlin. Here we should say that Kotlin has Java API, Scala API, Python API, and R language API. They are all official. There are a couple unofficial too. One of them is R language support for Sparkler. It's second unofficial API, R language API for Spark. And second is C# or .NET language Spark API. And I'm the author of third one, actually, Kotlin. We at JetBrains love Kotlin. We develop Kotlin. So of course I wanted to integrate it. But today is not a day when I will, describe why Kotlin is bad or anything else. And I'll actually show my examples in Scala Spark, because it's the most powerful API these days for Spark. Where you can find me? You can find me obviously at JetBrains blog, JetBrains Big Data Tools blog. You can find me at Twitter. My nickname is Asmodio, as here. And you can find me and follow me at LinkedIn as Asmodee. Sometimes I try to post useful content there. It may be interesting for you. Yeah. Also, one note about Zeppelin. It's just a thing for notebooks. You may be familiar or may not be familiar with Google Colab or Jupyter Notebooks or anything else. You can see that Zeppelin is basically the same concept. Some notebooks here, they can be executed, they can mix languages, and so on. By the way, about mixing languages. For example, in this notebook, I have Markdown code, which is rendered to nice Markdown. Okay, it's not that nice in presentation mode, but overall, it looks fine. And here I have quite a simple Scala code, which allows me to give you a small introduction into Spark. Spark operates on entity called data frame or dataset. They are basically the same. Dataset is, or data frame, I will call it dataset during this presentation, is an abstraction of any table-like structure. I mean, it has columns, it has rows, right? And it allows you to manipulate data in columns, just like in Microsoft Excel or any tool like that, in Google spreadsheets and so on. You can always create a new column and say, for example, hey column, I need data in this cell to be equal sum of this cell and this cell, or something like that. Of course, we are writing in Scala for Spark, so we have couple of ways working with datasets. Actually, datasets have three APIs. Spark has three APIs: typed dataset API, untyped dataset API, like raw dataset, and SQL. So we always can mix everything. Sometimes we can work with types. Sometimes we can work with, some just columns like in Excel, and sometimes we can even query data with SQL. Today, I will try to, walk you through all these APIs to solve some like real life problem. Quite simple, actually. I'm working with Zeppelin from Big Data Tools plugin for IntelliJ IDEA. And here you can see that this plugin supports not only Zeppelin, but several more things, for example, Kafka and remote file system. For example, here you can see that I have connected Azure Blob Storage with lots of data, actually lots, I think gigabytes, maybe even more of data. And I can open any file in any, big data file, like from CSV to ORC or Parquet or Avro. I can open them and see them in tabular view. For example, here is the Tesla stocks and their costs during time, and it's CSV but I can open it as a table. And actually I can say the same about Parquet files. I have a very small Parquet file here, and it's also opened as a table. Also I can see its metadata, like its size and columns and so on. Sometimes it may be useful, but it's not the topic again of our talk today. Today we are going to solve following task. How do you think, please write in the chat, how do you think, what is the most popular genre of movies for last, for example, 70 years? Yes, there is the single genre that is the most popular during latest 70 years. I was quite shocked to find it. And today, we are going to find it together. Again, I will work with local data just in case. And I will start working with a dataset called Movie Lens, which contains CSV like this. It's a movie CSV that contains all the movies from, like, I don't remember, 1921 to maybe 2018 or something like 2018 or something like that. It's organized in a very simple way. It contains movie ID. It contains title with year inside title, and it contains pipe delimited list of genres. Let's try find something more interesting here. I'm not actually sure that I will be able to find it, but sometimes there are no genres at all for some mysterious reasons. Maybe they are lost, maybe they were not used by publisher of this movie. I don't know, but okay, I can find it quickly. So such movies are marked as no genres listed in brackets. Okay, again, to solve this problem, I will use typed dataset API, at least at first. If we will have time, I'll show you untyped API too. To work with this, I should actually define some types, because if we want if we want to use typed API, of course we should have sometimes. By the way, let me check the chat. If you have written something there, what is the most popular thing? Yeah, please write. Please do not hesitate to write the most popular genre of movies in your opinion. Last 70 years. Okay, we have some domain model defined here, and we'll start with class movie. Case class is just a class with several fields and automatic toString equals and hash code. Okay, how do we start? We start with reading some data from our CSV. I just copy path from here and can paste it here. Yeah, of course it's the same because I didn't change anything. And I can read this, and I should actually read this CSV as data set. Also, I'm using function z.show here. This function just shows me content of my data set in tabular in a table view. Theoretically, I could build some charts here, but I think it's impossible to build any chart on this data because, okay, there is nothing to put on axis. So let's move further. We know, okay, what we should do to perform our task. We want to define something on years, right? So we should definitely extract this year to separate column. And also, I think we don't really need to have a year number inside our title. So let's remove it from the title. How should we do it? We should actually, let me just comment this out. Oh, this way. Yeah, comment this out. As first thing we should do is define couple of patterns. First pattern is very simple. It's just 4 digits. We can check that it works for example, 9053. Yeah, you can see a small green check mark here. But and of course it should work for 2020. Yeah, it works. But of course it shouldn't work for -10 because it's not a real year number. And of course it shouldn't work for year 135 because we believe that they've started filming movies just like 100 years ago. So there always will be exactly 4 digits in year number. Also, it's very simple thing, but the second more complex thing is we need to we will use it to replace year in brackets with optional spaces around with nothing. Let's look at this regular expression. It means any number of spaces, 0 or more. Then there should be opening bracket. Then there should be 4 digits again. Then there should be closing bracket. Then there should be any number of spaces again. Then it's CSV. So theoretically, there can be closing double quote. And then, okay, it's optional thing. And then the string should finish. How should we do it? For Java developers, concept of map, I think it's very familiar, right? We are taking some collection and then we are transforming it. We have exactly the same API in Spark. It's called map also. So we are taking, let's just check. What is movies? Yeah, movies is the data set of movie. It's almost like, sequence or stream of movies. And we are calling map on it, and we are transforming movie to another entity we defined a bit earlier, movie with year. It should also contain movie ID, and also should contain title, genres, still pipe delimited, and now it should contain a new column, a new field called year, obviously. How should we do it? Of course, we are creating a new instance movie with year. We have lambda argument movie. Movie ID of movie with year will be the same movie ID. Title will be the previous title, but with this regular expression replaced with actually nothing. Nothing. Genres will remain the same. And here is a bit complex. We should find all years inside our title. I mean, for example, imagine that there is a movie, something 1992. It's in the name of the movie. It's not year when the movie was filmed. This this movie could be filmed year before, year after, or century before, century after. But there should always be a year at the end of the name inside brackets. So we should find all occurrences of year inside title. Then we should take last of them, map it to string, obviously. And if there is no year, I don't know why, if there is no year inside the title, we will map it to -1, then to just filter these movies without years out. And now let's try to look at what do we have now. It takes some time to run it. I hope not too much time. Here we can see that the picture is basically the same, right? We still have movie ID, we have title, we have pipe delimited genres, but now we have separate year in separate column. But let's return to our task. What we should do next? We should find the most popular genre, right? But now we don't have distinct genres for any title. Well, okay, for every title. Because, for example, Toy Story has five genres, and for us they look like a separate string. So it looks like we should separate this string. We should separate this string into some array, right? Let's try to do it. I'll comment everything out for you for flow to be more clear. Yeah. Okay. What do we have here? We have current data frame. I gave it some dump name like df2 because I'm too lazy, but of course we can invoke any refactoring on it. For example, let me rename it to movie with year. Movies with year, actually. Yeah, like this. Of course, I made a typo. Yeah, nothing can have changed, but of course, refactorings work in Zeppelin. Oh, okay, not in Zeppelin, in IDEA, but they're propagated to Zeppelin. So everything is translated everywhere where it should be renamed. Okay, what I want to do now is to split every genre string to array, and there is a very simple, or to list. There is a very simple way to do it. I have defined a bit earlier again case class movie with genres, where genres is not string, but list of string. And of course, code will be, almost primitive again. I'm creating movie with genres with the same movie ID, the same movie title, the same movie year, but this time I'm splitting genres by pipe and converting into list. Let's call this, oh, of course, I have renamed it, but I didn't run the affected cell. Let me myself. Yep. Now it should work. It works. Of course, it's a bit ugly because we are in presentation mode and there is not enough place to demonstrate this. But what we can see that there is a Toy Story thing, and its year is 1995, and now all the genres are there. They are even displayed as array, which implies that we have converted to array, right? And now, of course, there are several genres: adventure, animation, children, comedy, and fantasy. Jumanji has 3 genres: adventure, children, and fantasy, and so on. But it's not enough, right? Because now what we should do, now we have array of genres for each movie, but it's not enough to analyze what is the most popular genre, because now we wanna, change the structure of data frame a bit. We wanna lose our uniqueness of lines, but we wanna have this one line for Toy Story and children, one line for Toy Story and I don't remember action, one line whatever. For each genre, we want to have single line. For each genre and movie, we want to have single new line. There is no such function in SQL, but luckily there is such function in, for example, Java Stream API, and it's called flat map. It allows us to convert, for example, lists of string to just list of string. In our case, it will be a bit more complex because for each genre, we wanted to have the line. This is how it will. Please work. Yeah. This is how it should look like. Flat map. We should, for each genre, in genres, we do map, and we are creating movie with year. What is movie with year? Again, it's an entity we have used. Theoretically, we could create a new case class here, because now there will be only one genre. But to be honest, I'm just too lazy to create a completely new entity to just rename a bit one field, to rename genres to genre. So I prefer to reuse this case class. And actually, it looks fine to me. So yeah, we are creating movie with year with same movie ID again, and with same movie title. This mysterious underscore means that we wanna, it could be lambda like this, and then we would use X here. But Scala gives us, this shorter syntax, just underscore, to use the first argument of our lambda, and the same movie year. Okay, let's try to call this cell again, and now we can see that there is a Toy Story Adventure 1995, Toy Story Animation 1995, Toy Story Children 1995, and so on and so forth, which kinda makes us closer to our final goal of finding the most popular genre during all the time, during class 70 years. What we should do now is to filter out those movies who have no genres listed. And now the complex, analytical part. How should we find this information about during 70 years, what the most popular genre is? It looks like we should invoke group by. There is no function called group by in Java Stream API, but there is one in SQL. And Spark is a nice mix of SQL and sequence or stream API from Java. So we can call group by key. And what should be our key? Obviously, we are looking for genres in years. So we should group by key year and genres. This syntax, this syntax means that we are creating tuple of two elements, actually pair of two elements, year and genres, and in our current state is the genre is singular. Then in each group we should just count number of movies, right? Because we have year and genre. So for each genre in some year, we need to count how many movies of this genre were filmed this year. It may be solved with map groups. It's kind of simple thing. We have argument of our lambda and nice destruction declarations. Thanks Scala. Oh, what just happened? Okay, I'm sorry. Some rendering glitch in presentation mode. Yeah, it's our key, which is tuple, and it's our value, which is set of movies in this group. And we want to create a new entity called stats. It's a very simple entity. It contains genre, year, and count. All the things we need to finally solve our task. And also, just for the sake of convenience, I would prefer to sort this data by year and genre, because it's a convenient thing. If we want to find something in years, we want to order it by years. Now let's call our cell. Okay, and now we have some data. For example, of course it's sorted. In 1974, there were only one movie, and it was a documentary. And in 1990, in 1888, there were 4 movies, and they all were documentaries. By the way, I hope that I don't remember the whole thing of Brothers Lumiere with train. How is it called? But I hope it's here. In 1890, there were one movie, and it was comedy. And in 1894 was like a huge. It was like huge year for movies. There were 13 documentaries, at least in the movie lens dataset, and so on and so forth. But here's the thing. We can't really understand what is the most popular genre, right? Because there is so lots of data in this table. What is the best way to understand what's going on in our data when there is too much data? I believe that it's visualization, and that's what we will do. I have a nice chart button here. Of course, this chart is absolutely nonsensical because it gives us almost no information. Oh, okay. I see that in 2060 there were plenty of movies, but that's all. I don't know anything about genres. Sorry, I pressed the wrong button again. Here are the settings of my chart. I don't really need this chart. and I want to use area chart. In this view, it's unsensical too. But the nice thing, on x-axis, we do really want to have year, yeah, grouped and sorted. On y-axis, we want to have count, but I think that not mean, but yeah, not mean, but mean. No, like no, I'm wrong. Sorry. Oh, I think I'm actually right. And also, we want to group this data by genders. Yeah. It looks correct to me. But still, the data, now we can see the data in absolute numbers, right? And it's hard to determine what gender was more popular. Okay, something here says that, but I'm not sure because, for example, light blue here is actually more popular than violet here. To fix this, I want to use expanded chart. Yeah, now I want to hide my series settings and maybe expand this chart a bit, just a bit. Sometimes it's hard to find the boundary to drag. Okay, it doesn't work for me. Okay, now we can clearly see that starting from I think 1915, the most popular genre was drama. Of course, it's just 13 dramas filmed in 1915, and in 2001 it's 459 dramas, but the relative number of dramas filmed all the years is basically the same. Also, let me find something interesting here. Yeah, can you see here this? I'm not even sure what is the name of this color. It's above the green one. It's actually between two green ones, this green and this green. But it's a very interesting phenomenon. It's a movie of genre film noir, and it's extremely interesting that it appeared several years before Second World War, and this genre basically disappeared in 13 years after Second World War. And it's the data which is very hard to find when you're just looking at some table with data. Charts are awesome, and that's why I like visualizing. And I believe Richard talking giving a talk like 40 minutes ago, that's why he visualized the data too. And now we can see that the task is solved, and let's move to next part. By the way, let me try to call the cell. I'm not sure if it really works. I wanted to demonstrate you something else, something interesting on text now, but I just wanted to find the the movie with lots of tags, and that's here you can see the code how you will do it. You're just reading your tags to as tag entity. We can view it. Yeah, user ID, movie ID, tag, and timestamp. Then we can join data. Of course, like in SQL, in Java Stream API, we can't just join data, but in Spark we can do. So we can join movies with tags and define how they should be joined by column movie ID. And then we need only, couple fields. We need title of movie and name of tag from all this data. Then we are grouping again by title and counting tags. That's very simple. And then we should just order this data descending by tags and see the top 10 movies. And the first one would be Star Wars Episode 4. I mean, chronologically, it was filmed first, but its name is Star Wars Episode 4. I'm sorry that I can't show you it, but let's move further and let's look at untyped Spark API. What we should know about untyped Spark API is that we do not operate on types anymore, on typed dataset. For example, here I have commented out as movie because we do not want to have, this type here. And the algorithm will be of performing the same task with data frames or untyped data sets will be basically the same, but we will operate on columns. As I said, in untyped data frames, we can operate on columns with their names. First thing we do, we are renaming title to title with year because it's actually what it is. Let me comment almost everything out to show it. Yeah. Now it's not title. Now it's title with year, not as it was in CSV. Now we are creating a new column called title, and we are replacing the whole complex regex with nothing. We are adding new column title, and here it is. It's Toy Story, and title with year is Toy Story 1995. And the same way we should create a new column called year. By the way, you can see that there are no types, so we should cast data explicitly. We are extracting year, and we should cast it to integer, like here. And yeah, here it is, the new column. Now we should rename our genres to genre soul. And call it again. And yeah, it's genre soul. And you can see that I can use any naming strategy I want. For example, here I use genres underscore all. Here and that's snake case. Here I use camel case. Everything works fine. I believe I can even use names with spaces, but I don't like this idea. Now I should, as in previous example, I should split genres by pipeline, and we have function Spark specific function split for this. By the way, I forgot to say that in usual Scala code we were using usual Scala functions like replace and extract and so on, but here we are using specific Spark functions. They have definitions inside. Let me show it to you. Yeah, org Apache Spark SQL package. The same is correct for split. Let's call this. Oh, okay. Of course, I've already called it, and we can see that now we have a new column called genres, and it contains a wrapped array of genres. Wrapped arrays internal Spark representation of arrays. Then we are using select, just like in SQL, to stick to only those columns which we are interested in. Oh, and I forgot to tell that instead of flat map, we use function explode here. Explode is basically does what it says. It explodes array to several rows, and we are renaming this column to genre. It's like S is given an alias, and given an alias and renaming is basically the same when we are speaking about selecting something. Now we should, of course, group by and aggregate, and now we should filter out movies without genre, and we should remove movies where year is null, and now we are ordering data by year and count again. Let's look at what we have, and of course we have basically the same chart. I'm not sure if oops, I have lost. Let me screenshot. I will back report my folks because I don't know why I can't find control buttons here. There should be chart settings, but basically, of course, it's the same. It's just like previous example, but yeah. Let me just scroll it down until my chart. Where is my chart? Here it is. And let me set it up again. It will be grouped by genres. And yeah, by the way, you can see that we can basically see the same data in very different ways, in line charts, or for example, in bar charts. And these bar charts can be stacked, or they may be even horizontal. Everything works. Everything is as expected. And also there are some settings, nice settings of area chart. For example, stream one, it arranges the data a bit another way, but basically it's the same. Oh, and now they are returned. I don't know what it was. Of course, it's not stream. We need to expand again. We see a little bit different gamma, but basically all the data is the same, and we can clearly see that the drama is the most popular, or is much more popular than any other genre for last years. And by the way, what is interesting is sometimes, it's most part of data engineering. We don't just visualize data. Visualizing data is a nice way to explore data. But usually we already know what our data is, but we don't need, we should dump our knowledge somewhere, right? Our conclusions, and we should do it periodically. Just imagine you have, for example, some e-commerce shop, and you need to count some metrics on your data, like how many purchases I had today. And we should put this data somewhere, right? We don't need just visualizing it. We do really need to put this data to be later analyze our sales declining, or they raising, are we fine, are we not? And for this, Spark has right option, and we, for example, what's wrong? Path already exists. Let me just try to remove it. By the way, you can see at the bottom of the screen what hotkeys I'm using. I'm trying to call together. Something goes wrong, totally wrong right now. What's going on? Location, struct. Oh, I see. It looks like Spark is running on incorrect version, on unsupported version of Java. I think I won't be able to fix it in a moment. It's like 55, I believe. It looks like Spark is running on Java 17, and it's not fully supported. It's totally fixable. We just need to run the Spark on another Java, but it may take some time, and I just don't want to waste your time. Of course, I mean, it's very simple concept. we are just writing with the header to some CSV, or for example, we could write with to ORC file with some location, and so on and so forth. So to JSON, so on, to Avro, to Parquet, to anything that Spark supports. And Spark has lots of connections, and of course, Spark can read and write to and from JDBC data sources. I mean, it's written in Java. Integration with JDBC is just simple. You're dropping your JDBC driver into your software, into your Spark job, and I mean, adding, of course, your JDBC driver to your Spark job, and Spark will be able to write data in any table you want. Actually, not only write, you can do inserts, updates to relational databases, and so on. And while we're here, it's SQL, right? So let's talk about third API of Spark. It's SQL API. Spark, please open this new notebook for me. Oh, shoot. What's wrong with you? Oh, okay. Now it's here. Let me fix my code a bit. It's quite funny thing. I forgot to fix path data. The first thing we should do is actually reading our data again, but this time we are not creating any data frame. We are calling create or replace temporary view. It's like SQL, right? We want to work with SQL, so we should create some temporary view or even table with which Spark will be able to work. And it has no seeming result, but what's interesting, we have a table. Let me just leave my presentation mode for a second and show you something interesting. Yeah, we can see that in databases there are now, there is now a virtual table. Of course, there is no data, but this table has, of course, it has some structure. It has 3 columns: genres, movie ID, and title. And we want to perform the same task in another API. Let me enter presentation mode again. Yep. And we can call any query on this data. For example, and of course we have after completion and all the things. For example, after completion of our columns is just an awesome feature. We can call any SQL, and this it's something simple. Let's call it and see if it works. Yeah, Toy Story, and it's half of the work, right? Half of the work done. And look how simple it is. It's just regex replace, and then int. It's just casting data to integer, and then regex extract inside from title as and we are and in the same query we are splitting genres by pipe and exploding it, and it's very simple. Of course, it's not our task completed. Our task completed will look a bit different way, like this, because and of course it gives us the same results. Look at how simple it is. I mean, it's just regular SQL. Almost anybody could read this SQL. No more complicated Scala code, no everything. But of course, it has its own drawbacks. SQL is not strongly typed. For example, well, let me just break it and write something completely incorrect. For example, it's just not correct syntax for regex extract function. And if I would delete this argument, Oh, I don't even get hint, because maybe regex extract without third argument is correct. Let me just check if I can call it on single argument. Yeah, if I am trying to call it on single argument, the idea says me, man, you should call it on more arguments. A single argument is not enough. But this way, query is incorrect too. And of course, the output is empty. And yeah, here idea shows me the data inside the data frames, the structures, and so on. We won't look at it right now. We just want to return to our thing. But for example, we don't need pipelines to build such a simple thing, because we can just call where and set up couple of predicates, and we can group by, and we can order by, descending, or by the way, let's try. Theoretically, it should not change anything, but I have never tried. Yeah, of course, it doesn't change anything, but it's still valid SQL, and we can see it in table view that the data is actually different now. The latest movies are from 2018, but still data is the same. 112 actions. Okay, 2018 is not too interesting. 200 horrors 2017, 159 in romances, 312 thrillers, and of course 685 dramas, which only supports our hypothesis about the fact that the most popular genre during last 70 years is drama. Okay, it's pretty much all. I have finished my demo. Let me just summarize what we have just seen. We have seen that Apache Spark may be extremely like Java Stream API. You can map data, reduce data, flat map data, filter, and all the things. But it has couple more features. It allows you joining things, and of course, and it has several APIs. Java Stream API is strongly typed, and Spark has two more APIs. One is data frame API, which is untyped, and third one is SQL API. Also, we have seen that it's comfortable to use all these APIs from Big Data Tools plugin. We have special setup for Zeppelin notebooks, and Zeppelin notebooks work, for example, inside Azure HD inside. Or, for example, if you have huge on-premise installation, you can still use local Zeppelin. You can even install Zeppelin locally, like me, and access all the data you need from the local Zeppelin and connect to your local Zeppelin from Big Data Tools plugin. It will help you with syntax, with refactorings, with column names, not making stupid mistakes, and so on. That's pretty much all. Thank you very much for your attention, and if you have any questions, you are very welcome to ask them right now.
Hey, thank you, Pasha, for that wonderful session. So as of now, we didn't got any questions so far in our chat box. All right.
How many attendees did we have?
Sorry, what was that?
How many attendees did we have?
Yeah, we had them in 10 to 15.
Okay.
Alternative
Well, I mean, 15 is not enough to have huge amount of questions, obviously.
Yeah. All right. So,
I hope. Just tell me if it was, useful or understandable at least.
Yes, it was understandable. Anyway, we are going to upload this recorded in our channel, so people will be coming back and going through the session. So I hope we'll get more viewers at that point of time. Maybe because of the time, because it's around our lunch time here. Maybe.
Oh, of course. Thank you very much for having me. It was a pleasure to give a talk here. I hope it will be useful for somebody and folks who are watching. I hope it was useful for you too. You're welcome. You have all my credentials. Just you are free to ask any questions at Twitter or anywhere else. Amal says thank you very much for time
It was
and having me.
our pleasure hosting you in the second edition of Azure Community Conference. Hope you will come back again next year. Thank you.
I hope too. Thank you very much. Bye bye.
All right. So next we will start in a minute. We have Amit here joined for the next session. Amit is going to take us through Windows 365 and Azure Virtual Desktops. So without any further to do, I am handing it over to Amit to take you through the session.
Great. Thanks a lot, Amal. And just a quick audio video check. Can you confirm if you can hear me fine?
Yes, I can. Yeah, I can hear you fine. Maybe you can share the screen and we will.
Yes, I just started sharing my screen as well.
Yeah, it's also there.
Perfect. Should we get started or do we need to wait for a couple of minutes?
Maybe 10 seconds. We'll start.
Okay. Perfect. Thanks a lot, Amal.
All right. Amit, we can start.
Great. Thank you again. So welcome everyone to Azure Community Conference session for Azure Virtual Desktop and Windows 365. My name is Amit Malik. I'll be taking you through this session for next 45-50 minutes. And please do make use of the session by asking as many as questions you can. And if there are anything which left unanswered, please feel free to connect with me via social media later on as well. So with that, let's just get started. So first of all, it is absolutely a pleasure to be here at the Azure Community Conference. I've been involved with the community for a long time now, and I've pretty much every time I'm there talking about some Microsoft technologies or other. So it's a pleasure to be here, and really excited to share all the knowledge about Windows 365 and Azure Virtual Desktop that I've gained over last couple of years. Thanks to all the sponsors, especially Microsoft, Elastic, EY, and all these sponsors for coming together and helping us organize this event. And special thanks to all the community members, all the volunteers who are doing all the heavy lifting of bringing all this together, doing all the coordination. Being a part of the community, I understand very well how difficult it is and how time consuming and efforts required to pull off such a scale of event. So absolutely wonderful to see that, and really looking forward to learn more about how it helps overall the community and overall everyone to grow and learn more technologies. So with that, I'll be talking about Windows 365 and Azure Virtual Desktop. But it's more of a comparison session where I'll go deep into Windows 365 because that is a new service, whereas the Azure Virtual Desktop had been there for quite some time now. And primary focus is how do they differ? Which one should you use when? And a little bit about me. My name is Amit Malik. I work with Spectra Systems. So I drive the Spectra Systems overall business and tech strategy. And we are a cloud focused organization. We work with Microsoft very closely to enable products and services on top of Microsoft Cloud solutions. With that, let's get started. So agenda for today, we'll talk about what exactly is Windows 365, and we will do like a quick demo as well of Windows 365. How does it look like? What kind of portal does it look like, and so on. We will be doing a comparison between AVD and W365. We'll do like a generic comparison, and then we'll go into different sort of segments such as technical architecture, IT administration experience, end user experience, cost and licensing, and in the end we'll keep like 10-15 minutes for questions. So that's basically what is coming up in next 30-40 minutes. Credits to the to Microsoft Inspire Sessions, Nerdio blog, and Microsoft documentation for helping me put together this deck. Nerdio blog was very helpful to sort of having a detailed comparison between AVD and W365. So I will definitely recommend you to take a look at that post the session if this is something of your interest. So with that, now before we get into what these things are and how they are different, what's the need? Why do we need like Windows 365, or why do we need Azure Virtual Desktop? So the key thing is remote work. Remote work is a normal now. With COVID and the pandemic, it basically the adoption of remote work was super high, and it is still high, and even in future, even post pandemic, as the surveys are saying that it's going to be like more of a hybrid work scenarios for IT organizations and other companies as well. So there is a real world need of remote work. How do we work remotely from anywhere in the world without compromising on the productivity, security, and experience? So no matter where you're working, if you're working from somewhere between from the mountains or the beach, or in a different part of the planet, you should be able to work effectively using all the apps and tools that you need, and while accessing them securely in a greater experience. So essentially, like irrespective of whether I'm sitting in office or I'm sitting in some remote location, I should be as productive as as I would be in office. So that is essentially the goal for managers, even employees, and so on. So essentially, remote work is there to stay. There will be, obviously, like employees do want in-person collaboration, and we do understand the value of that. But so sort of but remote work or sort of hybrid work model is there to stay, and that is where Windows 365 and Azure Virtual Desktop will come together and sort of enable you to do like to implement a hybrid work, a culture in your organization by using these sort of technologies. So traditionally, this is how like we work. We have our client PC. So I'm currently like presenting from my laptop. So that is the traditional way of working. Sometimes there are like personal laptops, which we call like bring your own device. Sometimes there are company provided laptops, but irrespective, there is a client PC, laptop, desktop, or any other machine. Similarly, so that had been the traditional way of how do we work. Later on, virtualization, virtual desktop infrastructure picked up. So Microsoft Remote Desktop Services, VMware Horizon View, Citrix Zen Desktop, Zen App. So all these VDI solutions enabled organizations to allow remote work from anywhere. However, they were hosted in their own data centers. So all those virtual desktops are running in companies' own data center, leveraging the power of virtualization. That had been like a sort of in a second type of remote work model. And now with cloud in picture, desktop as a service solutions are also very much popular, where you are just accessing a desktop hosted in some cloud platform, and you are streaming it to device of your choice from anywhere over internet securely, while maintaining the superior experience of your apps. So essentially, we have three ways of accessing our applications and data using the cloud PC, which is not really the best model when it comes to remote work with all the VPN requirements or legacy things. This may not just fly, and with all the new bring your own device culture, this is not really the best solution. Virtualization definitely enables a lot of value, but it requires a huge IT investment for you to get your own servers, get your own infrastructure ready, get your own teams, experts who will set up this environment, and then who will maintain this environment as well. So definitely a solution, but comes with a lot of capex and opex, cost along with the management overhead. Desktop as a service, again, fully cloud streamed service, sort of you can compare it as a SaaS, where you are just streaming the desktop irrespective of where it is running, where it is hosted. So the cloud PC, or Windows 365 as we call it, essentially is a desktop as a service solution, where you will stream your desktop from cloud to any endpoint. In this slide, I've got like a laptop over there. So I'm streaming my cloud PC from the laptop, but it's not restricted to laptop devices. You can stream your cloud PC to Android devices, iOS devices, Mac OS, pretty much all kind of devices. You can stream your desktop as is and access your apps, data, content securely using your favorite applications while making sure that it's all safe and secure. So that is what that is what essentially cloud PC is, where rather than using your own PC or your data center's virtualization desktop infrastructure, you are streaming a cloud PC from internet hosted in a cloud platform to your device, and you are sort of doing your entire work in that. So essentially today, if every day if you log into your laptop and do your work in that, it will be replaced by logging into any device and then logging into your cloud PC and doing the entire work in your cloud PC. Windows 365 is the cloud PC solution by Microsoft, where you will be accessing Windows 10 or 11 machines over the internet on any endpoint. So Windows 365 is part of the Microsoft Cloud ecosystem, which includes Azure, Enterprise Mobility and Security, Microsoft 365, and now the Windows 365. So it's a hybrid Windows for the hybrid world. And essentially, you have a personal PC running somewhere in the cloud that you can access anywhere on any device. So what does it include? What does Windows PC include? So it is absolutely familiar. So it's the same Windows 10 or 11 OS that you would use on your devices. So it's not that there is a new learning curve, or as an end user you have to sort of figure out how to navigate through this. It's the same familiar OS, same familiar set of Microsoft 365 apps, and then you would, the only difference is it's running in somewhere else. From an organizations and IT perspective, it is super simple to deploy and manage. You don't need to hire specialists or have a dedicated IT technical team who would be responsible for managing and deploying this. It is pretty simple to set up, and Microsoft does a lot of management for you. Secure by default. So using your existing investments of Microsoft 365 Enterprise Mobility and Security, including Microsoft Defender for Endpoint, Microsoft Endpoint Manager, Microsoft 365 Security and Compliance. So all those products are still very much integrated and are available by default on your cloud PC as part of your license. So it's secure by default. So you can always be sure that if you are putting some confidential data in a cloud PC, and if you're configuring it right, the data will be safe. Can be streamed to any device. So we talked about how it supports Windows, Android, iOS, Mac OS, and so on, and Linux as well. Available at predictable monthly price. That is a key thing. So far with virtual desktop infrastructure, one of the challenge for organizations to implement. Sorry. So one of the challenge for organizations to implement VDI had been cost, and capex and opex both. Essentially, you have to invest a lot of hardware, you have to purchase, and then you have to have an IT to manage that. The cloud PC is available at a fixed price per month, irrespective of your irrespective of how long the user will use it. So I may use it 24/7. I may use it just few hours a day. I may use it at any schedule. My monthly price is fixed. So you have a predictable per user cost with Windows 365. It's scalable and resilient against changing needs. So anytime you are hiring a new employees, or some employees are departing, you can always decrease your cloud PC quantity, which will basically also decrease your cost accordingly. So essentially, pay as you go. The moment you need more, just buy more at that time. So since it is super familiar for users, so you can stream it to any device. It's always ready and updated, personal and familiar. Your users will not have any reservation as long as they have good internet bandwidth while using Windows PC. And talking about IT, since it is predictable cost, simple to buy and manage without any existing without any investment in hardware or any capital expenditure, with minimal management. And so your IT teams would also love that. It integrates with your familiar Azure Active Directory. So if you are using Microsoft 365, if you're in Microsoft 365 system already, you are essentially have Azure AD. You essentially have your apps and in Defender, Microsoft Endpoint Manager as the whole cloud modern management suite. So the cloud PC is extended to integrate with all these technologies by default. So your existing processes, existing tools, and things will continue to work as is without any additional deployments or without any additional investments. So moving forward, how does it start? So I'll briefly show this in a moment in demo as well. But essentially, Cloud PC comes as a license. So far, we have seen Office 365 licenses like E3, E5, then Microsoft 365 licenses, Microsoft 365 Business Premium, Enterprise such as E3, E5 again for M365. So Windows 365 is also offered in the same licensing approach. So over here, you do not pay for Azure, you do not pay for any usage cost or cloud cost in case of Windows 365 Business. You just pay for a license per user. So the Windows 365 Business, which is the simplest, a simplest offering, it starts with $24 per month per user, and you can use it for up to 300 users. So essentially, this particular service will allow you to offer personal cloud PCs to your employees and users starting at a fixed price per month without doing any additional investment. You just have to buy the license and assign the license to the user, and everything will be ready. Windows 365 Business with hybrid benefit. So if you are already having the required licenses which are covered under Windows hybrid benefit, you can save a bit on the cloud cost as well over here. Windows 365 Enterprise is for organizations who wants to manage the cloud PCs with their integrations such as Endpoint Manager and so on, and want to take advantage of their existing infrastructure by connecting their existing infrastructure securely to their cloud PCs. They can use Windows 365 Enterprise as well, which is also starting at a pretty low price as you see. So this is the starting price, and but the price really depends on your licensing cost. So let me quickly bring up the pricing page from Microsoft. So essentially, it's all about like any other compute machine. It's all about CPU, memory, and storage. So depending on what CPU, memory, and storage you choose, there will be a corresponding price that you would pay for Windows 365 Business and Enterprise. For example, this is a 2 vCPU, 4 gig RAM, and 128 gig storage PC, which can be used for light productive tools and browsers. It starts at $31, but if you go for like higher CPU, higher RAM and storage, the price increases. So like a decent sized machine as we like a 4 vCPU, 16 gig RAM, and 128 gig storage starts at 66. The price is similar for Enterprise Edition. It's all dependent on CPU, memory, and storage combination, and you pay for the corresponding compute. There are various combination available depending on what you need. Like for example, it starts all the way from 1 CPU, 2 gig, and 64 gig storage, and goes up to 8 CPU, 32 gig RAM, and 128 gig of storage. You can even have like 512 gig of storage. So depending on what exactly do you need, you can actually choose one of the combination, and price is different per combination. So depending on what CPU memory combination you are choosing, you will pay a fixed price per month for that. So you just buy these licenses and you assign these licenses to users, and that's it. From a Windows 365 business standpoint, that is all you need to do, and rest of the things happens automatically. So users logs into windows365.microsoft.com. So that's essentially the portal where okay, wow, I have to change my password. So let me share my screen, stop sharing my screen once and be done with the password updates, and then I'll be sharing again. a great time to have my password expired. Right. So I'm sharing my screen again, and Amal, I'll need your help to
Yeah, I'll
sort of push that again to the live stream.
Here you go.
Are we live with the screen sharing?
Yes.
Yeah, I think we are. So again, Windows365.microsoft.com is the place where you would go and access your PCs. Before this session, I had already provisioned a PC for me. So over here, I can see I have a cloud PC business edition. And this is the configuration I had selected. And let me quickly open that up. So I can allow like clipboard, microphone, printer, and even file transfer if needed. And if organizations wants, they can block some of these transfers if needed for different editions. And all right, so I'm in my cloud PC now. So you can see it's a Windows 10 machines running inside my browser. And over here, all my favorite applications such as Microsoft Word, Outlook, Office are pre-installed. It pre-includes the company portal app where and the device is joined to my Azure AD for my organization already. So and it's streamed like right inside a browser. I didn't need like any special app or anything. So this is basically the cloud experience is there over the web browser, and this can be accessed over a variety of devices. Now coming back to the portal over here, as a user I have various options to sort of manage my device, because this is my personal PC running in cloud. So I can restart it, reset it, like start from scratch. I can rename, and if I'm unable to connect, I can use the troubleshooting options as well. And now this is basically like I'm accessing over web browser. There is also like a remote desktop app available, and this app is available for different devices, like such as Windows, Mac, iOS, Android. You can download it from the respective stores. So if you log into this app, then you can even launch your cloud PC using the app as well, and even get like even a superior experience. So let me just quickly show that too. That's the Windows 365 PC experience for you folks. And in a moment, I'll switch to the comparison between Azure Virtual Desktop and Windows 365. This is the business edition, so there is no really any administration console for administrators. It is it's simply assigned to users as a license, and users manage it themselves. So right now, like over here, I've connected it via remote desktop application, and the same would work even on your mobile devices. So which is absolutely wonderful to be able to access your entire PC on any device. So this is the business edition. In business edition, there's no admin center, it's just instances. But if you go for endpoint enterprise edition, you will actually have the ability to manage your Windows 365 using Microsoft Endpoint Manager. So if you over here, you will have ability to manage that. Now moving forward, so go back to the presentation. So that was like a quick Windows 365 end user experience. Now let's take a pause here, and let's talk about Azure Virtual Desktop. So Azure Virtual Desktop is a VDI solution. It's been quite some time it is available, and it's sort of an evolution of RDS on Azure. So earlier RDS on Azure was a very much supported solution where you would maintain your own connection brokers, gateway machines, and so on. So Azure Virtual Desktop is a managed VDI service by Microsoft where you will deploy a full-fledged VDI solution in your Azure subscription. Some of the things will be managed by you, some of the things will be managed by Microsoft. So the cloud PC was just Windows 10 or 11 machines. The Azure Virtual Desktops, so it allows you to have full desktops or remote apps, whereas in Windows 365, it was just the desktop, not the remote apps. You can use multi-session sessions in AVD, whereas Windows 365 is only individual session per user. It also supports using Windows Server 2012 R2 or newer for session as a session host. Even supports Windows 7 Enterprise up to the extended support limit dates. So it gives you even more flexibility, which is not possible with the Windows 365. And over here, you manage the images, you manage the sizing, VM sizing, all of that, and you are not restricted by the license type. So you have more flexibility. You have ability to share desktops between users, and which will basically like allow you to set up a customized VDI solution for your organization's requirement without being restricted to the Microsoft Windows 365 licenses. Over here, like the management infrastructure of any VDI solution. So in any VDI solution you take, there have to be some sort of broker machines, there have to be a gateway, load balancing machines, management machines. All those things are offered as a managed service by Microsoft. So all these, broker, gateway, all these roles are sort of hidden for you. You don't have to deploy them, you don't have to manage them, you don't have to sort of uh, you know pay for them as well. It's a full managed service. You only pay for running your desktops and session host machines. And the underlying compute, storage, networking is which are provided by Azure infrastructure. So that was like a recap of AVD. So if you sort of compare at a very, very high level, AVD is a VDI solution which allows your IT organization to set up a customized remote desktops or remote app strategy for your organization while maintaining full control, while having ability to share sessions, and even if you are already using Citrix or VMware solution, integrate with that too. So Azure Virtual Desktop can actually integrate with your Citrix and VMware solutions if needed. This is a pure consumption-based pricing. So AVD does not come in license packs. Instead, it comes in Azure consumption. So you will pay for your Azure cost. Whereas Windows 365, it is a full SaaS service, which basically allows you to set up Windows and 10 and 11 personalized desktops. Not AVD has personalized and shared, whereas in case of Windows 365, it's only personalized at the moment. So you put like Windows 10 and 11 personalized desktops, and you just deploy it, and you get like a predictable per user pricing. So if you are a smaller organization with who doesn't have like a dedicated IT team, Windows 365 may be the preferred approach for you. Whereas if you are maintaining like a large VDI infrastructure and you are looking for full customization and control over the machines, then AVD may be a better solution for you. So this is at a very high level. We will be going in detail when it comes to technical capabilities. So talking about the first thing, that is the architecture. So from an architectural standpoint, Windows 365 and AVD, in the back end, they are running on the same Azure cloud, and they are leveraging the same Azure Virtual Desktop infrastructure. So control plane for both service is AVD. The only thing is, if you choose AVD, the control plane is exposed to you. If you choose Windows 365, it is fully managed by Microsoft for you. And please note that in Windows 365, we discussed about two editions. So we'll also like see the difference between enterprise and business editions of Windows 365, as well as personal and pool desktop available features for Azure Virtual Desktops. The first thing is, everything you run in Azure requires an Azure subscription. So in case of Windows 365, the Azure subscription is managed by Microsoft. In case of Enterprise Edition, the networking has to be managed by you in your subscription, whereas the Windows 365 machines will be managed by Microsoft in Microsoft managed subscription. AVD is fully customer managed. So wherever we are saying Microsoft managed subscription, you don't pay for that. You only pay for license. Wherever we are saying customer managed subscription, you pay for that, all the usage cost of that subscription. Talking about compute, in case of W365, you are restricted to use the fixed size provided by Microsoft. We took a look at that list of combinations available between CPU, memory, and storage. So you have to choose one of them. You can't just go and enter your own CPU and memory unit over there. With AVD, you have the full flexibility to choose any CPU, RAM, storage combination as long as it is supported by Azure virtual machines. Now, talking about storage, again, in case of W365, it is fully Microsoft managed, fixed cost. There are only limited storage sizes. Like I think the maximum one for business edition is 512 gig. Whereas in case of virtual desktop, you can have it as big as you want, and you can have like backups and DR and everything configured as per your personalized requirement. In case of networking, this is where the key difference comes between enterprise and business as well. Enterprise business edition is deployed on Microsoft managed networking. So you cannot connect that Microsoft managed networking to your private network or your on-premise network if you are using business edition. Enterprise edition allows you to deploy the Windows 360 machines in a virtual network, which is managed by you in your Azure subscription, which can be extended to your on-prem environments as well. So Windows 365s allow you to have your own network, own IPs and routing and security, all of that. Whereas the business edition is fully managed with no ability to connect to your connect to your other infrastructure privately. AVD gets you full flexibility, and you can have your own network as you want. User profiles, where all the user home drive plus your preferences and other things are stored. In case of W365, it is all local in that VM. If that VM is lost, that data is lost. Whereas in case of AVD, you can use FS Logics, which is a profiling solution for Azure Virtual Desktop. Using FS Logics, you can store the user profiles in a storage account, Azure File Storage, or in a file server. Like so, essentially, you can store it in these remote storage locations, and irrespective of which VM users are logging in, they will have their exact same experience and profile carried over. Last, but a very major, key difference is on identity. So today, like Windows 10, 11 machines, you can join them to an on-prem Active Directory domain, Windows Server Active Directory domain. You can join them to Azure Active Directory, or you can do hybrid Azure rejoin, where it's joined to the Windows Active Directory, plus it is also joined to the Azure Active Directory using hybrid Azure registration, also known as a domain join plus plus. The Enterprise Edition supports hybrid Azure AD join at the moment. It will be supporting pure Azure AD join in future. The Business Edition only supports Azure AD join. It will not support a Windows Server Active Directory joining. And in case of Azure Virtual Desktop, it requires you to have Windows Active Directory joining, whereas the native Azure AD joining is going to come soon. So the key difference is, if you have an Active Directory infrastructure and if you want to join your cloud PCs to that, you only have two options, either the Enterprise Edition or Azure Virtual Desktop. You cannot use Windows 365 Business in there. If you see here, we also have Azure DDS, that is the managed Active Directory in Azure, like Azure Active Directory Domain Services. So that is supported for AVD only, and it's not supported for Windows 365. So I can understand that this can be a lot, and this is a lot of differences in a very small time frame. So Nadio has a great blog post out there which you can see and look in detail later on to sort of capture recap some of this information. Moving forward, further differences, IT admin experience. So the IT admin experience from Windows 365 and Azure Virtual Desktop is pretty different actually. Azure Virtual Desktop requires specialized skills to manage Azure environments and VDI environment, whereas Windows 365 is fairly simple to manage and set up and doesn't require deep Azure skills. So talking from management portal, Business Edition, there's no management portal. It's just assigning the licenses. In case of Enterprise Edition, we do have the MPM, Microsoft Endpoint Manager, previously known as Intune, as the admin portal. And AVD, you will basically manage using Azure Portal. OS, it only supports Windows 10 or 11 single sessions, whereas AVD supports Windows 10, 11 single session, multi-session, as well as Windows Server as session hosts. So you have a lot of flexibility over there. In case of images, you can have, you can use your custom images in Enterprise Edition. In case of Business Edition, it's only Microsoft provided images, whereas in case of AVD, you can have as you desire. Applications you have to manually install in Business Edition, but in case of Enterprise Edition, you can use your Intune apps deployment policies and configuration policies as well. And in case of AVD, you can use either Intune or Image Update or even MSIX App Attach, which is a great technologies to be able to attach your applications on demand without really having to worry about separate installation and so on. So at this time, Windows 365 doesn't include a backup, but that may come in future. Azure Virtual Desktop, you can use your favorite Azure, Azure Recovery Vault, Azure Backup Service, basically, and Azure Site Recovery to do like the full backup and DR service of it. Monitoring, so we have got Azure Monitor for AVD. In case of W365, either you can use Microsoft Endpoint Manager's Endpoint Analytics, or in case of business, there is no monitoring available at the moment. User profile, we briefly talked about it. It's all local in case of W365, whereas in case of AVD, you can put it into a remote storage. We briefly talked about networking too. We are, in previous slide and last auto scaling. So Windows 365 doesn't have any auto scaling at the moment because of the fixed cost. But Azure Virtual Desktop, you can actually save a lot of money by implementing auto scaling in Azure Virtual Desktop. Like, for example, if you have like a 500 users and you are managing a solution for 500 users VDI, not all 500 will be using it at the same time. So depending on the peak time, depending on during off hours, it may be just 10 20 users. So depending on the load, you can configure auto scaling in such a way that it can stop the VMs, delete the VMs, and if needed, it can start the VMs again. So, which basically in a larger scenario actually brings bigger cost benefits than Windows 365. However, that cost benefit is only like limited to the Azure costs and not really your operations and management costs, because you will need like a team to set up that and manage that as well. So talking about cost, that's the next slide is. So licensing and cost. In case of W365, it is per user license that you have to buy based on the configuration needed. In case of AVD, it is the Azure pricing. You definitely need a Windows 10 enterprise license in order to access Windows 10. So all these solutions are requires Windows 10 enterprise. So you need to have a Windows 10 enterprise license. That can be separate purchase, or it can be part of your existing M365 suite. Like for example, M365 E3 license includes Windows Enterprise E3 as well, and that is sort of same in case for both AVD and W365. So networking price, in case of Enterprise Edition, you pay for the bandwidth because you are hosting the cloud PCs in your network, in your Azure network. So you pay for bandwidth cost. Business Edition, it's part of your license, and AVD again is your Azure consumption. Intune, now renamed as Microsoft Endpoint Manager, is needed for Enterprise Edition, whereas Business Edition it's optional and AVD it's optional. Office subscription, it does require Office subscription than Windows 365 if you want to use the MS Office apps. In case of AVD, you will need like shared activation as well. Last difference, so end user experience. End user experience is like pretty similar, and primary thing is in case of Windows 365 Enterprise, the URL is sort of different. So you access your Windows 365 over windows365.microsoft.com or cloudpc.microsoft.com, whereas the URL is separate for WVD AVD service. Essentially, the experience is same because it's using the same set of background technologies. The portal look and feel is different. You do get like printing, redirection, etc. in both edition, whereas In case of enterprise edition, you can redirect it via network as well. In case of business edition, it has to be redirected via client only. So if you remember, when I tried to access Windows 365 over my browser, it asked me, what do I want to redirect? And AVD gives you full flexibility to redirect via client or using network based. Now, user self-service. So user self-service is possible only in case of Windows 365. It is available right inside the portal. In case of AVD, it's not possible by default, but there are third-party solutions like Nerdio and even like WVD Control Center and other solutions are available. So if you are more interested in going detail of each of these topics, do take a look at the blog post by Nerdio, which includes these things in greater detail. Now, now that we are done with the technical differences, the next step is, which one should you use when? Like, how does the overall, like, how do I choose? Like, if I'm an IT owner in an organization, how do I choose which one is best fit for me? So this is a great decision flow built by Nerdio, where it really depends on your requirements and use case. If you have like less than 10 desktop and no Azure, Windows 365 makes sense for you because you don't have to worry about like getting a new skill to manage the Azure AVD. Then if you have more machines but you already have like an Azure like sort of you already are using endpoint manager or you are already using Intune things to manage things, in that case also Windows 365 makes sense because you don't have any desktop virtualization sort of requirement or experience. If you need like local admin rights, that is sort of mandatory. And if you need the access more than 55 hours per week, see, this is the key thing here, because Windows 365 cost is fixed for the entire month, even if the user is using it 24/7. Whereas in case of AVD, one of the most common way to implement is that, hey, during the work hours, keep all of them running. During night, keep minimal running. During weekend, keep minimal running. But if you have a requirement where the desktop access are required more than 55 hours a week, then Windows 365 may be more cost effective because it allows you to run it 24/7. Like you do not have to worry about uh, pausing, like stopping the VMs when they are not in use and so on. Remote apps is only supported for AVD, so that is the only option you have if you want to use remote apps, not the entire desktops. So another thing is like if you need like quantity up and down all the time, you can use Azure Virtual Desktop auto scaling capabilities, whereas the cloud PC licenses are purchased on a monthly basis. So AVD basically can auto scale and increase, decrease VMs and stop VMs based on the demand. So if you don't know, if you don't know how many users you'll have every month, and it's always changing, AVD may be a better option. Last, cost, because AVD allows you to share desktop between users, also known as pool desktop. AVD can be really cheaper than cloud PCs if it is configured right using the auto scaling capabilities and the other cost optimization best practices. So so that like if you have a large environment with tons of users, and sharing PC is a, like, even though it's sharing PC, like every user will have their personalized experience and will be logging in their own profile. But if pooled desktops works for you, AVD actually may be a bit cheaper as you go from a long-term scenario. So that is pretty much all from my side from a presentation standpoint, and we will be like breaking for questions as well. So before we do that, again, thanks to all the partners for supporting the event, and thanks to all the communities for coming together and building this. Like I said, it requires great efforts and great sort of time and dedication from all the community members to pull together such an event. So thanks a lot to all the communities, and and kudos to every community member and volunteers who are coming together and organize this. And with that, I'm all open for Q&A.
All right. Thank you, Amit. So we do have one question. So this is, I'm
Yeah.
bringing that to the screen. So this is from Manish. So what he is saying, how we can connect to Windows 365 PC.
Yeah. So in order to connect to Windows 365 PC, there are multiple ways. So let me quickly show that. So over here, I am connected to my, so over here, I can connect to the Windows 365 Cloud PC using a URL. The URL is windows365.microsoft.com. And right inside the browser, you will see your Cloud PC. Just click on this Open in Browser, and it will ask for your credentials, and you will be able to like log in right inside the browser. And this can be done from any machine as long as it supports like HTML5 browser. This is like one way accessing over a modern browser. Let me just put my right password. The other option is if you don't like, if apart from the browser, the other option is using the app. So right now you can see I have a Windows 10 machines loaded in my browser. This is my cloud PC. This is Windows 365. The other option is that I can use a remote desktop client. So a client is available for Windows, Mac, iOS, Android. So even from your Android mobile phone, you can download the remote desktop client from Google Play Store or the respective Mac Store, App Store, depending on your device, and even access it using the that app over any device. So that is sort of how you connect to Windows 365 Cloud PC.
Thank you, Amit. So that's the only question we had received so far. So
Perfect.
okay. Anyway, it was
So
our pleasure to host you here. Yeah, Amit.
I mean, we still have like another 15 minutes left.
10
So if there
minutes,
are
yeah.
questions, I'll be around. If there are questions, if there are any questions, like I'll be happy to answer them as well. I'll be around.
So there is a follow-up question from Manish. So
Okay.
So this is actually, it is like to access one machine, you need another machine.
Yes, that is true. You need some sort of device to be able to stream your cloud PC.
Okay, there you go, Manish. All right. So maybe we can do one thing. We can, yeah. So here is again one more time to access W365 PC.
Absolutely. So I'll just close this. It's a simple URL, windows365.microsoft.com. It will ask you to log in with your work account, and it will show up your cloud PCs here. From here, you can restart your cloud PC, reset it to scratch, rename it. Like I can call it something else, and do any troubleshooting if needed. Over here, all I need to do is just click it on open in the browser, and it will ask for my credentials, and that's it. I'm connected. And from an app standpoint, so I can even show the app experience once again. Right now it will connect me via browser, so I'm here in the browser. I already installed the app in advance. So this is the remote desktop client app. If I want to connect using the app, again I just have to click on subscribe, log in with my work account, and just double click on the cloud PC, and it will ask for authentication again. And this is another way of connecting to cloud PC. And this app experience is pretty similar for across different platforms like Windows, iOS, and Mac OS, Android. If you want to access your cloud PC over Linux, you have the ability to do so via a web browser. As far as I remember, there are plans to launch this remote desktop client via for Linux as well. But for now, you can use any of the web browser. So I hope that helps.
All right, Amit. All right. So
Okay. So I think that is it for now. Yeah. Uh,
yeah.
I had a wonderful time like presenting the session, and I hope it was useful. Feel free to like if there is any follow-up questions or anything, feel free to connect with me over social media or my blog post. And I'm part of Spectra Systems. We are a cloud focused organization, and we work with all the cloud PCs, AVD, all these technologies day in day out. So we have tons of open positions for Azure engineer level to architect levels. So if you are looking for a role change, feel free to take a look at our careers website and apply. And yeah,
Yeah.
that's
So
essentially it.
yeah, one more question for you. What if you want to change the memory capacity or CPU? How is it? How
Yeah.
easy it is?
So the changing the capacity and everything is it's all about license. You buy a license based on what capacity you demand. These are the licenses. So changing essentially is you don't need Microsoft support for that. The way you can always change a user's license. Similarly, you can even change a cloud PC license. The only thing is, since the profile is stored locally, you may have to, if you are changing like storage and all, it is recommended to store the data in like OneDrive only, so that your all data is in one place. But yes, it's nothing but changing the license type to a different a hardware combination. So you can go to M365 Admin Center and change the license type.
Okay. All right. Thank you, Amit. It was our pleasure hosting you again for the second time, and we will really hope you will come back next year also.
Absolutely.
Thank you. Bye bye.
All right then. Thanks a lot, everyone, and have a great rest of your day. And thanks a lot, Amal, for coordinating and helping me through the session.
Yeah, my pleasure. Okay, so we have next session, Roslyn source code generator with examples. So we have another 10 more minutes to go. We will start sharply at 1 o'clock. All right. Hey, welcome back, everyone. So we are going to start our next session with Andre. Andre will be taking you through how to use Roslyn source code generators with examples. Andre?
Hello, nice to meet you. Thank you for the presentation. First of all, I want to thank you and all the organizer for having me to this wonderful conference. I have learned many things, and I hope that the ones that are coming to my presentation will learn something useful about how to generate automatic code with Visual Studio or .NET Core. So I'm starting the presentation, right?
No, not yet.
Okay, I wait then.
Register. Okay, here we go. Okay, enter the. It's visible now. You can take. Your entry.
Yes, I can
Yeah,
start
the
now.
screen. Yeah, the share is visible. You can go ahead.
Okay, thank you very much again for having me here, and thank you for inviting me. I hope that you learned some useful tips for generating automatic source code that will minimize your work as programmer. The Roslyn source code generator is pretty new in the .NET Core world. It was previously, so there were some previously tries like T4, but I do not speak about them. Let's see the agenda. This is the agenda. It's about me, what is a Roslyn source code generator. I will show some simple generator examples. I will show how to interact with code examples. And then I will make an advanced example about automatically generating stack tracing for your code without touching the code. And at the final, I give you some links to get started because you can create your own Roslyn source code generator whenever you want based on your purposes. So, about me. My name is Andrei Ignat. I am a programmer for 20 years and plus. I am an ASP.NET Forum moderator, and I have a book that I was enjoying writing, How to Copy Paste for Stack Overflow. And I bet that every programmer has at least once have copy pasted from Stack Overflow. Now let's go to the subject. I have an ebook about Roslyn source code generator examples that you can get free from this address, and will show like 20 Roslyn source code generators produced by me and others that can help you every time that you have a task that can be automatized. Let's go further. What is Roslyn source code generator? Roslyn source code generator, it's a new child in the Microsoft.NET world, and that means that the build can generate based on your instruction and on previous code or files or everything else, new code to be added to the source code that you just written and you want to build. How does it function? So let's suppose that you have a solution and you build this solution. The compilation runs from .NET Core, .NET Build, it runs. Then after it runs and compiles the existing code here, that comes your source generator or other source generator that you add to the solution. He analyzes the source code, generate the new source code. This is added to the compilation, and the compilation resumes and builds the whole project based on previous source code that we have written and the new source code that was generated by Roslyn source code generator. And I will show you a simple example of this, and I will show you how to debug and see how to create and debug this kind of Roslyn source code generator. And this is the first demo. We have here something that I have created that it's called time bomb comment. What it does, you have here a comment. You see here that it's time bomb. It's with the prefix of time bomb, and it says, on this date, this is a comment transformed in the error. If this date is passed, this comment will be transformed into an error. Also, we have the obsolete. Obsolete, it's an attribute by Microsoft that shows an error or a warning, depending on this bool error, when the compile is activated. As you see here, what I have put, it's time bomb comment, and this kind of stuff is not defined anywhere here. The whole console time bomb comment, it's just this line. How it is compiling. Let's say how it is compiling. I'll build, and you will see two errors. Just a moment. Okay, so if I go to error list, we see that this is a comment transformed into an error. It shows me the error. If I modify here and I put 1101 or here 1101, that means it will be next month. If I compile again, you will see that no error will be raised. Is rebuild all started? And in the error list, we have 0 errors. How it is done? First, let me introduce the Roslyn source code generator. The Roslyn source code generator, it's a DLL that it's .NET Standard 2.0 with Lang version 9.0. This is not very useful, but it's useful for you that you create one. And we should have a Microsoft Code Analysis analyzers. Also, we have this is Roslyn component equal true. That means that when we want to debug this kind of Roslyn source code generator, we have here debug, and we debug this Roslyn component by using the console. So this Roslyn source code generator generates code for this project, for console time bomb comment. Let's see the code generator. If I go here and I press F12 to go to the definition, it shows me this code that says it's auto-generated by the generator and cannot be edited. How it is done? This is done. I will show you just right away how it is done. It is done here by putting, this kind of class. I have put namespace, partial class, and constant bool date, and this is adding to the source. This is the instruction to add to the source. Let's go. What is this add source? We go again up, and the Roslyn code generator, I have said that it's basically a DLL that has a class that implements iSource generator, and it's with the attribute generator. The iSource generator have two methods, initialize and execute. Initialize, it's raised here. After the compilation runs, you analyze the source code, and here it's the initialize and execute. The both are here. What it's passed by these arguments that we implement, the initialize pass a registration to see the syntax node and all the code that we have written previously. So what it will give me? It will give me this static void main analyzed, and the other that execute allows me, when I write a Roslyn source code generator, allows me to interfere and add the source to the existing code. Good. How you debug? You see here is the Roslyn component. So I'm making this a startup. Sorry, just a moment. Set a startup, and I put a breakpoint here, and I run the project like usual in Visual Studio, do not forget that even if I run this, what it's compiling is this program that will be compiled because it references the Roslyn source code generator time bomb comment. I press F5, and now I have the breakpoint hit. Just wait a minute. It is somehow difficult, but on a better PC, you will have better performance. This is the compiler that compiles the program CS, this program, and you see here that we have the context, and in the context, we have the assembly. Let me put here in the watch, context dot, and you will see here compilation. And this compilation is the compilation of the target program, this program CS, that will be enriched with our source code generator. So this program haven't finished yet to compile. We are just in this step of the analysis of the source code and generate the source code, then will be added and the original program will be compiled. Okay, so I have explained you about how to debug this kind of thing. We have also system diagnostic debugger break, We have logs with do diagnostics, and the files are appearing here. Let's see this. So if I go with build, rebuild all to see the files that our Roslyn source code generator time bomb comment will add to the original source, you can see in two ways. One way is press F12 and see where this was added and see the source, or go into the dependencies analyzers, Roslyn source code generator, and here you will see the code that was added. If you do not see, please restart your Visual Studio. Sometimes it helps, sometimes not. Also, you will have to have the latest Visual Studio pack installed. Okay, let's go further. I will show you some simple generator examples that will generate files for CSV, XML, and JSON. These examples were written by Microsoft to show you how to use the Roslyn source code generator. Okay, let me go here into the code. I do mention that you can download the presentation. After this, going to my site, I will show you where the presentation is and all the examples there. This kind of stuff with generating code source from CSV and XML are very simple. You can think about a source generator that it's automatically generated from a database, all the create, read, update repository for the tables, or even the web APIs or something else. Let's see this example for CSV. And here are another example of JSON that you can download a package for Herman and show how to generate classes from JSON. But first of all, let's see this kind of CSV. Okay, in some time. Sorry for that. We wait another minute. Okay. So what I have here, I have a program that have a cars CSV. This CSV, it's a comma separated values of cars. So I add brand, model, year, and CC, and some examples here. Also, I have another people CSV, and think of this about like a database. What it's into the program? Into the program is something simple. it says uscsv generator.run. And in .run, we have this class cars that have a method that calls all. How is this generated? Again, it is a source generator samples from Microsoft that generates automatically these cars, Fiat Punto and Ford Wagon, that you have seen here in the car CSV. Because I'm from Romania, I want to add Dacia, model Dacia, and here I do not know. And I do not know the CC. I put just random values here. I save this. I rebuild solution to enter the Roslyn source code generator in work. And after this, after the whole project is generated, I will have also Dacia to the cars. Let's see this. Okay, have been rebuilt. Let's run it. Sorry, I will put this as a startup, set a startup project. And you'll see here Dacia. If I add something there, that it will be, I do not know, into the people. And again, let's see how the people are. John Doe, right? And I put this like Andrei, unknown. And I rebuild all the project. And I go to the people, you will see the people all have been put me here with name, address, and age. So if I run, I can see this. So what kind of stuff does this Roslyn source code generator with CSV? It takes the CSV, it knows that CSV are because it puts here as additional files include that could be a lot type of startup and demand. This kind of stuff, it's used by Microsoft generator to know how to load the file and how to cache the objects and generate code appropriately. So if I look to the people that was generated, let's go to the program CS and see here the use CSV generator, and we see all. You'll see that the cars has here brand, model, year. And if I go to the people, you'll see here that has address and all it's put into the source code. And this kind of people that it's the class, he has been also generated from what I have put here as headers. I have put this here name, address, and 11 age. So we do have a people that has name, address, and 11 age as properties. That will be later added to the program. You create classes based on your CSV and XML. So we have here the XML, main settings, XML settings, and we have this kind of stuff, main, false, run, and cache size. And we have here an XML settings main, let's put F12. And you'll see here that it's a document that it's loaded from the XML file, and it has first run, cache size, what I have here into the properties of the settings. So the idea is you provide the CSV or the XML and the Roslyn source code generator that you can find the source here. Again, it's a generator that implements iSource generator, and in the implementation, it parses the classes and add this kind of classes. I know that are somehow written here namespace CSV, but you'll get used to add dynamic source code to your programs. Okay, good. This was the example of source generators for CSV and XML. I do not make the JSON2 class. I have this on my presentation. You will find here at code, and it's JSON2 class. So from a JSON, you can create classes for this kind of stuff. Second, how to interact with code examples. So we have done what I have done here to show you. It's how to interact with existing files on disk of, let's say, database. You can interact with a real database if you want. Now, how to interact with existing code. Let's see on the time bomb comment that I have shown you previously and see how it's interacting with the code. So, what the time bomb comment does, it's take the date from the comments and transform into an error. This was the first functionality. Why it says time bomb comment? Because when you compile after the date, it will transform the comment into a time bomb. So how is this done? Let's go to the code and deep dive. We have here generate from comments, and we have two methods. We have the initialize. In the initialize, we register for syntax notification. So if you want to interact with existing code, we should register for syntax notification with a class that I called receive comments and obsolete. Let's go to see this kind of stuff. So this receive comments and obsolete implements an isyntax receiver that has just this function on visit syntax node. The syntax node is every node here. So main it's a syntax node, console write line it's a syntax node, this comment it's a syntax node. Everything here in the program are syntax nodes. So what I want to do, I want first to transform this time bomb comment into error and pass this kind of stuff. In the syntax node, I just see all the comments. Let's say how it is done. So I say here, if syntax node has compilation unit syntax, and if it contains comment start, if the syntax node contains comment start, what is the comment start here? The time bomb comment. So we have this time bomb. I should identify somehow this start. So if it starts with time bomb comment, then it is, just go again, the generate from, here, receive comments. If it's starting with this time comment, I said, give me the trivia. Trivia is another name of the comment where the trivia is a single line, and I add to candidates comment. The candidates comment, it's a list of syntax trivia. Syntax trivia, again, is just a comment. So I identify if the compilation unit syntax contains time bomb. If it contains, I go to all the trivia, all the comments where I found in a single line, and I add to the candidates comments. What I'm doing with these candidates comments, I'm doing in the execute. So now we have been just into this initialize. So we have initialized, we have received the code source. Let me go again back to show you the figure. So the compilation runs, we have the generator step, we have analyzing the source code. So for the moment, we have analyzing the source code by this isyntax receiver that receives all the syntax, and we identified what we need. So the comment with time bomb that we have put here. And after this, we are in the stage of generating new source code. The generate, it comes from the second function. The second function is execute. The execute receives a context that I have make comments diagnostics. Make comments diagnostics, let's see the source code. It receives a comments that are the candidates. You know the candidates, that the list of comments are here, rec candidates comments. And I say for each item in comments, I put a diagnostic. I have put a diagnostic severity warning. And if I trying to parse the date and the date is less than this date, the severity will be error. Otherwise, the severity will be hidden. So we have the severity for this kind of stuff, for the error, and we put a new diagnostic descriptor and we report the diagnostic. Until here, we didn't modify the source code, we just report an error. Let's see again how it is doing. We put here 1101, put 1001. Now, if we build a build solution, you will see here the error for this comment. This is the comment transformed in the error. Just a moment to compile. And says in the error list, this is a comment transformed into an error. The comment is, again, if I put 11, and this will be in some days from now, build, rebuild solution, this will not be shown and the program is compiling successfully. Okay, so rebuild all succeeded. Again, how is this done? Analyzing the code source and adding a diagnostic that it's the severity error or hidden and report this diagnostic to the compiler. Until now, we just reporting an error. How we do the second thing, improve the code source. So we have here the attribute obsolete. This attribute obsolete, again, is not my attribute, it's the Microsoft attribute that has a constructor that says a message and bool error. What I have put here, I have put TB underscore, so time bomb, and put here the date. And what will this be doing? Will transform this TB into an error or not, into Boolean true or false. We'll add this a code source with this and transform into Boolean true or false depending on the date that we are today. So now we see that have no errors. If I put here 10 and it's in the past, I save, build, rebuild solution, you'll see that now it is giving me an error. An error is says it's obsolete, should be deleted. This is obsolete. And this is generated by my source code generator. Let's see how it does. It is basically the same. So in the isyntax, in the, sorry, it's not here, it's here. In the isyntax decipher, I see if it comes with TB. Here I says, if it's in the attribute syntax, this is the attribute, and the attribute name, it's obsolete, I just add to the candidates of obsolete. What I'm doing with these candidates of obsolete, let's go. So in the execute, I make the obsolete variables. This kind of obsolete variables, it says, we have a dictionary here, and says, if I'm finding the date, then I create a namespace, a partial class for the same class that we have identified, and I put constant bool tb date equal, and it's error or not, depending if the date it's less than now or not. You see here that this is the error. So if I'm going back to the program, to the original program, this TB is generated and it's putting true. If I'm going and put in the future, let's put 12, and I save, build, rebuild solution. And this is succeeded. You have seen that 0 errors. And this is now generated with the value false. What is again very interesting that we have generated this kind of code source when it was compiled. So this program, it's compiled And in the meantime, let's see again the image. We have the compilation runs. We have analyzed the source code and see the obsolete. We have generated new source code that will be true or false depending on the date of today and the date that it's put here on the time bomb comment. We generate a new source and the compilation resumes. That means that after this, the compilation can be run successfully or not depending of what code source has been generated based on your demands. This is kind of awesome. I have liked it a lot, and it's very interesting. Okay, this was the time bomb comment. And the last presentation, it's stack trace with Roslyn source code generator and open tracing. Let's say that we have a program that we want to add logging and we want to add debugging at runtime without the programmers to be involved very much for each method. Let me first present you Jaeger. Jaeger, let me run the command for Jaeger. It's a program that it's very useful to generate stack trace and see where your stack trace is going and what other components have been called. It is very useful in the microservices thing. It's kind of must do to see how the components are interacting, where they are interacting, and how they are interacting. Let me show you. Let's start with loading the program. I see that it was sorry for a moment. I was having here more examples to show you. Sorry, just a moment. We'll resume for the Jaeger just in a moment. I will go to the Advanced X program to show you how to modify the source code and improve your programs with, let's say, copy constructors. Let's show you this kind of stuff. So the second example after Roslyn source code generator, I have shown you how it was created and get into the technical details. Now I should show you some advanced examples when you profit from other people Roslyn source code generators. They are just basically NuGet packages, DLLs, that you can add to your program and modify to your convenience. Let's see this kind of stuff. So build, rebuild solution. We have here in some methods common and methods generator. This is the Roslyn source code generator. We have also mock source generator. Let's see what it does. So we have a class that it's a person that has an interface iPerson, and a partial class that has just this kind of definition, public partial class person of iPerson. If you see in the program, I have, let's say, copy constructor. I have new person. I have the first name. I have put my first name. And you see here that I have var p2 equal new person p1. Where this come from? Where is the code source for generating the constructor? Because here the class doesn't have a constructor. The class person doesn't have a constructor. It's just the usual constructor. This comes from a Roslyn source code generator that can modify your code and just generate code, not modify, add code. And this kind of copy constructor here, it says we have a partial class name, and we generate a constructor here with other, and we generate copy properties from. So let's see how this is generated. We have, sorry for this, just a moment, please, just a moment. Okay, sorry. Just a moment. Sorry, this comes from working from home every time. So I go to the program CS, and if I go to the constructor, with the other, you'll see here that it was generated copy properties from person other, and it has generated the ID, the first name, and the last name. So we generate automatically the properties from the copy properties from a class to another, making basically an automapper from a class to another, to the same class, to copy all the properties. If I want to modify and add something else here, I just edit the source code here and say copy the property, and I put here the name of the property, and I go with build rebuild solution. And I'm going again to see the code that was generated, F12. You will see here the copy from property ID, copy the property first name, copy the property. What I have put in this copy constructor txt to modify, to add more source code for copy constructor. So does not matter how many properties we have into the person, after we generate and we put on public string, let's say public int age get set, and we put this also into the interface, int age get set, and we save. Now this property age will be generated into the copy constructor. Let's show you. Build rebuild solution. Just a moment. It was the destructor that was generated, and now it doesn't work way, but I will comment this kind of stuff. I'll repair it in a moment. Build rebuild solution. And now let's see how the copy constructor shows. So now we have ID, first name, last name, and the age have been appeared. So you have a copy constructor that is always up to date, no matter what, how many properties you will add. What I have shown as an error, it was this deconstruct, and this is generated also automatically to deconstruct this class on their properties. And because I have added another property here, it was generated another here that it gives back to the error that here should be more than 3, should be 4 properties to do this. So this is the copy constructor that was generated very quickly. There are also something that will help you when you're done testing. We have here the interface iPerson, and we have here new person mock. What is this person mock? How it was appearing, because it's not here, it's not here. So this person mock, if I go to F12, it's basically mocking the iPerson with a class that was generated that has history entries, that it has mock first name and the property, the first name that you want to mock. And this was generated automatically by the NuGet package mock source generator that intercept your code, sees here that you want to mock something, and says that, okay, it ends with new something mock. So the programmer want to mock a class that it will be named person mock, and it want to mock to this iPerson, and it generates the source code accordingly to you have the mocking just ready for your needs. So it generates code for you for mocking and using for test the class person in the mocking situation. So it has mocked, let's say, to the person mock, and it has mocked now also, it has mock ID, mock last name, and it has mocking also the age that I have just added to the code. So this kind of stuff, it's helping a lot to not copy-paste code every time, but generate code from your existing code, like the properties of the class, generate copy constructor, generate mocking, generating new enums. The possibilities are endless. And now I'm going to the last example, struct trace with roasting source code generator and open tracing. Let me go to the examples. Auto tracing. Okay, so Jaeger, it's an open source end-to-end distributed tracing that you see here. And the Jaeger, I have put an Jaeger in the Docker, and it answers on 16686. Let's show you how it looks. Oh, sorry, it was not Jaeger, but local host. I have on my computer, and it's Docker based. So I do not have here services. If I refresh, you will see that Docker is showing himself Jaeger query, but this is not the stuff that I want to show you. So now we have a program that is .NET framework, .NET Core, sorry. And what it does, basically it's calling Bing. Let me find Bing. And it's just a simple source to show you the possibility of Docker and the possibilities of how to intercept this kind of stuff. So if I put Jaeger to the work, I run the program. It has a Swagger. And I said, give me, sorry, let's put into the auto tracing here. I do not want IIS Express. I am very happy with this kind of stuff with .NET Core. Just a moment. So the program starts, and in a moment I'm going to Swagger. So the program starts. The Jaeger is already intercepting the calls. If I get refresh, you'll see here that it's intercepting the calls for the Swagger. And what I want, I get the person with ID 10 to see you how Jaeger shows me what is happening. So again, it's going to the Bing, and it has an argument exception. It doesn't do many things. It's very simple. So if I'm going to Jaeger and says I have the service auto tracing and the operation, let me refresh, because the person with ID 10 I have already done. So we have the operation person ID, and I said find traces. You see here that I have 4 traces, and this is the calling to the Bing. But I want to know how it was getting there, because before going to Bing, it is called by search and load data. That search and load data was called by this kind of stuff here. So how we do and see what is called when and how. This is very simple and can be done in a CI integration when the code is automatically built. Just replace here with auto. What is this magic? It's a auto methods source code generator that has a custom template file that you can modify and sees all the methods that have the method prefix auto. When it sees that it has the prefix auto, it replaces the method, it generates another method without search that calls this auto method. So I modify here the auto and put in various parts the auto. You see here the search full name, it was calling this search full name. I put auto, when we'll be building, it will generate the search full name with the same properties to be called, and the search full name will call this auto search full name. So it's a level of indirection that will allow me to see what the program does. So I put auto everywhere. Again, I'm doing manually, but this can be done into a CI scenario. And after this, I am building again. You'll see here that Jaeger, again, has just 4 traces until Bing. Let's go and going to build a rebuild solution. In just some moments, please. Okay, it is building the project. Good. Let's start the project, and we'll go again to the Swagger and request the same person, 10, and see what will be there. So this is loading. And I put again execute. It was refreshing. Let's try it out. Put 10 here, execute. It takes a little longer, but now in the Jaeger, if I go to find traces, you'll see that this is the same auto tracing, have 9 traces. And if I go here, you'll see that the person ID that it was called goes to search and load data, goes to search and full name, and then goes to my data source. If I want more, I can instrument all the methods. I can instrument this auto dates. We put in the auto prefix here and starting again. Just let's close this. Okay, this is the hot reload that comes into action. Debug, start without debugging. And now you'll see more traces. Let's see how it's done here and see what the properties are in search and load data. It says call from file. It says else. So what was the method that was called? And class.method. You will see here what file it is, what line it is, and you'll see here the service that it's business logic, the DLL that was the business logic. And you can see everything that your class has. So search full name, it's called from auto search and load data, is from person repository CS, that the class method is person repository search full name, and line is 46. So you can see, you have a documented trace for this kind of stuff whenever you want, just making a calling into the UI. Let's call again person ID with 10 and see more traces that are coming into the Jaeger. So if I'm going back, and I'll go to find traces, you see here that there now are 12 traces because now Also, the method find depth should be here somewhere. It doesn't have load, but this is not the idea now. So what I have demoed now is that your programmers, you are being a programmer and you want to add logging, you can add the logging that you want by just putting an auto prefix and then modify this kind of stuff with partial class and putting here the method and what you want. You can put a stopwatch, you can put activity source, you could put tags called from and the line and everything you want. And you can add your kind of stuff, not just Jaeger, but you can modify here by adding your logging with nlog or serilog or another logging that you want just by intercepting the method. Again, it doesn't affect you as a programmer when you compile the code and you have the code because it works also without this auto. And just in the CI time, it will compile with the logging enabled. Okay, so this was the Roslyn source code generator. And these are several links that will help you to start and create your Roslyn source code generator that you may want to add to your tool set or toolbox. And the future, I think that it's bright because JSON serializer, that will be in .NET 6 on 9 November, it will feature some Roslyn source code generator to serialize any classes that you want. So instead of making reflection on runtime, it will use the code generated at build time by the Roslyn source code generator. Also, Blazor have this. So I expect more and more code generators to enter in our lives after .NET 6. You can start with .NET 5. Again, a Roslyn source code generator is not a big deal. It's just a simple DLL that has .NET standard in it. Now I wait for your question, if you have any. Thank you for following.
Hey, Andre, that was a wonderful session. So as we wait for questions from our attendees, I have one for you. So earlier we were using some templates, right? Text to templates for generating these kind of things. So how it is different from those approach using text templates for generating our after post build or pre build we used text templates, right?
Right. So how it's different from this kind of stuff? Yeah. The difference between, let's say, T4 templates, I have worked with T4 templates before, and the difference is when it's generated. So the T4 templates were generated, and you can see from the past, by a T4 generator if you run the generator. This kind of Roslyn source code generator, it's capable to see your existing code and generate codes based on your existing code. So from other stuff, from CSV file, from XML file, there are similar T4 templates, very similar. But from the fact that you can analyze your existing code at the moment of the compilation, so your code compiles, your main code compiles, then the source generator can have the source code that was just written and add his source code there. This is very different from T4 templates. You didn't have this kind of possibility. And I have shown you my Roslyn source code generator time bomb comment. How do you do a time bomb comment that just put a comment and generate an error with T4 templates? So you cannot, because you didn't have access to the source code. But with this kind of generator templates, it's pretty easy to do this. You just analyze the output that the compiler gives to you by those method context. I hope that I have answered the question. And my second answer is T4 templates of the past. It doesn't work now. So
and also
just go this way.
Yeah, from a DevOps perspective, is there any changes needs to be done from our pipeline to handle this, or will this be taken care automatically as part of the
It will be taken care automatically. If the pipeline, it works because it's very deeply integrated into the .NET build. So if you use .NET build, it works. doesn't matter. I do not know for the framework. I suppose that it works for the framework too, but I didn't have the occasion to use it in the .NET framework. But from the .NET Core, it works because it's integrated in the .NET Build. So .NET Build does not Visual Studio. Visual Studio just shows you the sources, but .NET Build just runs the source code generator. And it's pretty wonderful. You do not need to modify your CI, but again, if you want to add logging and something at runtime, you just modify the CI somehow. If you want to do this, like I show you to modifying the source code. If you want to add automatically, something should be modified. This lossy source code generator doesn't modify the existing sources, just add sources. Generate new source code. Please.
Yeah, so these files are automatically generated during your compilation process, right?
Right.
So is there any need for us to add these to our source our configuration control like TFS or Azure DevOps, or is it good? Is it a good approach to leave that behind because it is going to generate every time?
I don't think that it's good to be added to the source control. I think that should be generated whenever the need arises. So this kind of stuff, no, because this is generated by a DLL. So as long as you stay, let's show you this roasting source code generator. It's this AOP methods common. This is the roasting source code generator that I have used here. So if you maintain the version, the files will be generated every time in a reliable way with the same .NET build from 5. So if you have Docker or something else that you generate automatically and reliable, you have no problems.
Okay, Anthony. So I think there are no more questions. And once again, I would like to thank you for taking your time and having presented this interesting topic here at Azure Community Conference. And we hope you will return next year also.
Thank you very much, also.
All right. So let's move on to the next session. So next session will start in 4 minutes. Our speaker is already here. It's like image recognition in WhatsApp chatbot with Azure UI, Azure AI. So see you in 3 minutes. Hey, welcome all back. So next up we have Luis, who is going to talk you through about image recognition in WhatsApp using Azure AI. So without any further ado, I'm handing it over to Luis to take it forward. Hello, Luis.
Hello, Aman. Thank you very much for the introduction, and thank you to all the audience that is attending this event. I hope that today, tomorrow, it's a great learning experience for you. So let's get started. Thank you very much again for the invitation. So our topic is image recognition in WhatsApp chatbot with Azure AI. Basically, in the next hour, we are going to talk about some topics that cover the communication with a digital assistant that can answer to some questions or that can analyze what is happening in a multimedia file. So just a very brief introduction about me. I am Luis. I am a Mexican Microsoft MVP in AI and developer technologies. Currently, I am living in Czech Republic. I am pursuing my PhD in engineering informatics at Thomas Bata University in Slim. I am also a researcher and lecturer at this university, also at Tecnológico Nacional de Mexico in Celaya. Greetings. If some friend is watching this event or this presentation, maybe later, because in Mexico it's like 3 a.m. or something, really early there. And well, yeah, I enjoy sharing my knowledge with other people because I consider that it's really great for learning. We learn while we prepare the topic, then while we are delivering, and also after that with the feedback. So please, if you have any questions, any comments, feel free to post them in the chat. I will do my best to try to answer them at the end of the presentation. As I said, it also helps me to learn more, maybe something that I did not consider, and next time I will deliver better topic. Okay, so in our presentation, we will talk about these topics that you can see. First, very short introduction about the topic, about artificial intelligence. Then we will move about pre-built machine learning that we can use in our applications, then how we can integrate it in a specific communication platform, such as WhatsApp, how we are going to do it. Then we are connecting or integrating all technologies. We are making our assistant available to users with some code. I will talk about Azure functions. And finally, of course, we will showcase this topic with a demo. Okay, so yeah, what is a chatbot? Maybe you have interacted with this element, or you have seen this type of applications where you interact. For some reason, this animation is not working. Okay, but the idea is that the chatbot is an AI-based software that establishes or sets up a conversation with a human using natural language. We, as humans, don't need to learn specific commands to get some answer from this conversational bot. We speak in the same way that we would do to another person. So we can ask Alexa, for example, okay, will it rain today? Or can you call Peter, for example? And well, this digital assistant will look up for our contact, Peter, maybe the first coincidence, and will perform the call or initiate the call. So basically, it understands our intention and then proceeds to compose a reply, right, in way of action. So the advantages that chatbots have are that, for example, since they are software, They can combine millions of data from different sources. They are available 24/7, 365, unlike humans. They can be integrated into almost any platform. You name it, Facebook Messenger, WhatsApp, Telegram, Microsoft Teams, and other communication platforms. Sometimes they can improve the user experience and keep human effort to a minimum. And well, they are considered as one of the most advanced human-machine interactions. Oh yeah, now the animation is playing for some reason. Okay, so yeah, let's see. So basically, we ask something and we get some reply. Sometimes the reply can have animations, can have some pictures, and the user can choose something to speed up the conversation or the flow of this communication, right? It's not all the time that we have to type or we have to use our voice to talk to this digital assistant. So basically, how does it work? So user sends a message using their voice or typing, or maybe choosing the option from menu. Maybe the message is, I would like to put 10 euro on the SIM card of telephone number 390, blah, blah, blah. Okay, so this assistant, this software, gets the message, and it has a machine learning model. It has an intelligence built in that process the message. This is called natural language processing, and then proceeds to extract the intention of the user along with contextual data. So in this case, the user wants to buy telephone credit, and some user data is the specific phone number and the amount. So after analyzing this request, after the bot understands, okay, the user wants to buy telephone credit, maybe it performs some validations, like if the number is correct, if the payment was processed successfully, for instance, right? And then composes a reply. Maybe this reply, or usually this reply, is sent in the same using the same channel. Like if the user spoke, then some also spoken message is sent back to the user, or maybe some text. We can identify in natural language processing two important elements: the intent and the entities. Intent is what the user wants. Entity is the context. Some data that will help to perform search on database, or that will make it possible to complete the operation. And one important thing, chatbots don't come to replace humans. Actually, in general, artificial intelligence doesn't replace humans. Instead, it helps. It collaborates with humans to perform some operation faster, but also to that these humans, these employees, can maybe perform other tasks where their skills can be leveraged, right? So the idea, as I said, is collaboration, not replacement. So consider that when you are building a solution. At the end, we are talking about some ethics or some responsible AI, which is important to mention. Okay, so let's take some other interesting topic, which is computer vision. So, okay, we mentioned, or we talk about text, about messages, about natural language processing. So we will make a pause there, but we will recover this topic later. Now, what about computer vision? Well, this is also a core area in artificial intelligence that focuses on creating solutions that allow applications to see the world and make sense of it through AI capabilities. So we can provide to some software a picture or a video. This software maybe has a neural network or, again, artificial intelligence model that is able to process this picture, image, video, frame by frame, or some parts of it. And we ask this intelligence for some specific task. Maybe we are interested in detecting several objects, right? So this intelligence will tell us, okay, here you have a car, here you have a bus, there are two cyclists, but also it will tell you the location in your picture. You can say coordinates. Actually, this is called bounding box. That's the difference between object detection and image recognition. In both cases, you will get some object, something that is inside your picture, but in object detection, you will also get the bounding box, the specific location where your object of interest is. Other specific tasks include brand identification. So, well, I remember that during the Euro Cup, the soccer tournament in summer, there was applications to collect digital album from Panini and FIFA. You could get extra packs if you scan a bottle of Coke, right? So, well, yeah, you broke up the camera and then put a bottle of this beverage, and then it looked for the brand, and then you get the price, right? So yeah, that could be one interesting application to get your users engaged and also get some income. Then there is image analysis or image description. In this case, you see a picture. Well, there is a saying, a picture is worth more than 1,000 words. In this case, we want to create sentences. We want to describe this scene. If you take a look at this picture, the third one, from left to right, you can tell me a lot of things that are happening there. Some of you might focus on the taxis. Some of you might identify the city. Others might say, okay, there is a person with a dog on the street. You focus on the center. Yeah. So this intelligence, this computer vision, can tell you what is happening based on, of course, historical data. Actually, well, yeah, we can say that this natural language processing and computer vision task, usually to create these models, there is a training. The training includes historical data, previous tagged images, and actually that's the next slide, right? So we provide, in the case of computer vision, pictures with tags. So you can start a machine learning training or process, by providing pictures. In this picture, there is a cat. In this other picture, there is a dog. Or even specifying the bounding box. Okay, in this picture, there are 3 cats, and they are located here, here, here. And in this other picture, there are cats and dogs. One cat is located in this position, and one dog is in another position, blah, 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 right? So this is called supervised learning, because we are telling the algorithm, okay, here is the data, and here is what is inside this data. Then this algorithm will go through iterations. Maybe we are building a neural network And this one, through epochs, through iterations, will analyze, will identify patterns that define every class, every tag that we included in our historic data. So this model that is created at the end, this machine learning model, is able to recognize, to predict in a new picture that was not used in training what is inside a dog, a cat, or something that is not identified yet, right? So this is machine learning, basically. It uses mathematical algorithms that can teach itself to evolve while data changes. You don't write a program explicitly to recognize dogs, cats, right? Rather, it learns. It learns from data, improves the accuracy over the time. Usually, machine learning models are not static. For example, maybe 20 years ago, a machine learning model that can predict the taxi fare in New York was created. But in the last 20 years, a lot of things have changed. The price of oil, gas, or even new locations in New York, a lot of things change. So this model might not be accurate because new factors, new context should be considered. So yeah, then this new data can help to build new models. And the same applies for computer vision, for natural language processing, right? We can also train some model to recognize characters. And well, maybe it is able to identify some specific vocabulary, alphabet. But if you want to train it for to recognize Arabic characters, Chinese characters, Japanese kanjis, right? You need to train new model, right, to detect the patterns. And also for face detection. Actually, yeah, the face detection is a topic that is, there is a lot of research about it. And one important thing, if you are building a solution that is able to recognize someone or to detect faces, is to be inclusive. Train your models with all the races possible that you can. Include all let's say, type of models, because you don't want your models to exclude some groups, right? You want, most of the time, that your machine learning model or solution be used by everyone, correct? So again, this is part of the responsible AI and ethics in AI, to consider everyone, right? Then, well, we might talk, we have talked about applications of machine learning and AI. In general, these applications are covered by tasks. So one task might be classification. One common example that you see every day. If you have email account, well, you receive some messages in your inbox, and others go to a spam folder. When new email message arrives to your account, the provider, or maybe Outlook, Gmail, or other servers, they have a machine learning model that analyzes this incoming message. Not only the text, but also the attachments and metadata, maybe the IP address where this email message was sent from. Also it looks for some specific words or topics. And the algorithm has some rules to specify, okay, this looks like a spam message, so it will go to that folder. Maybe it is mentioning that you won some lottery prize, or that you want to meet someone, right? So that's very common, right? And of course, other messages will be valid and they will go to your inbox. Clustering, in this case, you don't know the classes beforehand, but you are interested in finding which, let's say, which users are similar to others. For instance, maybe you want to create targeted advertisements, right? When you as a company send email to people, you don't want to spam their folder or inboxes, sorry. Or also sending emails cost. There is an associated cost. So maybe you want to reduce the messages that you send to your customers, to your users, but you want this operation to be effective. If I am sending a message, I want this to be effective in the sense that the user that receives it will open it and probably will buy something from our store. So if you are selling new product, let's say a video game, you will analyze your customer database and will find the users that maybe follow some pattern and that will be more interested in buying this video game based on previous experience, based maybe on what their friends buy or acquire, right? So they are analyzing behavior, and maybe you fit in one profile similar to other users from other countries, different contexts, but still the behavior is similar to yours, and they already bought the video game, so most probably you will do, right? And regression is used when you want to predict value, double value, decimal value, like a price or some cost, right? Yeah. Okay, so to create these solutions, AI solutions, or data science, you need some knowledge. You need to be probably proficient in R, Python, right, or some programming language. Building a neural network, even though today is a bit straightforward because, well, there are some libraries, there are some frameworks such as TensorFlow or ML.NET that help you to create artificial neural network with few lines of code, but still the mathematics that are inside are important. Right? There are some models that are already created for you that you can integrate in your applications. And in this case, for example, we can talk about Azure Cognitive Services. This is a suite of services and APIs backed by machine learning created by Microsoft that enables developers to incorporate intelligent features such as facial recognition in photos and videos, sentiment analysis in text, and language understanding into their applications. So using cognitive services basically allows you to not think about building an AI model, rather to consume something that is already created. You don't need to create a neural network for computer vision tasks. The ones that you saw earlier, such as OCR, object detection. Well, if you are no data scientist or no AI practitioner, right? You are a developer, you can still infuse, let's say, AI in your applications by using these services, right? So for example, for computer vision, right, we can send some picture to the service. For that, you need to create an Azure resource. I will show you in a second. And you send this picture to the service, and you will get a JSON response as a result. And this will tell you, right, for example, we are performing object detection. You can see the bounding box here. There is a rectangle with X, Y, width, and height properties, followed by the object. Okay, so here it is mentioning kitchen appliance, which is here. Then another object that was detected in this picture, computer keyboard in this position. So here it is, right? And so what you need to worry about, okay, what is the code that I need to send a picture, either from URL or the content as a byte array or a string. You can use C#, PHP, Python, any language that can send a HTTP request, correct? And you will get the result. And well, you can even use an SDK. There are SDK for JavaScript, Node.js, or also C#, .NET applications. And in this case, for example, you can see that I am using the analyze image async. I am providing URL, right? Some options. And then we get the result, such as the captions, categories, tags, objects that were detected, right? So yeah, let's take a look. Just a second. Okay, good. So here we are in Azure. I have already created, let me make this a bit larger. Right? So here I am already in Azure Portal. I have created a cognitive services resource. There are two types actually. One is a specific cognitive service. You can, for example, create a resource that only identifies or performs text analytics. Another specific service for face detection, another one for computer vision, and so on. But maybe from a couple years ago or 1 year ago, there is now cognitive services general resource. So you can use this one for different tasks, right? Actually, I think they are mentioned here. Well, no, they are, well, yeah. You can see here. You can use for decision, language, speech. What do I mean by using them for these purposes? Well, you can get keys and endpoint, right? The keys is basically some kind of password, right? Random, that I can add into my code and also send requests to this endpoint. You will see in C# in a minute. In order to get a response, right? To get the AI analysis. So, well, now I can show you this code. It's the same one that you saw in the slide. So I have a solution. I will tell you at the end what type of project is this one. But here you can see I have computer vision service class, C#. I am using the SDK, as I mentioned earlier. I have my subscription key, my endpoint, right, which I get from Azure Portal. Then I have first method, authenticate. I need a computer vision client that I will use. I will use this object, this instance, for the request, for the analysis. After that, I analyze. Okay, and in analyze, I prepare some features. What do I want? I want to detect faces, color, if there is adult content that needs moderation, for example, the description, brands, and other things that I might be interested in. Then I simply need to use these methods, or yeah, as I said, but you can also send HTTP requests, but you can check the documentation, how you can use your endpoint to send this. Basically, it's a post request. Yeah. And after that, just get the results and use them for whatever you want, for your purposes, right? In this case, I am just building string and returning this string as a result. Everything that was detected will be there. Okay, so very simple, very easy. Just later I will call this computer vision service, right? Method. This one, analyze image, is the only one public from this class. This analyze image first connects to the service, then gets the analysis. Sorry. Okay. And well, so we go back to presentation. Then we have, for our initial task, right, for the chatbot that might analyze or process the text, we have one service known as LUIS, Language Understanding Intelligence Service. Basically, this one performs NLP. It's a cloud-based service that you can train by providing examples or sentences known as utterances. You don't need any previous AI experience to create a solution like this one. As I said, well, yeah, we provide examples, utterances, what the user can say to this bot. Okay, for example, book a hotel in Seattle. I want to make a reservation of 2 rooms in New York, and other examples. But these sentences fit into one intent. So maybe the intent is book hotel. Then you provide examples. Okay, what the user can say to book a hotel, right? And then we provide examples. We also create entities. And as I mentioned earlier, entities are the context, such as the location, dates, the username or ID or something that will be useful to search or to process information. After we provide these intents, entities, and utterances in a website that I will show, luis.ai actually, we click some button to train the model, we can test it, and we can check the accuracy. If it is okay, we publish it and use it in our applications. Otherwise, we refine it. We add more utterances, more intents. We adjust to get better accuracy, right? And then publish it. So yeah, let's take a look. Now, let's go to our second demo. So in this case, I go to luis.ai. I create application, new application. I have already created one. I am calling this one WeatherBot. And in this example, you can see that I have already an intent with the name get city weather, right? I will go back. Sorry, I will go here. Just let me explain you about the intent. So the intent is basically a verb, an action, right? That you want your applications to perform later. Then we have the entities. And the entities, as I said, is basically the context. Dates, numbers, locations, person, people. In this service provided by Microsoft, you can also add pre-built entities. This one is a pre-built entity, geography version 2, and this one is able to identify places, geographical data basically, name of countries, cities, rivers, mountains. Yeah. and anything that is related with geography. Right? There are other pre-built entities, such as numbers, as I mentioned, and the interesting part is that numbers can come in different ways, with digits, position, like first, second, third, even the number as a string, right? So yeah, it is able to detect this. After I click on the intent, I start typing my utterances, my examples. And you can see that I provided 5 here. Is it snowing in Seattle right now? And then I proceed to identify, or maybe the model later is smart enough to identify, okay, Seattle is geographical data. Of course, this is an example, but you can replace Seattle with other city or place or country. It's like a Bible. Another, what is the current climate in Portasar? Or is it raining in London? And yeah, you see different examples. Just give me a second, please. Okay. Good. Can you tell me the temperature in Prague? And so, right? And all these are examples that you can use to for this intent, get city weather. We are interested in this because later, maybe when my system identifies this, I can connect it to some service such as Open Weather Map, right? And I can use their API. That they have a free usage, but also there is some cost. I mean, there is option. There are some limits for the free service, but if you are over this free quota, there are paid options. Okay, but and as I said, well, maybe I want to get actually the current weather in a specific city, right? I just need to send a request to the API by providing the app ID and the city name. So if my bot identifies, extracts this, I will be able, right, to get the weather. Right? I didn't show you something, so but I will proceed now. So when I create these examples, as I said, I can now train the model. This is already trained, then I can test it. And I can maybe ask a question. What is the weather in San Francisco? For example, you can see that I have not provided this exact example here, right? So let's test it. And here we see that this message was identified with this intent, get city weather. If we go inside, you can see that San Francisco was detected as an entity. I can get even the JSON, right? So you can see actually right, that San Francisco City was detected. So as I said, I can provide this to my Open Weather Map API and get the current climate in that city. Right? Of course, I can create some C# application. Luis, when I publish my model, I get also an endpoint for the Luis service. Right? So you can see it here. After I send a request to this one, that you can see here, this is the Luis endpoint. I pass query argument with the text, and the text is the message. What is the current climate in San Francisco? Then I check if the model gets this intent, get city weather, and if so, I look for the geography, for the city itself. Later, as I said, I will send this city to my Open Weather Map API that you can see here, right? So maybe you are getting an idea on what we are going to do. We might have some interface where we will communicate with a chatbot, right? We will send the message, and the message will be processed, and the city will be extracted, right? And we will get the weather as well. Or maybe we will send a picture, and it will be analyzed. So we will have some conditions, some decision to detect whether it's text or image, and then we will call the specific service. Okay? So yeah, this is later something that we will explain. All right. So yeah, I hope that we are understanding everything that we are creating. As I said, when we publish it, we get the URL. So I simply go to my dashboard, and well, yeah, you can see also the accuracy, and yeah. Okay, well, it is already published, so no need to go back. Okay, so I already showed you this. Yeah, on Azure Resources, we can get this endpoint. And credited. Okay, so now how we are going to use some communication platform. It is no secret that WhatsApp is the communication channel most widely used. Millions, even billions of users every day, every month, right? It is growing exponentially, as you can see. And this is a chart from 2020. So you can imagine. There were 2 billion, now probably 2 billion and a half, right? How many of us maybe have two cell phones with two WhatsApp numbers? So WhatsApp has no public API, but there is a private one for businesses. And you can you can contact a partner, Facebook partner, to be able to use this API. So you can simply go to Facebook for Business and contact one of the partners and ask them about the WhatsApp service, right? Or API for WhatsApp. One of them is Twilio. This is a cloud communication platform as a service that allows you to build applications through APIs and SDKs available for different languages and platforms, PHP, Ruby, C#, .NET. Some features that developers can integrate into their applications include text messages, voice messages, video calls, and also WhatsApp messages. So you can create web application, mobile application, desktop application, for example, that creates a video conversation between 2 or 3 users, right? Or also, for our specific needs, to create a WhatsApp conversation. So in this case, we go to Twilio dashboard, right, to Sandbox. And, okay, I will refresh this page. So I have already, of course, created the service or the service in the console. When you start with Twilio, you are given some credit to try the service, right? So you can see I am also using the trial credit. Then you get a sandbox, and I need to send a message to some number. So yeah, I will show you here. Yes. So I have already added this number, and I need to send this message. Don't close basic. This is my phone, the one that you see on the right. So here I am. And it will tell me, okay, message received, you are connected to the sandbox. So from here, I can even send a message, but I will not do this because I want the other way. I want the user to send something, and this message will be analyzed to create some interactions, to compose a reply to it. But I can configure the sandbox. As I said, I want to send a message, and this message will be processed, right? And a reply will be sent. So how can we do this? How can this message, whatever I write, for example, I want to know the weather in Slim. I live in this city in Czech Republic. I want this message to be analyzed, and I have already configured this, but what is this? Okay, that's our next topic. It's very easy, actually, or very straightforward to configure this Twilio sandbox. I will share some resources at the end that you can, there is a tutorial that you can follow, of course, to do this. Okay, so yeah, but yeah, basically also in the presentation, here you have, we get started with the beta. Sorry, it is not beta anymore, actually. We activate the sandbox, we send the message, and in our C# code, yeah, it's very simple. We can compose a message back to the user by in this case, I am using an SDK again. So I create messaging response instance with some message, with a string message, and we send it as an XML. This is XML for TWI-ML format, okay? And for example, this is another application. In this case, I sent this message to the user, okay? So I also have it here. I have Twilio service. It's the same code that you saw. And well, we will talk about the received message now. So how can we have something, some code maybe in the cloud or in some server that gets triggered, that gets, let's say, activated every time that the user sends a message? Some code should process it. So we can have our code in the cloud thanks to Azure Functions. Azure Functions is basically one example of serverless solution. Serverless is when you as a developer don't worry about the server. Don't worry about scaling up or down your resources or what operating system should you install, which is something you consider if you are in on-premises environment or even in infrastructure as a service. You need to worry about memory, CPU, and other factors. Serverless can be considered part of platform as a service, but what some characteristics about serverless is that you only get billed by the processing time. Only when your code is executed, you are charged. And actually, the cost is really cheap. For example, I have a solution that sends probably 30,000 messages per month, and I pay less than $1 US. That's the main difference with app service, because app service is dedicated service, and you are charged for all the time that your web application, web app, or basically your app service is running, right, or is up. And your Azure function, right, is also some kind of app service, but it is sleeping most of the time. It is only active when your code is triggered. And well, what can trigger your code, right? So maybe you specify timer trigger. You want your code to be activated every day at 9 a.m. So yeah, maybe you want to clean up a database. Okay, so every time it's like you are scheduling a task, right? So every time the code will run, and all the time that it's let's say running your process, you will be charged. So maybe 10 seconds, okay, 10 seconds. Maybe we have a mobile application. The user takes a photo and store it in blob storage, or in our code, we send this photo to blob storage. Maybe we created a blob storage trigger. Every time that a new picture is sent to this storage account, to this specific container, we have a code that creates escalated images, right? And this one automatically runs when this new picture is received in this container. In our application, we only send it to blob storage, and this one automatically executes. There are other triggers, and there are bindings. The bindings means the context, like the file or the container or something that will be useful for the code. So you can see some example. We have two storage accounts, two storage containers. One has input direction, the other one has out direction. So the input is the file that is received, the file that is actually, not received, sent by the user, received in our account, okay? So you can see this file name, and this file name is here. Then, and also, or maybe the byte, array byte, it's the same. We are binding these elements in our code, and we are producing an output. This output block is a different container, right? And we create escalated version, maybe with the same file name, but of course, different location. And in this case, we are using some package that creates a resized version of it. And you can see simply that we just specify the output block, and that's it. We don't need to add the SDK of blob storage. The code is very simple. Well, it depends, of course, on what you are building. And I skipped one slide, but it was not on purpose. We can use Visual Studio Code, Visual Studio 2019, or next week's 2022, to create this kind of solutions, right? And we can debug them as any other program. So yeah, let's go to our code. And actually, this project, this solution, it's an Azure function project. And here I have a receive message function. This is an HTTP trigger function. It means that every time that we receive an HTTP request, this code will be executed. You can think of it as a webhook or as an API. You have an API, maybe you created with ASP.NET Core, and you publish it to app service. Well, you can also create APIs with Azure Functions. And in this case, this is where we connect everything. We are going to send a message, and you see that we get the content, the string. Then we are going to process it. For example, we are splitting because actually this is like URL. So we are looking for some specific arguments. And this is the WhatsApp content, the WhatsApp message, but in URL format. And we are looking for a specific parameter, new media, right? If it is present, it means that there is a picture in the message. So we are analyzing this here. If this is, if not image, but if there is a picture, we extract the URL of that picture and we send it to our computer vision service instance that you saw earlier. But if there is no image, it means there is text. And this one is sent to Luis service. We get the city and we get the weather, and we send a reply in text. After that, we just need to compose the Twilio message, and we send it back, right? This code is, let's say, local, but I can publish it. With Visual Studio, it's very easy. I have, I think, the information here. Right, yeah, we can publish it. Sorry. We can publish it. And then at the end, we will get a URL. We can even check it on the Azure portal. This URL, I will use it here in my Twilio sandbox. And you saw it earlier. There was some space. When a message comes in, this webhook, this Azure function will be triggered. And let's say the application will do something. So now let's see it in live. As I said, this is my phone. So let's do it. I send the message, and I should get some reply. Let's see. It takes some time to wake up, so no problem. I will try again. I want to know the weather in Sling. Okay, so let's try again, and we should get some reply. Okay, it is taking some time for some reason. Okay, let me try with the picture. So let's see here. And hopefully we will get some response. But well, something is happening with this. Okay, yeah, now I see it is already wake up. So I will try again, final test. I want to know the weather. Okay, just simple. Tell me the weather in Sling. Yeah, I got some error, but that's okay. Okay, yeah, now I got it. The weather of Sling is clouds 14. Yeah, it's really nice here. So yeah, basically that's it. This is the final diagram, how everything was connected or interacting. So our message or e-picture was sent to Twilio, then Azure function process it, and if it is text, calls Luis service. If it is picture, it calls computer vision service, and then the reply is sent back. So I will share this presentation to organizers so you can have the tutorial to check it later. And yeah, that will be all from me. If there are any questions, I will do my best to answer them in chat, because probably the next session is already coming. So yeah.
Yeah, thank you, Luis. So we have one question here. This is
yes, please.
Navneet. So
please.
What type of board should a beginner start with?
What type of board
should a beginner start with? So if you are if you are new to board development, how do you start, and where you what type of projects you should look for?
Okay, yes, good. Well, for example, in Azure there is Q&A bot that you can create. In this one, you provide maybe FAQ website or even a document, and the bot will be able to answer questions. So this one doesn't require any line of code, because you can create it on Azure portal and yeah, deploy it in second. And you can even deploy it to a website, because you can get the HTML. You can deploy it to Teams, to Telegram, right? To WhatsApp, I believe, not directly, not yet. But yeah, this is one service, Q&A bot, or Q&A that you can start with. Then you can also use Bot Composer. That one is also for non-developers. You can create the communication workflow without any single line of code. If you are a developer, I recommend you to go to Azure Bot Service, also use Bot Framework, SDK, and start building your own communication flow.
Thank you, Luis. So that's the questions we had. Anyway, it was our pleasure hosting you in the second edition of this Azure Community Conference. And thank you for your time, and hope we will see you next year also.
Definitely. It was a pleasure. Thank you for inviting me, and good luck with the rest of the event. And have a nice day.
Thank you. All right, so we have now Sam with us. Sam is going to take the next session on time traveling in the cloud, time series analytics with Microsoft Azure. So I welcome Sam for the next session. It's like lost him. Maybe he'll be joining in a second. All right, so let's wait for Sam to join back. Hey, Sam. Able to hear us?
Yes, hello everybody. I hope you can hear me.
Yeah, perfect.
All right. Apologies for the somewhat delay because I had to give permissions to share my screen. Hello everybody. I'm Sam van Houten. Today I will talk about time traveling in the Microsoft Azure cloud. We won't go back too long in the time. Actually, we will focus mostly on what is coming, so the future. I actually work as a CTO for a Belgium-based company, at least headquartered in Europe, and we are called Coded, and we are just over 200 people working in 8 different countries. And what we focus on is IoT, Azure-specific solutions. So think about platform as a service, think about AI, and really data-driven solutions. And we really use the Microsoft Azure cloud for that. And that's actually where I will use, let's say, the experience from our projects to share information in this session. So first I will talk and explain what time series is, what time series characteristics you can find in typical data. And then I will actually talk about 4 different services, using these services in specific cases. First of all, I will talk about Azure Time Series Insights and Azure Data Explorer, used to be called Custo. Then I will focus on how we can use predictive maintenance. And for that, I will also, without diving too much in the details of data science, I will talk about LSTM training. So with Azure Machine Learning, that's to predict data. And what I will then do is use stream analytics in order to use that model and predict things in a streaming fashion. So that's what you can expect in the session. I will not dive deep in any of these. I will give mostly a high-level overview and position where they can be used and share some best practices. So you will get, I think, a good understanding of what is possible. I also the slides will be shared and everything is on GitHub. So if you really are eager to dive a little bit deeper, you will find all the information on the GitHub repo. So there's code to train these things. There's code to set up things in time series insights and so on and so on. If you need any further information, please use the comments section to ask your questions, or you can find me afterwards through Sam van Houten, so first name, last name, and that's on Twitter. I think that would be the easiest. So let's go. What I would start with is, first of all, what are time series? Because that's what everything will be built on here, is time series specific data. And for that, I always try to go back to different types of, let's say, messages or things that get exchanged between systems, signals, you could say. One thing is that you have intent. Intent is typically things that you expect something to happen. I give a comment, I ask a query, and I want to get something back. Please update this data. Please make sure that you save this order in that system. So that's typically an intent. The other side, you have facts. Facts are things that happen, and you don't necessarily expect something. You just express the fact that something happened. Like I report that the door just opened. I can also say the temperature has now been measured in this room, and the temperature is X degrees. All these things are possible. Traces, someone logged on to this website. These are just facts. You can just raise or mention a fact. You don't necessarily expect something to happen. So you could say these two actually have already two different names. The first one on the left, you could say these are all types of messages that you typically see in systems with service bus and things like that. And on the right side, you have events, and that's where we will focus on. So we will not have the messages, we will focus on events. And again, with events, you have two different types of events. You have the discrete events and you have the time series. So I think by now it's clear that we will focus on the time series, but what the discrete events are, it's typically something that a state has changed, but they are not interlinked with each other. It could just be perfectly that this order has been created. That's just a discrete event, and you don't really care about the sequence of these events most of the times, and they are typically actionable. Something happens, I have to focus on that. I have other sessions presented that at different conferences where I focus on the service that is perfectly built for these more discrete events, and that service would be Azure Event Grid. But today we focus on the right side of the things, and that's time series. What is specific to time series is, like you can imagine, the fact that they are time ordered. You really care about a sequence of events as they happened. They are often also what we call context partitioned. What I mean with that is, imagine again, and that's what I will focus on. I will focus on IoT scenarios. But if you have 10 different devices, you typically have 10 time series because you will have the context partitioned typically by device ID most of the times. And you can obviously compare different time series with each other, but the time series on its own is typically linked in the IoT case with one device. They typically report conditions, and what is important, they are analyzable. And for that, I think we will focus now on in the next parts on how time series are typically built up. First of all, some high-level examples that I'm sure you can make up for yourself as well. So think about stock prices, and of course, if you could predict those, we could be rich. But we all know that is not that easy. Weather reports is another one. What's the weather typically in this country? Electricity demand is something that becomes more and more relevant with the rise of electricity and electric cars and smart grid and so on. Revenue numbers, how can we predict the revenue of next quarter, things like that, temperature readings, number of passengers, criminality numbers, and you can go on and you can go on. What you always will focus on is that these time series are typically listed or plotted on something like a line chart so that you can see these typical things like trends and so on. And what you have is exactly 4 components in a time series. So a time series, you can typically decompose, and you will see that later on when I talk about ADX, which is Azure Data Explorer. There you can focus on the 4 components and you can really extract them from a time series. And the first component, this is, for example, the trend of passengers, where you can see there's definitely different peaks and so on. But the blue line that you see, that is actually the trend. So it focuses on the longer term variation, where you see a growing number of passengers over time. And if there's peaks in the middle, they are typically averaged out. So the trend shows a slight incline of the curve. That's important to understand. The other one is the much more longer term cyclical effect. Apologies. So what is that? It's typically fluctuation that happens around the long-term trend. And that could be more with things like political circumstances, impact of economic things like crisis and so on. So that is what you can see there, and that you typically get less impact on for, or you take it less into account for predictions and so on. I think trend is much more important for predictions. But a very key component is what we call seasonality. You have seen with the flight curve, like the number of passengers that we have on a specific flight, you have seen that fluctuates every year. And you can imagine that maybe there's a higher number of passengers flying at the end of the year with the Christmas period, and maybe in summer with the holiday season, and maybe less in February, March. And that's what you see. If you see that coming back, then you can see that that is seasonal. And you can always say, okay, we will calculate seasons. For example, in the case of the passenger system, you can say, okay, we will do it on a yearly basis. Whereas if you think about the visits to a museum, you could also say, oh, it's interesting to do that on a weekly basis, like which days are much more busy than the others and so on. So you can have seasonality on different levels. And again, in time series services, like the ones we will show, you can say, okay, let's look at the seasonality, for example, now per day. Maybe you have the business hours that are more busy and so on and so on. But you can as well do things like by year, by month, and so on. All right. What is important is that the seasonality is typically on a much shorter thing. So you have much more seasons in a time series than you would have the cyclical effect, as I said. And obviously you have the things that you are not seeing part. So if you would detract or subtract all the different components that I mentioned, the seasonality, the cyclical effect, and this the trend, then you could say all the rest that you that remains is what we call residual. That's typically random. That could be caused by smaller events that you typically cannot predict and so on. That would be the residual effect. So residual, seasonality, cyclical effect, and trend, these are the components. If you all add these up, that is typically the result into a time series. Now, that was enough on theory, but I think it's important that you get those concepts with you before we can now dive into more concrete demos. And all the demos will happen about around the same scenario, and that's actually engine telemetry. So I will first share what we say the typical reference architecture, and I'll go a little bit faster here. So this is the typical IoT reference architecture that we position at customers, where you can, of course, see that everything left of this red line would be what we call the edge. So in IoT, you typically have the edge setup there, so living in the factory, for example. In this session, we will definitely focus on the right side. And you can see that you have different streams of data that you can imagine. You have the hot pod, you have the cold pod, you have long-term data, and so on. And the things, if you now map all of these conceptual components to the Azure services, you can see that you have a lot of them coming back. And these are the ones that we will focus on. So firstly, time series insights, so the blue box there. And the next one will be Azure Stream Analytics, this blue box. Then we have Azure Machine Learning. And lastly, we will also have the Data Explorer that was not highlighted here. The high-level architecture of the things that you can find in the GitHub repo, and this actually needs a little bit of updating, is this. So we have on the edge, although we will simulate it by a container in the cloud, but that should not matter. We have data that is sending, so 100 engines are sending data. So telemetry, I think 26 fields. And they are sending that into IoT Hub. So we consider IoT Hub the main entry point for all the telemetry in the cloud. On the IoT Hub, we have a stream without writing any letter of code to time series insights. That's the first demo that you will see. We also have that IoT Hub going into Stream Analytics, streaming all that data, where we will have queries. And if we detect, that's for the predictive maintenance, that a specific engine needs maintenance, then on the top right side, we can say, oh, now we will raise an event, and that event will be handled by, in this case, Logic Apps. We will not dive into that part, but just think about, you have streaming, you have detection of events, and the handling of events, you typically let it over to other services, like the ones on the right side. With the machine learning, we will use the data that we collected, and we will train a model that will be used by Stream Analytics. And the piece that is missing on this architecture is Azure Data Explorer, that you can actually see on the same level as time series insights. All right. The data that we use is based on public data from NASA. So you can click the link and the thing will be shared, of course, but it's a public data set that is actually taking data from different engines and how they behave. So it's aircraft gas turbines, And the data is containing time series for 100 different engines. And these time series are typically cycles. And that's the data that we are taking into this exercise. What I then have, and again, and maybe I should just click on this one. This is the documentation of the module that any one of you can just go and use to start sending data into. You actually have to bring your own IoT hub if you want. So that's what you could do. You can just do a Docker run of this thing here with the engine module. You just pass your IoT hub connection string. And if you start that up, then data will be sent by 100 different devices into your IoT hub in the cloud. And then you can do whatever you want in that stream of data. So you can see how you can configure things and so on. All the code is available in this repo. So where everything is a little bit explained. So we care about sharing, and that's exactly what we will do here as well. So first component that we focus on, first service in the Microsoft Azure Cloud would be time series insights. What it is, it actually says in IoT scenarios, you get data from different devices. And most of the time, this data is not necessarily having the extra context that IoT typically needs. If a device is sending data into the cloud, a lot of times it does not even know that it's in the building 15 or it's on the production line 5. It just sends data from that specific thing. The only thing that you get in the cloud is most of the time the ID, the device ID. So you know it's production line 5. And then it's you that you typically have to add in the cloud that extra contextual data. You typically combine it with other pieces of data. I will not focus on ADT, which is Azure Digital Twin, but if you would have Azure Digital Twin, you typically want to enrich it with the things that you have there in the graph. And also what IoT typically requires is that you have what we call infinite retention. So you want to have that data available for long-term analytics, both for machine learning, but also to look back at other things. All right. Oops. This would be your canonical IoT data pipeline. So where you collect the data, you process the data, and we will focus here on the store and the analyze. So the data typically gets stored in time series insights, and this is what happens. What I would say is that the most important thing to remember from this is that time series insights comes with two different engines. You have the warm storage and have the cold storage. It says public preview and private preview. That's also something I should update. Both of them are generally available now. So you have these available. But the good thing is, if you want to query data, you have different means. You have the API that you can use for your custom applications. What I will focus on here is the Time Series Insights Explorer, which is just an exploration tool. Both of them are using the Query API, and the Query API is taking into account if it should query the cold storage or the warm storage, most of the time both. What is also available is that the cold storage has what we call Parquet, which is a common structure file available to connect to things like Power BI, like Spark, Databricks, and so on, that you can use there to have your more big data type of analytics. So that's the bottom side there. What is good on the top side is that it gets data ingested. The default services that are available are IoT Hub or Event Hubs. So typically streaming types of data that you can just connect to the Time Series Insights engine. What you also should be aware of is that actually the warm storage, so the thing that you see on the right, on the left, that is hosted and run on top of ADX, which is Azure Data Explorer. And that's the thing that we will see next. So Azure Data Explorer is actually the service that is behind the warm storage engine of Time Series Insights. What you get is also an important thing that we said you need to add context a lot of times, context to the incoming data. And for that, there's three components or three things that you have to realize. First of all, you have to define different types. So for example, I defined a type of an engine. what is an engine looking like, and that comes with the different pieces of data that we get. And there you can add some calculation fields and so on. You can add differences, you can have aggregates and things like that. So that is important, that you can actually say, okay, this sensor is this type, and that type contains all these different fields. It's like a schema for a type if you want. You can add hierarchies. So if you have, like I have in the demo, 100 devices, you can easily just show these 100 devices grouped by, for example, region and things like that. That's a structure that you can add to yourself and does not require the incoming IoT events to contain that information. You can just link that in your cloud side of things. And then obviously you will use the instances. So for, in my case, 100 devices, I will say, okay, each and every device belongs to this hierarchy and is of that type. So that's the things that you can have. Obviously, setting metadata like this is something that is exposed through the API. So you can all automate that, of course. So imagine that you have a provisioning way of adding new devices. In that workflow, you can perfectly say, okay, let's add a new device, and that device should automatically be added to my time series insights infrastructure. That's typically something that you would make part of the automated workflow. Okay. Time for a demo. And as I said, the demo is about time series insights. So let's have a look and find my browser. Okay. It seems when giving permissions to share my screen, I close my browser. So let's go to the dashboards. And this is the dashboard where I can focus on the time series insights. So what we will show in the first demo is the visualization of the time series Explorer itself. I will show you how the metadata works, how you can save and share queries, and also what the marker is. So clicking here brings me actually to the resource in my portal. That is the Azure time series environment. What I think is important for you to understand before we will not dive in all the details here, but is the event sources. So I have, as I said, an IoT hub, and I added that as a source in this time series insights environment. So you can perfectly see what is typically used here. When do we start? I'm using a specific consumer group. If that is something that you're aware of from Event Hub or IoT Hub, consumer group says that it allows someone to have checkpointing of, where am I with the offset of the reading of that queue, to have that totally independent from other consumers, right? Because the IoT Hub, in my case, is being read by 3 services: Time Series Insights, Azure Data Explorer, and Stream Analytics. So this is the first one, just using that one. So that's the only thing that you have to do. You link your IoT Hub where my messages are coming in. You link that as an event source to the Time Series Insights, and that's all. You wait. You don't have to define any schema and so on if you don't want that. The only thing that you can then do is go to the Time Series Insights Explorer. So you click there, and you see you're taken a little bit out of the Azure portal itself, and you're brought into a dedicated portal, which is also not bad, because in most of the cases you want to have the time series exploration done by people that you probably not always want to have, touching the actual infrastructure behind things. So you don't want to have them removing devices from IoT Hub by accident and so on. You just give them access here. And what you can see on the top is the time series timeline, actually, where you can see, okay, how much data do we have? So this is data from 1 day, as you can see. If I say, okay, let's use a little bit of data less, you can just scroll there. As long as it is in the yellow band, it means that data is coming from the warm storage. So in my case, I only have data started from yesterday morning. All of that data is still in my warm storage. So that's also something that you can specify in Time Series Insights. How long is my warm storage? because typically you pay more for the worm. You can use that to use these things. What you can then do, and maybe I should first go to the metadata. I got it by now. I can say, okay, this is the definition of types. Imagine that I would have different devices in my IoT stream. Here, in my case, I only have one device type, which is the engine. But you could say maybe I have another thing that says this is a turbine, and another thing that says this is the exhaust, whatever. You could define them as different types. In this type, you can see these are all the different elements that I get in. And they are defined, for example, here as this is the event that I get, and this is the field name of my event. So the mounted corrected fan speed, and I define it as a double. You can also say if you will show aggregated data of this, what do you want to show? Most of the time it's average. For example, a temperature, you would say we will show the average. But if you say it's, I don't know, the total energy that it, or the fuel consumption, maybe you say that needs to be a sum because I want to have it all aggregated. So you can see there's a lot of things that you can specify there. And what you can also specify, like here, is actually calculated fields. So what I said is I here make the comparison between the LPC and the HPC outlet temperature. And that's just by having a calculated field, and I give that a different name. All right. So that's how you can perfectly specify all the different fields in a specific type. This is a hierarchy that you can specify where I say, okay, we first have a type and then we have a region. And the most important thing is then for every device, so I have 100 engines here on my IoT hub, I say this engine actually belongs to this type and this region. So I actually map where it belongs in the hierarchy. Again, you can all do that automatically through the API or just by importing here a JSON file. All right. So that's typically something you do up front, and that allows you then to have here on the left side, I can say, oh, I'm looking at my hierarchy engine, and I can say, let's go to the CMAP in Europe, and all these engines belong in that category. If I then say, let's click on the 70, and let's have a look at the HPC outlet and the LPC outlet, you just add them. You can see that this is typically showing curves, charts actually that have the time series specified for this 21 hours. You can see that it is not showing all the values because it has what we call these min-max shadows. For example, here, that is actually showing, so what you see here is the average, because that's what we defined. The average temperature should be the actual line, but the min-max is for that specific threshold. We can see that the minimum and the maximum are higher or lower to the line. You could now say, oh, this is not good enough, so let's dive a little bit more in the details, and let's take maybe this 1 hour of data. And you can see now we no longer have the shadows because we actually have every single measurement point visible here. We don't have to do any aggregation because we are small enough in the window size to see every actual event. Right? So if I go broader like this, at a certain point in time, you will see that it adds these shadows. So again, diving in the details here, what I can then say, let's have a look at this peak. Let's just zoom in here. And maybe I will say, okay, what fields are this? And I can just say, explore the events. So by exploring the events, I have the raw data, and I can perfectly see engine 70 at this moment. And you can see that all of this is time series data that is ordered in time. You can perfectly see for every value, for example, the bypass ratio that I just added, what was the actual measurement. So that's all possible. What you then also often have to do, because you might want to use things like Excel and so on, is just download this as a CSV. Easy as that. So you have, if you want to have just an overview of what is coming into your IoT hub, the only thing that you have to do, add your time series insights instance, link it with the ingestion stream, and you're already able to explore the actual data that is coming in, and all with a schema-less approach. I did not have to define the schema. All of that would have been done automatically as well without the modeling. What I can also do is say, and maybe I have to close this first, I can save some views. For example, let's have a look at this one. I actually have saved this view. And what you can see is I have added something here. This is not necessarily a peak, but I just said what is causing this peak by adding a marker. And I now can add another one saying here, demo marker. So this is something that I can say, these are specific fields, and that's important. I can then perfectly say, let's have a copy here. And if I, oops, this should not be a private session because I have to log in, obviously. But if I would share that information to, or that link to my colleague, that colleague would see the exact same view with the indications that I made, and he or she can have a look at the details there. You can obviously say, I will duplicate this so I have more data, and let's maybe show the value, the fan speed deviation, and so on and so on, right? So very easy, very intuitive to have all this information done by time series insights. Not any letter of code, everything automatically. That's the thing that I think is very important. If you want, you can then say, okay, I need to have this information, these charts and so on. I need to have them in my actual, let's go full screen again, in my actual application. For that, you would query the API. So you can make the query API, typically from JavaScript or just with your playing REST clients. You just call the query API. It's not the easiest or most intuitive API, I have to say, but you can at least get those time series visualized in the way that you want them. So by aggregating in time windows and things like that. So that was the time series insights thing. What we have seen is that that is valuable at a lot of IoT cases that we have built at customers, but not always good enough or not always rich enough to have the real insights and the real details, because you're limited in functionality. The Time Explorer is really interesting, but sometimes you just need more. And that's where we see that Data Explorer is coming in. Data Explorer is, as I said, the engine that is behind the warm storage of time series insights. It is also the engine that is behind things like log analytics or application insights, probably both, but at least one of them. So it's a very powerful query engine that is also supporting a lot of time series specifics. So it's used to be called Custo, and you will also see that in the query language name, which is called Queql, KQL, so the Custo query language. How does it work? Actually, you have to do 4 steps. That's what I did as well. I think this morning or yesterday, I set up this extra part of Azure Data Explorer in my demo. So the first thing you do is you define a new database and a new cluster. You can just do next finish in the portal, obviously also using your automated resource deployments in reality. It supports auto-scaling, which is also an important thing. If you have certainly higher queries, it will scale out and in where needed. And you have to set up, as a next step, ingestion of data. There's 2 pieces of data that you can ingest. I focused on the streaming part because, as you know, every minute there's 100 events coming in from my simulator. That's a stream of data, but you can also add batch sources. Then you say, that incoming data, I have to map it to a destination table. You could compare it with a table in your SQL database and so on. So you just give it a name, and based on the incoming schema of, for example, IoT or Event Hub, it will automatically be able to define the schema for your table. If you want, you can also customize that and so on. But there's something, I forgot the name, but it's like a wizard for Event Hub and so on that just automatically defines a table. You don't have to do a lot of work for that. And as from then, you can say, okay, let's now use the Kusto Explorer to just have queries written. And obviously, you can call them with the API. And that's what we do most of the time at our customer projects where we are using ADX, so Azure Data Explorer. We query the API with Kusto queries, and then we take the results and visualize them in the specific applications. All right. You can then have integration with Power BI. There's notebooks that you can use and so on, although they are not always supporting the full functionality, especially around the time series for this session. And what is possible specific to time series? Because you don't have to have time series data to use ADX, to be clear. It's good enough if you just have data that you want to query and it's huge, that's fine enough. But time series is supported and there's specific functions that get to it. So you can think about seasonality support, you can think about regression, you can think about filtering. All these things are possible with well-documented functions. And these are the functions that I actually, and again, I will not dive in the details, but these are the functions that I think are most important to link to the 4 components that we said initially. So the next part will be, again, showing how a query looks like in Kusto. But you will see that I will make use of the make series. And make series is actually just taking a numeric value, for example, the temperature of the fan. And it's taking that value combined with the timestamp. So you have to say that the column in my table is, for example, event time. The value that I want to make a series out of is the temperature. And I maybe want to group it also. And that was the case for me. I want to group it by the engine. So I have 100 engines. I have that one specific measurement value. So that results in 100 time series that I have. Okay. And with those time series, you can then do specific things. Like I want to do a decompose. And decompose is actually decomposing the at least 3 components of the time series. So it's not necessarily the cyclical component. As I said, that's less relevant most of the time in queries like this. But it detects seasonality, it detects the trend, and it detects the residual if you subtract those ones. You can also say, just give me the seasonality. And is there seasonality on week, day, month? You can do that with the series seasonal. You can also detect periodicity and outliers. Outliers are typically, values that are a little bit outside of. You can also specify the actual thresholds to be an outlier or not. And the last one is also interesting because there you can say, based on the series that I have, please now make a forecast. The forecast is not really machine learning, it's purely statistical functions that are quite often powerful enough. If you have seasonality, trends, and residuals, it's easy enough to predict at least based on the trend and so on, what would be the next things. So this is not necessarily with deep learning, this is just statistical analytics. The link that you can see here on the bottom points exactly to all the functions. Maybe I can click it easily. These are all the functions that you have here on the left side for time series specific data. So again, this would lead us too far to have all of that explained, but you get the gist. So as a second demo, what I will do is not show how you set up ADX because that's easy enough and it also takes some time to spin up the cluster. No, I will focus on the Queckle, the query language of Kusto. So going back to my dashboard here. So demo 2, the cluster setup I can show, and then we will focus on how the data ingestion was done, but we will spend the biggest part in the actual Explorer. You can see this is the cluster. The cluster has one database. You can see what's the cache period and things like that. So all of that is available. You can see how much data is in it. Not a lot at this stage. We have customers where we have multiple terabytes of data. So this is, of course, nothing here. You can see how it scales up, scales out. But what I want to dive in here is the left side is in the databases. And if I click on this database, you can see that there's one data connection. And that data connection actually has a link to Event Hub. It could also be IoT Hub. And it actually says all the data that is coming in from IoT telemetry will be sent into this specific table, the telemetry table. So I'm using all of that, and I also say that it data format, and that's important for IoT Hub and Event Hub. You have to say multi-line JSON, because you can have batches of data with multiple JSON events that are just with a new line separated. So I initially set JSON, and then it didn't work. You have to specify multi-line JSON, and then you see the data coming in. So that's how you can specify the actual data connection. And you can also see how much data is being processed and so on throughout the different times. So that's all. That's my cluster. That cluster has ingested data from IoT Hub, again, without any letter of code, and it sends the data into my actual database. So if I now say, okay, let's go to the query. And it's loading. Then you can here see, let's just do a query, for example, and this is probably the most easy query you can imagine. It's like you would say, select top 10 star from telemetry. That would be the query in SQL. Well, that's the query that you write in Kusto. So you will see that you use the pipe sign for every next step. And there's not a lot of things like select, where, into. Most of the time, it's a sequence like that. I have some things that I still have to do a pull request to my repo as code, but you can see these queries will be made available, so you can also start playing with them. And let's take this one. So what I'm specifying first, maybe I can zoom in. Yes, so first I say, let's take the minimum and the maximum time of the event time. So that's just, this is like setting a variable. So I specify, take the minimum and the maximum timestamp. And then I start with my actual query. I say, let's use a telemetry table. What I then said, I'm now transforming something into a time series. And what I'm using is this field, the corrected core speed. And I will take the average for the time series. This is the most important field, probably, is the event time. So that's the field I have here. So that's a timestamp field in your table that you want to have your time analytics done for. And I do that, in this case, between a min and a max that I just took. And I say, let's take 10 minutes. So I will take the average over 10 minutes. So it's like a time window. And I do that by engine ID. So as I said initially, that would be the result of having 100 time series grouped by the average of the corrected core speed for every time seconds, 10 minutes, sorry. And then I start doing things. I detect the periods. I said the period has to be larger than 0.7 and so on. And I say, just now take the top two based on the slope of the periods. And I will, maybe I should just hide this one and run this query first, shift enter. You can see how fast it goes. You can see it's engine 50 and 26, and you can see all these values. But obviously this is not showing so much. So what I can also do at the end is I render a time chart. So I do shift enter, and now you can see it shows those values in a much more understandable fashion. A time chart that I could give a title of the top two demo. You can see how fast it goes. And if you want, you can dive into details of how much was spent on CPU on the actual time, what's the disk hits and things like that. So all of that is possible for you to see, and also to query to the API if you want to understand these things, because this has impact on your pricing. The last query I want to show is one of these functions where I actually say, using the same thing here, I make the series, and maybe I should say, let's take 1 minute, and I will make a forecast. I will say, what is the forecast? And I'm doing that for 7 hours ahead. So please make sure that you predict values for the next 6 hours. And I only do that for engine 6, because otherwise I would have 100 curves. I don't want that. I just said I'm interested in what the next thing will be for my engine 6. And if I do Shift Enter, you can see that this is typically what is expected. These are the reads, and these are the ones that we will expect in the coming, I think, 7 hours. All right. Again, the actual source code will be available in my repo. You can have a look at that and start playing with that. So again, if you take the engine simulator, you connect it to IoT Hub, and you connect your Data Explorer, you actually are free to start using that information. Next, and this is the part that I will skip too much details, because this has a little bit more data science to it. But this is what I actually want to do. I want to prevent the outages of engines by doing predictive maintenance. For that, we use best practices that we call MLOps. So most of you are probably familiar with DevOps. Actually, MLOps is DevOps for machine learning. So where you interactively train, you register your model with Azure Machine Learning, and you start using the model. But if the model is not doing good predictions anymore, you have to retrain the model based on new incoming data. And all of that is automated through the cloud. These are some open source components that you can just use, that we contribute and actually maintain, which is Arcus for both machine learning and Azure Machine Learning. And we have many others. So just click on it, free for you to use as Python packages in this case. And we have many NuGet packages for the .NET community as well. But what we typically do with machine learning at our customers is first, we train locally. So because our data people want to have quick feedback, so you have a smaller data set, and you make sure that you detect the right syntax, that you say, okay, I'm using this type of network, and you have immediate feedback. So you do Shift Enter, you wait 1 minute, you see the results. And by the time that you say, I probably have something that I can now train on the larger data set with more hyperparameters and more scanning so that you take more time, that's where we say, okay, let's now schedule the trainings in the cloud. And for that, again, we use Azure Machine Learning, because there you can have multiple trainings scheduled behind the scenes. They are just generating Docker image, scheduling these Docker images as containers in the cloud, and they are running them side by side. And with the Machine Learning Studio, you can follow up everything. What I don't want to dive into details is the different networks that we use, the different algorithms to train. The only thing that I think is important for you to remember, if you're interested in that, is that the LSTM had the best, so that's a deep neural network with long short-term memory, that had the best results, so an accuracy of 93% with a window length of 30. And this is details that I can easily skip. If you want, you can have a look at that later on. So let's just show the results of my actual Azure Machine Learning components. Let's go back to the dashboard. Okay, this is here. So this is my Azure Machine Learning studio, where you can see I have, for example, a notebook. So people that are familiar with that might recognize that. So I'm just running a notebook on a machine in the cloud, not locally. I can do it locally, but I did it in the cloud, where I can just execute all of these cells. And maybe let's see if it's still in my memory. Let's do Shift Enter and see if it works. Yep. So I'm now scheduling a new training in the cloud. As you can see, there's one node that will be running, and I'm doing that with these, what we call hyperparameters in most of the cases. So I'm using a window length of 35. I'm using so much nodes and a dropout, all things that you don't have to worry about. Just know that I can schedule a second training in the cloud as well. And now I have 2 trainings that are being scheduled on target nodes in the cloud, because I have some compute there. You can see that I have the CPU here, CPU node, with one node that is being started up and so on. What is important is that the training is now running. I can just close my machine, which I won't do because I would lose connection with you. But you can follow up those experiments, so I can go whatever I need to do, and I can get back later on and see once these experiments gets completed. So this is the first one I scheduled just a minute ago, and the second one that is now being queued to be scheduled on the same compute. But for example, I did this one here. This was the result, and I can perfectly go back and see what was the actual input. For example, this was the script that I used in the training. I can see the exact script. So even if someone did not commit to the repo, if someone did not did changes afterwards, you can see the output of my best training is actually based on this specific script. What I can also see is some metrics. If you're familiar with machine learning, this is what we call the confusion matrix. You just have a true or false that we have to predict. And you can see that these are the ones that were predicted correctly. And here we are the ones that are not predicted correctly. So if I hover this one, it says I had 170 cases where we predicted that there was not need for maintenance, while actually the training should have predicted that. And that means that we have an accuracy of 95%, which could be good enough or bad enough. That's all independent of that. The thing that we say, if this is now my best training, my best model, you can then register your model in the model repo registry. So it's available here. And then you can start hosting that as an endpoint. And that's exactly what I did yesterday. I actually said, I'm setting up a new endpoint, which has actually an API. So this is the Swagger, and a REST endpoint with some keys. So people can now just start consuming through REST. So by this endpoint, and you can all see my primary key. So I will have to regenerate it. And you can see how do I consume it from these and these and these. So you just start querying the endpoint, and you will see, you will get back based on specific data, do I have to plan for maintenance or not? That is the actual model that we have exposed as an endpoint in Azure Machine Learning. Behind the scenes, it is running on a container instance, so ACI. You can also run it on AKS, so a Kubernetes cluster managed by Azure. And you can also host it in Azure Functions. So that's the only part I think I should show about Azure Machine Learning. But again, if you want, the full notebook is there. You can have access to all of the things to set it up yourself if you want to dive deeper. And the last part of this session is about Azure Stream Analytics. So with Stream Analytics, you actually are building what we call standing queries. So it's a query that stands right in the middle of the full stream of data that comes in. And you have sources. And again, you can imagine, just like we did with ADX and time series insights, here we also have IoT Hub as a source. So the source is streaming all the data into this engine here. And this is the cool thing. In my demo, I will show how we actually call the actual model that we just published, how we will call it from that stream. And then you can forward it out to a real-time dashboard, to storage, to events, and things like that. What you have to do is to define your Azure Machine Learning model as a function, a UDF, user-defined function. You can do that. There's some explanation on how to do it. So again, not diving in the details. And what you then have to do, you can say, okay, you give that function a name. So this was predict maintenance. So here I say create time windows is also another one. I want to have the last 30 images, 30 records in the specific time window combined into one field that I call my model with, because my model actually expects the previous 30 items that were measured so that it can predict based on the last 30, do I need to have prediction or not? And for that, let me switch the last time to the actual Azure portal. So I will explain a little bit on time windowing. I will show how the Azure Machine Learning function works and where the in and the outputs are. So this is my actual field. The most important part is, of course, the actual query. So while we are opening the query, you will understand that it looks much like SQL syntax. And what I'm doing here is I just define the incoming data. So all these fields that I have in my IoT Hub, I define here in the table. Then I say I have to make sure that I collect those time windows. So I make groups of the last 30. It's like a sliding window of 30 images. And the last part is I want to output into the engine maintenance something, the result of the needs maintenance user function. And that's exactly what I have defined here on the left side. The needs maintenance is the link to my actual endpoint in Azure Machine Learning. So it says it expects an array and it will return an array of data. And based on that, we will then save the data into the output, which is, I think, is a table storage in this case. Again, very high level view, not in the details here, but it's important for you to have an overall picture so that later on, if you want, you can focus on specific services like that. So to wrap up, before I say thank you already for hosting this insanely big conference, I'd like to wrap up with, let's say, the integration of everything. Yeah? So getting back, and the Data Explorer is missing here, but we focused on these four services. You can see that if there's maintenance detected, that we have a full isolation of handling these events from the actual detection of these events. So what Azure actually offers, you have different time series options. I think the easiest one to get started is time series insights. If you need more power, more fine-grained access, I think ADX is the thing to go to. With machine learning, you can focus on predicting the future. If you obviously have some experience with data science. And the good thing is that there's a lot of out-of-the-box integration with things like Data Lake, with Power BI, and so on. So all these services that you've seen, they actually all are seamlessly integrated. And I actually did not have to write any letter of code to show them in these different things. You can focus on syntax of your queries, and that's about it. With that, I'd like to thank everyone, and I think we are still open for questions before we go to the next session. Thank you.
Thank you, Sam, for that great session. So as of now, we didn't got any comments yet from our attendees. I hope if they have doubts, they can post it here. That's we already mentioned. So anyway, it was our pleasure hosting you here at the second edition of Azure Community Conference, and it was a pleasure having you, and we look forward for your session next year also.
Okay, I'm happy to, and congratulations on the good setup. Good luck with the rest of the conference, I would say.
Yeah. Thank you, Sam. If anybody has questions, they can place that into comments. Otherwise, we will wait for a couple of minutes and we'll move on to the next session. Okay, so it looks like there are no questions. I think we can move on to the next session. Thanks again.
Okay, bye-bye. All
right, so we have 2 more minutes. We will be starting in exactly 5 o'clock. Hey, so next up we have Ron Dagdag. He's going to take you through making neural networks portable with ONXX. And without wasting too much time, I'm handing it over Ron to take you through it.
Cool. Sounds good. We can see the screen. Good morning, good afternoon, good evening, everyone. My name is Ron Dagdag. I'm a lead software engineer and a Microsoft MVP, and welcome to my session. Today, I will be talking about making neural networks portable. So, today we'll be talking about Open Neural Network Exchange, or ONNX. I'm not going to be talking about ONNX for all those Pokemon fans or for all those geologists out there. I'm not going to be talking about ONNX. I will be talking about ONNX, ONNX. So let's go back and let me understand what programming is. And most likely you know what programming is. And then just to recap, you have an input and you have an algorithm. You create an algorithm and you calculate, like in this case we're doing a calculator. You can add, subtract, multiply, and divide, and it would spit out answers for you. Typically that's how we do programming. In the machine learning world, we kind of do it the other way around. Our goal was to teach the computer to build an algorithm for us. So in order to do that, we show it some input. We give them some examples of the answers based from that input, and it would try to understand and build an algorithm. And that's what we typically do for machine learning. So in the machine learning primer, programming here is on the right side, machine learning on the left side. In the machine learning world, that's what we typically call training data. So we have our input and answers. That will be our training data. And we use a training framework in order to spit out a model for us. And once the model is generated, we plug that into our application. And in order to use that model, that's what we typically call in machine learning world, we call it inferencing, and we have an inferencing runtime in order to use that model, and it would spit out the answer. And of course, as a feedback loop, improve our machine learning models later on. Cool. So typically, if you're starting to learn about machine learning, you have some machine learning frameworks out there. We typically use PyTorch maybe to start with, and then of course we deploy it with we run it locally at our machine. And then I found out if you're like a web developer, you have a lot of these JavaScript frameworks. In machine learning world, there's a bunch of more frameworks to learn and to understand. So depending on what you're trying to do, each one of those frameworks have their own specialties and what it can do and what makes it easier. And of course, on the other side, you're not just limited to deploy your models or into just one your software into just running on your computer on CPU. Sometimes you want to run it using a GPU, or in this case, the model can be deployed to run on a specific vision processing unit, where you have FPGA or ASIC devices, or you can run it on the phone, or you can run it in the cloud. So all different places where you can deploy your AI function. And of course, and that's what ONNX does. It's the link between, how you train it and where you deploy it. And think about it as kind of like, you have your, you build a Word document in Microsoft Word and you convert it to PDF. And then now, since it's converted to PDF, now you can view it in browser on your phone and all these different areas without installing another application. It just it it gets converted and makes it portable. And so that's the title of my presentation today, is more about how to make machine learning models portable with ONNX. So ONNX is Open Neural Network Exchange. It's an open format for machine learning models. It is open source on GitHub. To get started, go to onyx.ai. That's the place where you can learn more about these. And every time I would go to onyx.ai, there's more and more partners that gets into the ecosystem. Actually, it got started between the collaboration with Microsoft and Facebook, and now all these different companies have already integrated and have added the capabilities to ONNX. It is on GitHub. It's about 11,000 or more GitHub stars, about 2,000 pull requests, more than 200 contributors. It has more than 2,000 GitHub forks, and about 40 plus model zoo. And I'm going to talk more about that later on. It is a Linux Foundation AI graduate project, so it's actually ready for production. So today, our agenda, we will be talking what is ONNX and when to use ONNX. And then I will show you how to create ONNX models and be able to deploy ONNX models. And I will show some demo code later on to talk about that. So creating on this side, and then of course deploying on the other. Okay. So when should we use ONNX? When you have something that is trained, typically when you have a data scientist in your team, they may have specialty in R or Python. So in this case, when something is trained in Python, and then of course you have an existing app, or your team, your software engineering team, or their specialties are maybe in C# or JavaScript, and you want to deploy it to that application, it might make sense to convert it to ONNX so that they can integrate it to a JavaScript application or C# application. Another use for ONNX is when you have high inference latency for production use. You want it really fast. Using ONNX does not require all the different framework, from the training framework or however you need to run it. For example, all the PyTorch libraries that needs to be installed on that machine. So if you really need something really fast, it might make sense to convert it to ONNX. When the model to run the resource is on an IoT or an edge device, the reason for that is because you have limited resources on that device. So it might make sense to convert it to ONNX and deploy it there, especially when you're running it on a different operating system or the hardware it was trained on. So maybe you did train your machine learning model in Linux, and now you want to have it on a Windows machine, on a Windows app, integrated with a Windows app or a C# application. That might be a way to bridge that gap. When you're combining models created from different frameworks. So, for example, someone was written on a PyTorch, and then there's one that's written on TensorFlow, and you want to use it in your application. So it might make sense to convert the PyTorch model into ONNX, the TensorFlow model into ONNX, and then now you have just one runtime that you can use in order to incorporate to your application. And this is something new also. The next one is training takes too long. That's when we start talking about transformer models, where you can actually do local training rather than sending all your data up to the cloud and doing all the training. So those are typical use case for ONNX, and I'll talk more about that and discuss more about all these different use cases. Step one, we'll create our ONNX models, and then once we convert it, know where to deploy it, how to deploy it. Okay, so last year when we have pandemic and we have to stay at home most of the time, my wife and I, we started to learn how to bake bread and how to make bread. And our problem is, if it's our first time to make bread and we didn't know that you have to have the yeast a certain water temperature, how you mix it. Of course, we ruined the bread and it didn't come out right. And so what we learned from that lesson is, like, there's certain techniques to be able to create the bread properly. And so that's what data scientists do. So data scientists in your team, they're the ones who is experimenting and trying different ways and how to make the bread better, right? To make they build the secret recipe of your company in order to use the proper machine learning techniques, or however to be able to use AI the proper way, right? Or what's the best way to be able to build that machine learning model so that when we start using it, it's good enough to do its detection properly. So in case you're doing like computer vision stuff, and being able to correctly identify that properly, or do object detection or something with the computer vision. So there are 4 ways in how you would get an Onyx model. One is through Onyx Model Zoo, Azure Custom Vision. Either you can convert it to an existing model or train the model using Azure Machine Learning or automated machine learning. So let's start with the Model Zoo. So actually, this is on GitHub. That link would point you to like different. So what they did was, like, there's an already existing model class, right? For example, if you're talking about ResNet or SqueezeNet or something that already have deep research over that we can start using, they converted it to Onyx models, so we can start using that instead of the original one that was from research. So once we start using this, we can easily integrate this, like for example, ResNet, to our existing application. Another one is using customvision.ai. You can, in this case, I've uploaded images of fruits and then I tag them as fruits. And then based from that, because I train, I can click on training, and then what it will do is actually build the model for me, and I can export it as an Onyx. So that right there is the simplest way to get an Onyx, especially if you're doing something that is into computer vision, to do classification or do object detection. Of course, I start talking about this Onyx. What is these Onyx files models right here? It's actually graph of operations that, in this case, if you use this Netron app, so if you go to this website, netron.app, you upload, you drag an Onyx file to it, it would kind of show you a view, something like this, and it kind of gives you the operations and layers, and maybe it'll make sense. We can start. We can see if I can open this Netron app right here, and then what I'm gonna do is I have a file export. Get an Onyx file for you right here under presentation. Let me drag an Onyx file. Let me go find it first. So like on this one right here, I dragged an Onyx file, and this one is just the simplest 2-parameter system, right? You have an input and then it would have an output, and what it does, it just multiplies it. So that's one way you can visualize what, and of course it gets complex from there. If you have something that's really is, a lot more like one of those ResNet models, it will have a series that just something that looks like this. But the advantage of it is that it kind of gives me, as a developer right here, if I can view it, it gives me what is the input and what is the required type of input. Like in this case, I need a 3x4 array of float 32 and for this parameter and this parameter, and then it would give me the output of this. And so as a software engineer, I would be able to say, understand how I can use this in something I can also visualize. So another way how you can get an Onyx model is through converting it from some of these other JavaScript. Oh, not JavaScript, but I'm talking about machine learning frameworks. So for example, if it was written on TensorFlow, there is a converter, or scikit-learn, there is a converter to convert it to Onyx. So 3 steps involved to convert to a model: load an existing model, convert it to Onyx, and then save the Onyx model. So like, for example, in PyTorch, you have to import some, you have to do a pip install on one of these torch .onyx, and then load your PT file, load the model. Like in this case, you have to specify a sample input, what that model looks like. This one, in this case, it requires a 224 by 224 image and 3 RGB format, and then it would convert it to an Onyx model. So that's just an example. So for example, for Keras, in this case, you can use this convert Keras. So you load the Keras model, convert it, and then save it to that. For TensorFlow also, you can use command line. There's a Python command line to be able to convert that Onyx model, specify where that PB file is, and then the output is model.onyx. So different ways. So for scikit-learn, it's kind of like about the same here, converting it to an Onyx format, be able to do the conversion, load the model to memory, do the conversion, and then write it to a file. So that's pretty much it. What you would do in order to convert. You can also use Onyx as intermediary format. So let's say you want to convert Onyx to run on Android, to convert it to TensorFlow to run on Android. So you can convert, let's say it was written on PyTorch, and then you convert it to Onyx. Then from Onyx, you convert it to TensorFlow. So there's a way you can do that. There's also a way you can convert Onyx to Core ML for iOS. So for example, it was written in PyTorch, and you convert it to Onyx. Then from Onyx, you convert it to Core ML so that you can integrate it to your iOS application. You can also use Onyx as to build another Onyx file, so that you can do fine tuning. So you can do, in this case, you might be able to create and train a new model based from a base model. So there's tutorials on how you can do that. You can use also Azure Machine Learning to train models where you have GPU clusters in the cloud, and also do hyperparameter tuning and manage these models. So at the end of the day, what you're trying to do here is you can build and convert it to an Onyx model, and then register and manage these model for you. So Azure Machine Learning has a way to register these Onyx models and have a place, kind of like how you build your Docker images. You have your Docker Hub, right? Or you have some container registry. This is a model registry where you can store this Onyx model, creates versioning, and those kind of things. So now that we kind of have an idea how to create Onyx models, the next step is to deploy them to your application, how to integrate them with your application. So what is the difference between a baker and starting a bakery? Of course, a baker, makes bread or cakes or however, right? But starting a bakery is a different skill set from being a baker. Starting a bakery, it requires business information, right? So where do you put the cash register? How do you collect money? How do you make sure the supply gets in? That you have enough supply, the right crew, the right people at the right job, those kind of things that you have to consider. So it's also the same as in for your software engineers, right? There's the part where of course you have your data scientists be able to think about it. They create the secret recipe, so they're kind of like the baker. But your software engineers, the rest of your team, build the application around so that that machine learning model can be used. So it's also a way to be able to understand where to use that, when to use it, where to incorporate to your application, those kind of things. So it's a different skill set, and that's where the deployment is, the deployment part of here on the right side, where you can deploy it on Azure, you can deploy it on Linux, an IoT edge device, once you convert it into a model. So when I first starting to learn, it's like I wanted to learn more about this machine learning world. I wanted to learn more about data science and all that. And I just realized, coming from a software engineering background, is that the value that I can provide is how to make use of these models, or make use of these AI models, or these and how to integrate it with existing application. Because for me, that's the skill set that is actually needed. A bakery is not functioning. Starting a bakery requires you to have a baker and also the necessary personnel to be able to deploy them and be able to manage these models. And I believe that is more and more needed in the marketplace today. And that's the reason why I'm started talking about this Onyx model, and be able to say, how do we integrate it to our existing application? So of course, whenever you have an application, you have to think about, how do you deploy that? Do you deploy that at the cloud or at the edge? Edge meaning how close it is to your users. So of course, deploying them in the cloud, sometimes it might make sense to just use Azure Machine Learning, where you have your model management services, where you have the Docker registry, but also at the part of it where you deploy based from that model, you deploy it as a web service through AKS, or some container, and then you capture that model telemetry. So that is one way. So you can deploy it as a web service or deploy it through Kubernetes. That is one way you can connect to it. So like on here on the right side, or on the deployment side, where you build an image around that model, right, that you can just deploy it as a service and start monitoring it. So that is one way you can deploy them in the cloud. You can also use this Onyx Docker images as your base for your to publish an Onyx with, like in this case, a Python with minimal dependencies. There is also this Onyx ecosystem where you can have a Jupyter notebook that has Jupyter notebook inside it. So if you just want to convert it, use the Onyx converters without installing anything in your machine. That is one way that you can use and to your pipeline. So like in this case, if I want to do PyTorch Docker, you can do this command below, where you can run it through the CPU. So you have to specify CPU. Deploying at the edge, it requires you to start thinking about, of course, not just the edge also, but the cloud, the fog, and the edges, right? The cloud, of course, we already are familiar with, where you have your massive data centers like Azure. The fog would be the Azure edge zones, where you can deploy some of these workloads to process your data, maybe in the 5G network, or however it, or a gateway somewhere that is closer to your users. And of course, edge device would be something like a heart rate monitor, or something that is that you can do processing, like an Azure Percept would be a good example of that, where you can do your edge processing, or some of your machine learning payload or data processing closer to the user, closer or at the site. So where can AI be deployed? You can actually deploy them in constrained edge devices, or a smart edge device, or on-prem data center edge, or sometimes you can call it sometimes you can do a service provider edge, where you have the regional telco, or of course the centralized data center, which is in the cloud. So there's different ways in how you can deploy your AI models. So AI at the edge, why would you want to deploy your machine learning at the edge? Is because of low latency. You want it real fast. So meaning if if I have a camera frames, right, the camera images that I'm collecting, and I want to do machine learning inferencing on that for computer vision, it might make sense to do your processing at the edge rather than in the cloud, rather than uploading those images, because of low latency. You want the results real fast. Also, the sound processing might make sense to run it at the edge and do AI at the edge. Scalability, because you have a machine that's capable enough and might be able to process your data right there. It might make sense to do that, because instead of uploading those images to the cloud, that cost less, because of your ingest, and also your ingest cost. And of course, flexibility. If you're for these IoT devices that does not have good internet connection, or whenever you're on a plane or one of those cruise ships that does not have good internet connection, it's flexible enough. So of course, there are some areas where the company does not allow you to send data outside of that certain geographic area, that it makes sense to use and deploy machine learning at the edge. And that makes sense if you're converted to Onyx, because these machines right there has low in terms of computing power, and also it might be just capable enough. And once you convert it to Onyx, and you can use this Onyx runtime, which is a high performance inference engine for Onyx model. It is actually open source under MIT license by Microsoft, and it does not just support neural networks. Also, it supports neural networks for those traditional machine learning spec. So if you just want to do regression rather than a neural network, it might make sense to just use Onyx runtime to do that. It's also extensible architecture for hardware accelerators, and I'll discuss more about that on my next slide. And it ships with, of course, Windows 10 and Windows 11 as Windows ML. So if you want to start learning more about this Onyx runtime, the place to go is onyxruntime.ai. And every time when you go there, you'll see this page where it kind of give you step by step how to get started. So in this case, I have a Linux machine, and I'm working on a C# application, and my architecture is x64, right? And then I want to use the GPU, I want to use the CUDA, and then right there it tells me, okay, these are the instructions and requirements in order to use Onyx runtime. So I have to use this NuGet package in order to run Onyx runtime. So that's what I would need. So notice that it has different hardware acceleration models. So if you want to use OpenVINO, so this kind of gives you a guidance, and it's not just limited to just C#, and you have the Python, and you also different architectures too. If some combinations are not valid, it would tell you right here. So, and also there's that part where it says optimize training, so you can do retraining of that Onyx model. There is also Onyx Runtime Web, where it is a JavaScript library for running Onyx models on the browsers and in Node.js. It actually uses WebAssembly and WebGL technologies, the background, so you can actually integrate Onyx model to run in your web application, and it both runs on CPUs and GPUs. So it is on. This is getting outdated, which is the Onyx.js library. It's actually going to be part of the Onyx runtime. It's called Onyx Runtime Web. So compatibility chart, it allows you to be able to run it on Windows 10, Mac OS 1804, Ubuntu, and Android using, if you use the Chrome browser or Edge. The disadvantage of that is you have to download the Onyx model and run. It's actually running it locally on the browser, right? So for the Windows AI platform, this one, WinML is actually running on top of Onyx runtime. So if you have something that you want to integrate it to your Windows Forms application, even though Windows Forms can have machine learning models in running it using Onyx runtime, so that's for the WinML. Direct ML APIs, when most likely when you're writing a game and you really want a real-time high control machine learning operator API. So this is more lower level. And of course the driver model, where you have it automatically knows, Onyx runtime automatically knows if CPU, of course CPU is available, but if it's GPU available, it would use it right here. But it's also compatible with visual processing units that it's available out there, and of course XPU for the stuff that we haven't thought of yet, that might be a different driver that you need in order to run your machine learning model. So if you are interested in learning more about my presentation or the demonstration I'm going to show today, that is the QR code, and you can actually get the links that I was going to show today. But let me start with the demo. Okay, so I have this CSV file, and this CSV file have two columns because I want to do something that's not necessarily the simplest, but the minimum, right? You have an input, which is like in this case 1.1, and then salary. So you have these input and then output. So just this values right here. I have 31 columns. So one input and one output. And based from that, what we're going to do is we're going to create we're going to create a model. And this model, I would convert it to Onyx. So this one right here, I have a Jupyter notebook. Actually, it's just Jupyter notebook. It's Python notebook, right? So IPython notebooks, Jupyter notebooks, is actually running in my Visual Studio Code, and I did install .NET Interactive. .NET Interactive allows me to be able to have C# application or C# code running on this Jupyter notebook. The reason why I'm showing you this is because I wanted to run it line by line and kind of show you what I'm doing here as a project. So this one are just NuGet packages that you would need in order to install it to your application. And so in this case, you would need, in order to convert to Onyx, is this Onyx transformer and this Onyx converter in order to convert it to Onyx. Also, you need Microsoft.ml, which is for the ML.NET. And then, of course, this one right here is the data analysis side too. So in order to incorporate it with our application, we use Microsoft.data.analysis. And this one is just, I don't think I need this cell but I have that from my previous one. So what we're doing here is that based from that data frame is actually coming from this Microsoft data analysis. So this data frame allows me to, like in this case, load a CSV file, and I want to show you what that CSV file looked like. So that CSV file looks something like this, where you have two columns. You have years of experience and then salary, and it goes through those 30 lines or 30 items on that list. I can give you data.description to shows you the minimum and maximum numbers of each one of those columns. Kind of gives you a little bit of what the data type is. So in this one right here, what this static function does is it shuffles an array of items, and then I would use it for testing and training. So that's what I'm doing here. And then now I'm ready to use Microsoft.ml, so which is ml.net, and you have to create the context. So that's why you create a new ML context to be able to start creating transforms. So in this case, what I'm doing is that I want to use that years of experience as one of the features, and I create a regression trainer and using the salary as my output. So create the pipeline, and then there's always that pattern of saying fit and then transform. Fit, you pass in your training data, it will create you the model. And once you have the model, you use transform to be able to get your results. And so you can view your metrics, like in this case. So this is just to create a model on ml.net. But the most important thing for us is based from that model that we created, we want to convert it to an Onyx model. And so that's what we're doing here. There's, you need to specify the model name. I did specify the model name to here. You'll be model.onyx. And then I would use context.model, convert to Onyx. I specify the model that was generated previously, specified data. So that's one of the requirements that it needs. And then of course, where to save the file. So I think this is more of the test data. So just it just identifies a sample input. And once you do that, it would create something like this, model.onyx. And when I go to visualize it, it would look something like this. So this is regression. So it's not really a neural network, but this allows me to be able to export them to Onyx and then actually see what are the inputs and outputs. In this case, there's two things that it needs in order to use this model. You need to specify years of experience and then salary. This is kind of like, it's kind of odd because why do you need salary? Because that's what you're predicting. But if you look at and visualize it, it's just a pass through. It's not really going to be used. So you can pass 0 on salary and it would just be a throwaway. In this case, that years of experience is what you need in order to score the output, so that you'll be able to identify, from years of salary, from years of experience, what is the salary. So that kind of gives me that path to get that prediction model, right? So that's what the only thing that I would need in order to score that output to get my data. But that right there is the first part. We were able to create this Onyx model. And so the next part is I'm going to create and use it. Okay, so in this case, this time I am not doing C# application. What I want to do is to use a Python application. So in Python, you need to use this pip install Onyx runtime in order to start using Onyx runtime. And so using Onyx runtime, I can load the Onyx model that we just generated to this inference session. And then once we have the inference session, we need, so like in this case, what I'm doing here is now I can get, once I have that session, the input. So these inputs right here, I can describe them. In this case, I want to know the first input name. So in years of experience, what shape I need to be sending through Python. And on this case too, the salary output or the salary input, right? Because there's two input, they are in an array. So you get the first input and then the second input and specify them. And then of course I'm only interested in the output, the score that output. So I specify, what is the output, and then get the shape, what it needs to, what would it would be, and then what type I need that it would spit out. So in this case, I can specify, okay, I need an array of I believe none and then one. So it's a one-dimensional array. So I did pass that here and say, okay, I need to specify 2.5 years. And then 2.5 years would give me this value. And notice I pass in 0 because it's not going to be used, but it's required to pass it in as a parameter, so that when I say session.run, I specify the output name and then the input that it needs. And once you do that, you would get the results. And then the result would be something look like this, and then I can filter out and get that value. So to try this again, let's try 10.5, and let's see, it'll give us a different number. So now that we have a different number, and we can extract that result. Okay, so what just happened? So what I did was to create an Onyx model. I have a C# application or a C# notebook, and I created a simple model. And that simple model, I converted it to Onyx. And then I have another notebook that actually uses that Onyx model, reads that Onyx model, and uses Onyx runtime in order to do the inferencing in Python and get the results from there. Cool. So let's go back to the presentation. So after learning all these, this is how it feels like. Onyx is powerful, that you can use it in a lot of different places. And just to recap, what is Onyx? Onyx is an open standard that you can use right now, the right tool for the right job, that that it would run efficiently on specific platform. So how do you create Onyx model? Is you can create it from converting it from different frameworks. You can use some of the Azure tools that is out there, like Azure Machine Learning and all that, and like a custom vision to create Onyx model. And how do you deploy this Onyx model? You can use Windows ML and incorporate it to your .NET application using Okay, it looks like I got disconnected right there, but I'm back. Let me share my screen. So for some reason it timed out. Okay, just going back to this previous slide, just in case you didn't see it. So we did talk about what is Onyx, how to create an Onyx model, and how to deploy an Onyx model if you're and how to use Onyx runtime. All right, isn't that cool? What just happened? So If you're interested in learning more about me, my name is Ron Dagdag. I'm a lead software engineer at Spacey. I'm a fifth year Microsoft MVP awardee. Uh, my personal projects, you can go online to dagdag.net. The best way to contact me if you have any questions later on is through Twitter at Ron Dagdag. Best way to connect with me is through LinkedIn. And I appreciate you spending time with me about geeking out about Onyx, about baking bread, and about Onyx runtime. Appreciate it.
All right. It was a nice session. Thank you for sharing your knowledge and having us here. It was really a pleasure. So I'm waiting for any questions from our attendees.
Yeah, if
So,
there are any questions, feel free to ask. This would be a good time. Yeah. So I'm the last session of the day, right?
yeah, so we have only closing note left.
Oh, okay, cool. And I was surprised looking at it. There's like 10 tracks.
Yeah.
How that's awesome. I
So,
was like looking at all the great sessions out there, and there's a lot to learn, and
yeah.
it's really
There was a
amazing.
lot of sessions which we cannot say no, and there was unique sessions, right, which you can't find in here. So,
Yeah, so
yeah,
pretty much a lot of different topics, and I was like, wow, this is cool. You know,
yeah. Anyway, we are going to upload that to your YouTube channel. So even if somebody misses that, they can always come back and view that. So it's
yeah,
not like
that
in
is
attendee sessions, right, where if you miss that, it's missed.
yeah, that's cool.
All right.
Yeah,
So
it's great to learn more about it. Yeah, I think I have a few minutes to talk if there are any questions out there, or if just you know
yeah,
I didn't
maybe
dive
because
deeper into a lot of the different topics because
yeah,
we
I
only
know
have
it. This
1
one
hour.
is yeah,
But my whole goal here is to kind of give you an overview, because if you're like a developer like me, and I'm kind of like thinking, oh, I want to learn more about these data science, all these AI and all these different things, like what can you do right now to make it these machine learning models useful that is out there, and start integrating it to your application. And for us developers, as software engineers, it might make sense to say, let's start with something like, there's an API out there that can help us do object detection, or can help us do, let's start with that, or let's start with anomaly detection. All right, so anomaly detection in your application, you start integrating just little things, and that right there is, the value that we provide to the business is enormous once we start integrating it to our application. And that's the magic, and that's the key of getting the usefulness of these AI, and making sure that, you know and making sure that we they because they're what they call the AI winter, where everyone's happy about this AI and machine learning, and then at some point it's like, okay, the party is over. But in order to keep that party going, it's all about this, making sure we integrate it to these applications, make sure we can still use it to these business applications. And Onyx is the one that actually, for me, it's giving that value right there, right? Giving that opportunity to integrate, you know, without a lot of the engineering side of things, uh, and easily make these neural networks or these AI models portable and able to integrate it with our application, especially existing applications out there.
okay. One question from my side is right. We all are engineers. We all are working on creating softwares and all, right? So if I am going to venture into machine learning or data science, right, what should be my background? Should I be very good in mathematics or in the probability and statistics side of things? So is it a requirement, or is it a good to have one?
So the way I kind of see it is that if you're coming from a software engineering background, and you're already building software, right? Let's start incorporating some of these machine learning systems, right, into your application, to your existing application, even if it's just something simple as, natural, bots and those kind of things, right? Being able to add bots to your website, or not bots in terms of like collecting data, but bots in terms of interacting with your users, those kind of things. Um, you also start kind of experimenting on the different Azure cognitive services that is available out there, that start integrating it so into your application. One good way is to use some of the vision tools, the custom vision AI. there's and then once you start seeing that capabilities incorporated to your application, and then you can go deeper into, the way I kind of see it is like, let's start using applied AI, right? Apply it to our application. And then of course, once there's a need to get deeper into the the different frameworks and how to build these different different using these different tools, that's when start looking into some of the samples out there. And the good thing is, the Microsoft Learn has a lot of these examples and how you to get started. There is actually even on GitHub right now, um, that there's a data science tutorials that is available out there from Microsoft that are coming out, that are just free to use, if you just want to get started with you know with the with machine learning and all that, with data science. So math is not really required. It's just getting it started is always that initial phase. But integrating it to your applications, coming from the software engineering background, is the best place to get started and have usage for all the things that are out there.
So we have one question from one of the attendees. He is very new to ML, Azure ML, working with Python and Hugging Face transformer models. So have converted my model to ONXX and trying to deploy to Azure Container Services. What is the best way for debugging it?
I would recommend is um, so is it is a container. You can actually download that container locally on your machine and see if you can log in, or how in Docker you can do Docker exec and be able to get to the application inside. And that's one way you can debug. Their VS Code has a way to even get to that Docker instance. So if you create an instance of that Docker container service, right, locally in your machine, and be able to use VS Code to be able to uh, get inside that container service, or that container, and be able to debug right there, that is one way you can start understanding what's happening in the background. Or you can just get the files inside that that Docker image, right, and then download it locally in your machine and start running it. So it's how the Docker image is built is the key. Does that make sense? Because that would really help you understand what's going on, and see if there are errors out there. Sometimes it's just it couldn't find the file, and it would also show you the errors, what's going on.
All right. Thanks, Ron. So I think that's pretty much it. I think it was a pleasure having you here again. Thank you. And I hope you'll have your session in the next year's edition also. It's a pleasure hosting you.
Yeah, definitely. I think there's another question just came out.
What are good resources for learning? That maybe it is related to the previous question.
Oh, it's related to the previous question.
Yeah.
I would suggest, if you're learning more about the getting containers, right, building images, that really helps a lot. Because in a way of deploying an Onyx model, in integrating it to a Docker image, so you learn more about Docker images, how to get into, because at the end of the day, right, Docker images allows you to be able to ship from your machine to another machine and be able to run it as it is intended to be, or so getting that how to log in or be able to connect from Visual Studio Code, and there's a tutorial on how you can connect Visual Studio Code to a Docker image out there, and I think even just um, I think Microsoft Learn has an example of that too, so that's a good place to start.
All right, thank you, Don. Thank you, Ron. Sorry about that. And with that, we are nearing our time and wrapping up our sessions for day one. Anyway, thank you again for having me here. We'll catch you again.
All right. Later.
Bye-bye.
Thank you.
So with that, we have come to a close. So sorry about that. All right. So with that, we have come to the close of sessions for day one. We would like to thank you all who has joined, who has spared the time today and joined the sessions, as well as for the speakers who has delivered some awesome sessions on our track 9, sorry, and all the volunteers who work on the backstage, whose work on the backstage has brought this event or brought this day one events to you. All right, so we hope you learned something new, you had fun, and can't wait to see you back tomorrow for sessions on day 2. Until then, this is Amal signing off from day 1 track 9. Bye.